notion on what's the difference between the computers that we use every day in our lives and these new um, computers that are like coming um, in research and even like in industry, and which I think will come like the future of the computing world. Okay, so in a classic computer, and if you work regarding this, you will know that the basic of everything, of electronics and everything, is the transistor, right? So basically, with the transistor, you can have like different operations, like and or not, right? And then if you have like a group of those operations, of those gates, you will have different like functionalities. For example, you can make an adder or like something to make multiplications or different operations. And at the end, that comes into an integrated circuit, right? And that's how you build classical computers. That's how our phones are built, and that's also how laptops are built. So that's the basic. If you just narrow down, you will find that everything is about transistor. And transistor is just basically a device that works as a switch. It's something that let us like pass the electricity or not, right? That's it. It's a switch. It passes electricity or it doesn't. So why do we want like quantum computing? And this becomes because of transistors, right? So transistors are like the basic component of like classical computers, but they are also like the limit of classical computers. Why? Because right now we are creating like really tiny and small transistors, and of course, if you have like really tiny transistors, you can fit more transistors in your computer, so you can do like more switches, and that means that you can do like more operations, right? So you want to have a lot of transistors, and for that you want to minimize the size of the transistor. And transistors right now are really small. How small? Okay, so let's do like this comparison. It's kind of like a scale comparison, but you have like a virus here, HIV virus. It's around 120 nanometers, and the transistor is around 4 to 7 nanometers, right? So we're talking like the transistor is smaller than a virus. And if you put that virus in comparison with a red blood cell, you can see like this dot here, this blue dot, that's supposed to be the virus. So it's really tiny compared against the red blood cell, right? So imagine that if you can like, we can't almost see like the virus here. Imagine the transistor, we cannot see it anymore. So that means the transistor is really tiny compared like to the red blood cell. So it's like microscopic, right? So what's the issue with that, right? Because we are like making like really tiny transistors. So that means that we can fit more transistors in our computer and we can make like more operations. But there's a problem. They are like really small right now. So we are in like classic physics and physical world in which you cannot like make the transistor smaller. You can like there's a boundary there. So that's the limit that we're facing right now. That the transistor is so small that we cannot build it any smaller, right? So that's the limit, right? But remember, that's like the classical physics limit. The thing is that classical physics isn't like the whole story. We also have quantum physics and we also have quantum mechanics, right? So that's what is like quantum computing about. it is like, okay, if we are like facing a limit with transistors because of their size, because of the classic physics, so let's work with a different kind of physics. Let's move to the quantum physics and to the quantum mechanics world, which work different than the classical physics, right? So in quantum computing, the idea is that we will work with quantum mechanics, which by it works really different. Basically, quantum mechanics um, is just like the study of like really, really, really small um, items in the world, like atoms, electrons, or different particles. So that's quantum mechanics. Because when things are really, really, really small, they behave different. So like classical physics, as we know them, they cannot explain the behavior of those particles. So that's why people started studying these particles, and they became with quantum mechanics. So that's quantum mechanics. When you study like something that's really, really, really small, like a particle, an atom, or like electron, that's it. That's the physics. And they discovered that when you have like really tiny things like those, they behave really different, and they have like different properties. So the idea of quantum computing is start using those properties of those tiny particles or tiny atoms to our advantage, and to the quantum computing advantage, right? So yeah, quantum mechanics is basically just the science of the super tiny building blocks of our world, like atoms and the particles, right? So it's just like the science that is studying like particles. That's quantum mechanics, okay? And then quantum computing is the type of computing that will use the quantum mechanics to build hardware, right? To build like these machines, and this actually is like a quantum computing computer. This is one from IBM, is the most like famous one. They have been like pioneers in like this thing with the quantum computing, along with Google and other like companies in Europe. So this is like a really nice quantum computing in real life, right? Okay, so the basics of quantum computing are the qubits, right? We have bits in classical computing, but since we are working with particles and atoms and not only with electricity, we will start working with not bits, but qubits. We call it qubits because it's like quantum bits. That's the abbreviation, qubits. So let's see how qubits work. So in like the first years of like computers, you probably studied this. They used to have like these cards, and the cards were like the algorithms or the instructions, right? So the cards have different holes. They have holes depending on the operation or the algorithm that you want like to do, right? So in these cards, the hole was a one, and if there was no hole, it was a zero. That was how it was read. So you pass like the card through the computer or through the machine, and it will read a lot of like ones or zeros, because it was like just detecting whole or no whole. Okay, so that's a bit, one or zero, whole or not whole, right? Then we leverage that with the transistor, and now we have, okay, if I have electricity, is a one, but if I don't have anything, it's a zero. So that's another way to represent bits, and that's the way that we do it nowadays. It is electricity or not electricity, and it would be one if I have a signal, or zero if I don't have anything, right? It's like one if it is on, or zero if it is off. We could also represent bits with a magnetic field. So imagine like you have like this magnet. So you can say, okay, this pole is going to be 1, and the southern pole is going to be 0. You can do exactly the same. You can represent it in this way as well, because at the end it is just like one state or the other is just 1 or 0. Okay, so now let's imagine that we want to represent the bits with magnets, right? So we have 1 or 0. It is north or south pole, and that's it. But what about if we have, instead of having only like that magnet, we have, let's say, like a sphere. Imagine that we have a sphere, and inside we have like the magnet. So the north pole will be 1, and the south pole will be 0. It's still the same, but now we have a sphere, which means that maybe we have more space for something else, right? That's where qubits come from, right? If I have a sphere, I can say, okay, north pole is 1, south pole is 0. But what happens if I just hit or click in the middle of the sphere? What does that say? Is it like a 1 or is it like a 0? If I have like a sphere, right? And if you have like a sphere, you have like a lot of points, right? Which you have to ask, okay, is this a 1 or is this a 0, right? And that's like, this is like when everyone says, oh, it's both, or like in qubits, they can be both at the same time. So actually, that's kind of like a simplistic way to say it, because it is not both actually, right? Because it is not 1 and 0. It is not here and here. It is like in the middle, right? So it is a little bit of 1 and a little bit of 0. It doesn't mean that it is both, but it could be both, right? It's kind of a mix of 1 and 0. So are they really both like at the same time? That's the simplistic way to say it, but it's actually a probability, okay? A probability of being 1 or 0. And of course, if I have like the sphere and I know like north is 1 and south is 0, and like I point near to the 0 pole, um, it will be like, it will have like more probabilities to be 0 than 1 because it is near like the 0. So imagine that our qubit is planet Earth. So in the north we have 1, and in the south we have, in the south pole we have 0. So if I'm in Chile, right, I have more probabilities of go to the south pole, right, than the north pole. But if I am in the, I don't know, in Russia, I'll probably have more probabilities to go to the North Pole than the South Pole. So it is the same. So imagine that it is the Earth. It doesn't mean that you are like in the north and the south at the same time. It just means that if you could travel, you will probably travel to the one that you have like nearest to you. So at the end, it's a probability. And this is like the definition of qubit. So a qubit is a probability of the state of being 0 and 1. And this is actually like the notation that we use for that. And alpha and beta, they are like the probabilities. So if you have something that is near to 0, you will probably have alpha being, I don't know, 0.8, right? And maybe beta is 0.20, which means that you have like 80% of those like to 0 instead of like going to the north to be 1, right? So qubits is not like they are the same. They are like both at the same time. That's like really simplistic. It's actually a probability of being 1 or being 0. And once like you measure, and I'll show you how it is done. But once you measure and you check at the end, where is it? It will be 0 or 1, right? But in the middle, while you're not checking, it can be whatever because you have a probability, right? You don't know yet. You need like to measure to see did it did it go to the south or did it go to the north? But you already know that the probability was that it was going to go to the to the south because it was 90% probability, right? But you only have like the probability. It's like winning the lottery. You have like more probabilities or of not winning the lottery, but you might win the lottery, maybe. So maybe if I'm in Chile and then I'm measured, maybe I just ended up in the North Pole because it was like a small probability, but it was not zero. It was like maybe 10%, but it happened. So that's how qubits work, right? It is not just something defined. It's just like it might be one or the other with certain probability. Okay. And how do we build this uh, in the real life? How do we make qubits? Um, so as I mentioned, if you are working with quantum computers, we have to build qubits, and the base for that is quantum mechanics, which means that we have to work with really tiny things. So we don't use transistors anymore because they are really big for the quantum mechanics. So we start using particles or atoms or electrons or photons. We use those kind of elements, right? So how do we build qubits? We have like different ways of building qubits, and I will focus in the atoms traps that are really used today. So basically, we take an atom, right? And the most used elements are these that we have here: rubidium, cesium, strontium. You take one atom of that kind, and if you remember from your like maybe physics or chemistry classes at high school or at university, like the electrons and the particles in general, the atoms, they have something called a spin, right? So the spin will work in terms of the magnetic field that is applied. So like the spin is basically the direction, right? So it can be like this, like this, like this, like this. It can rotate 360 degrees because it depends on how like the particle or the atom is behaving against the magnetic field in your environment, right? Or the magnetic field that you're applying. So you can change that, right? So people decided that this was a good idea for qubits, right? Because like you have like a sphere, and basically you have like a spin, which is kind of, let's say, like the direction, which will be kind of this arrow, and let's say that is a pointer. So you can make that spin or that arrow goes like to any direction. So that means that you have different probabilities in a lot of possible states, um, and you can control that. You can control that applying different magnetic fields or lasers. You can change how the particle is rotating. Okay, so this is like the base for why we are using atoms. Is because we can manage how the spin is pointing, right? Okay, this is duplicated. Okay, so first step, we have an atom trap. Okay, so what's this? So basically, I already have my atoms selected from like one of the elements that I mentioned before, and I will what I will do is like a trap in which I need to gather like the atom, and I need like basically just like to trap it. Like I do this with lasers. Let's say you put lasers, you can like mount the experiment, and with the lasers, what you do is that you make the atom stays there, is still. Okay, so you have your atom now like in a trap, like an animal. So imagine like if you're like chasing like a mouse, you want to trap that mouse and you want like to put it in a cage. So it is the same with the atom. you want to put the atom in the cage, you do that with lasers, and it's usually you put like lasers and the atom will be in the middle. But there are like different configurations on how you can do this. Okay, and you do this for a lot of atoms. So you have different cells with a lot of atoms. So that means that you start having a lot of like qubits, right? Because one atom will be kind of like a qubit, so you can store information in that atom. But if you want to like make an algorithm, you need a lot of atoms. So you need to repeat this process, right? After you have like your atom is like trapped, you will start modifying the state of the spin. That means that you start rotating your atom, let's say, right? You start making it change the spin, and you do that through a laser. So you need to calibrate the laser, of course, according to the element, according to how you want like the spin to be. But basically, you hit it with a laser, and that interaction will make the spin modifies. So you can start modifying where the spin goes. And once you define what you want and the state that you want it, and then you hit the laser and it is ready, the spin is right in the position that I wanted it to be, you will need to measure, and that's the most important part. You'll need to measure to see at the end, okay, if the spin was towards, let's say, the south, once you measure, it will have more probabilities to go to the south pole than the north pole, right? So probably when you measure, you won't see the spin in this way. You will see it like a zero, because when you measure, they collapse. This means that they go to zero or they will go to one according to the probabilities. Here, like in this visual example, we have like the spin was going more like towards the south pole. So once we measure, it will probably be zero. So when I measure, and measuring, it means I'll apply another laser to measure, and it will emit light. If it doesn't emit light, it's a zero. If it radiates and emits light, it is a one. So that's how you measure qubits. And at the end, you see light or not light, and that's one or zero, right? But in the middle of the process, the qubit could be like in a different state, right? In different probabilities. Just when you measure, it's a zero or a one. And that's why you can store like more information in qubits than in bits, because it just collapses to 0 or 1 at the very end of the process. In the middle, you can have like different states. You can have like the spin in different directions. And then when you measure, you can have like one of the possible combinations, right? So that's basically how we are like building qubits right now. And of course, this is just atom trap. There are like other techniques that are used, and also you can do this not only with atoms, you can do this also with photons, which is like with light. So it works a little bit different because you measure, you don't measure like the spin, you measure like the phase. But it's kind of like the similar idea, and actually like the atom trap is one like of the most like famous techniques that is used. But yeah, it's like the basic is like for qubits, you need to start thinking different. You don't think anymore about electricity. You need to think about particles, right? How particles behave and what are like the properties of the particles that I can use. That's how qubits work. And why do we want quantum computing if we have such great computers right now? Well, basically, because we can leverage cryptography, for example, because cryptography, you know, that implies a lot of mathematical operations that are complex. And if you have these qubits that they can store more information because you can modify them and have like more states, you can do more mathematical operations with qubits than bits. So you can leverage the cryptography. You can also work in new materials development and new medicine development. Since you are working with particles and atoms, that's pretty similar on like to how like the materials work and how like the real world in the biology works, right? Because our biology and the materials basically they work under quantum computing, quantum mechanics laws, because we are like form or of like really small things like atoms. So if you are already working with atoms, that makes it easier to start developing materials or medicines because you have like a more similar way to compare the behavior, right? Also you can improve database search because again the operations, the mathematical operations that you can leverage here, and optimization, since you can start like making more operations with qubits than bits. So that's why we want quantum computing. And I would say especially like the part of like materials and medicine is really important because right now with classical computers, what we do is try to simulate what the atoms are doing and how they behave. But if you already have a computer, if you get a computer that is already working with atoms, you don't have to simulate. You can actually like do the real experiment. So that will make it easier to create new materials and new medicines. So that's why I think quantum computing is like really important. There's a lot of like work to do here in this area. This is just like in baby steps, but I think like the last 5 years we have like been making a lot of progress in this field, and I think it's super interesting that people who are working in computing in programming, they know and they have the notion about quantum computing as well, because maybe in like a couple of years you will see quantum computers more often than you can imagine. So I think it is good to start having like these concepts in mind and like the notion on of how it works, right? And it is not like a sci-fi movie anymore. It's like reality. And yes, I think that's from my side. I have here like my LinkedIn if you want like to discuss more about like quantum computing or topic. Um, yeah, you can reach me out there. Thank you.
Thank you, Karen. It's such an amazing topic, right? Such a hard topic, I guess, for those who are not really familiar with that. So, but guys, let's keep this conference interactive, and please reach your questions through the chat. So the first question is going to be mine, Karen.
Mhm.
Can we kind of summarize all of your presentation with one small question? What are the main advantages of quantum computer compared to classical computing,
Mhm.
in your opinion?
Um,
Yes.
yeah, I would say the main advantages is that we changed totally like the hardware, the physical hardware that we are using, and that we
Mm,
start using
okay.
particles. And using those particles will give us like more advantages on making different calculations or more calculations. It changes like the whole paradigm that we use with classical computer. Now in classical computer we have like the size limitation, and with particles we don't have that limitation anymore. So I think it opens the door for making more things, especially with materials and medicine.
Perfect. You know what? I've read in an article that changing to cha- changing from classical computing to quantum computing, it is going to be a big breach in security, in cybersecurity, more precisely. So,
Yeah.
what could you tell us about that? Did you mention really briefly about cryptography? But what else?
Yes, like one of the advantages it has like the quantum computing is that since you have like the bits and you can like save more information, you can start making more calculations with the qubits instead of like the bits, right? So all of like our like cybersecurity right now is based on a specific calculations, usually like prime numbers calculations, because they are really hard to get in a classical computer. You need like basically just like to have like brute force and try a lot of times, infinite time of times, right? To get like the right answer. But with quantum computers, it doesn't matter. You can make like the whole thing of like the calculations, and it will do it in a like time that is dangerous. Why? Because for example, like a classical computer might take, I don't know, like it might take 80 years for a classical computer to find like the right prime number for like encryption key, right? Because of like the
Uh-huh.
calculations. But for a quantum computing, it can be, when we hit like the level of the quantum computing we want, it can be like, I don't know, like a couple of hours or maybe days in the worst scenario. So imagine like you can start breaking things and encryption keys just by running the calculation in a quantum computing for a week, and then you have like your the encryption key. And in a classic computer, that would take like 90 years. So we were like thinking that we're safe because no one is going to run this during 90 years to like discover the encryption key. But now if you have like a quantum computing, is dangerous. That's why we have to start changing the algorithms that we use for cybersecurity, for encryption, for cryptography, because now we have quantum computing. So now you have like to make it hard for quantum computing as well.
Of course. So I guess that's part of the answer of the first question that we have here on the chat. That if I translate it correctly, it says what kind of complex problems can be solved by quantum computers more in a more efficient way than in a classic computers. Maybe you can tell us two or three more examples that you see every day.
Yeah, for the use of quantum computers, right?
Yes, yes.
Yeah, I like the cases that I've seen the most outside cryptography is like for chemistry, for creating new materials, for example. When you create a new material, it's really hard to say if that material is going to be stable in the real world, if it is going like to persist or to be able, like if you're going to be able to make like those interactions. But in quantum computing, you can make those calculations in a really more like easy way because you are already working with the atoms and the particles and everything. So it gets easier to say in a quantum computer and make all the calculations to know if the material is going to exist in real life or not than in a classical computing. So that makes you like that opens the door for you to start like designing new materials that you can use for different things, because you can have like a different kind of plastic, I don't know, that is like more like environment friendly, and you can check if you can create that or if that can exist in real world through the calculations in a quantum computing. And it is the same for medicine, like the other example. When you are like trying to treat a disease in your body, you need to know how the compounds in your medicine are going to interact with your body. It's maybe specifically like the proteins. That's like a problem right now because you need to know how like the protein falls and what's like the, I don't know, like the form of the protein. And that's like a lot of calculations for a classical computer. But in a quantum computer, it gets a little bit easier. So you can make the calculations and you can decide if like a medicine is going to work because it's going to interact with the right thing in your body, with the right particle in your body, and it's going to attack the disease. It's easier in a quantum computing than the classical computer.
Okay, thanks a lot. We have another question. So it says literally like that. current quantum computer solutions are somewhat resource intensive. What could be the next advancement that will help us grow in this field?
Mhm. I would say like there are two lines. This there is like the hardware line and the software line. And with the hardware, what we have is that yes, it is like resource intensive, and you have like to be in a really controlled environment. So for example, for the IBM one, the cooler system is like really expensive. I think it has like the lowest temperature in the universe, that cooler of the quantum computing. So it's really intensive, and also it costs a lot of money. So I think like we need like to start thinking a little bit on how we can start making hardware for quantum computers that is scalable. So that because you cannot have like that cooler that is like millions of dollars expensive. No one will build that, right? So maybe I start like thinking on what's like the way to make the hardware scalable. And the other thing is like errors in quantum computing right now are an issue because you have a lot of errors since we're working with particles and atoms. Like anything in like in your environment can make noise to that atom, so it can change the like the spin, for example. So you will get wrong information. So in software, we work with quantum error corrections, and there are like some algorithms that try to detect the error and correct it. So I think like the other line is trying to make good algorithms to detect and correct those errors so that you make sure that like the quantum information is like it's right, that you are like making the right calculations and everything, because you are making sure that like you're like catching all the errors and you're correcting them. So I think it's like hardware and software both.
Okay, perfect. Thanks. Another question is, do you think we will have quantum computing based security and encryption algorithms?
Yes, maybe not right now, but I think we there are people already working on this, and there are like some papers on like security based systems, right, that are like being implemented in university labs where they work with quantum computers. So I think like yes, we would have them, but not right now. Like our entire bank system is based on, on classical computers. So I would say maybe we have to wait like other like 20, 30 years to see like the change in the whole encryption and cryptography thing in our like lives, right? They exist right now, but it's pretty limited. It's mostly for like research purposes.
Yes, so of course, I guess we have to first fix the hardware and software issue, right? And after
Mm-hmm.
that, we can, improve
Yeah.
the security,
Yes.
like with all new technology, right?
Yeah. Yeah. One step at a
And
time.
do you think the quantum computing simulators, like the ones IBM is trying to popularize, could enable quantum computing accessibility?
Yes. Yes. For sure. I think like quantum computing simulators are a way to bring this new technology to people and let them know that quantum computing is a thing, that it exists right now, that we are researching on it. And it makes people also less afraid about quantum computing. Like when someone says AI, they think about like Terminator. It might be like the same thing, right? Quantum computing, it might sound like really catastrophic for someone that who doesn't know anything about it. So it is a good way to bring like the technology and show people what is this really, and also like to make people start learning not only the new generations but us that we already started with the classical computers and start understanding what is quantum computing. And I think like also IBM and Google, they have like good programs, especially IBM, which is the one that I know that I have like the certification. They give you access not only to the simulators, but you can access like real quantum computing from your desktop. It is like a quantum cloud. So they give you access to a real quantum computing, and you can run things there. So I'm in Costa Rica, and we don't have like a quantum computing here right now. But what I can do is, if I want to research on quantum computing, I can use that quantum computer because I know I can connect to the quantum computer and I can send algorithms or information. So I think that's a great thing for enable accessibility.
Perfect. So now that our friend Anand is mentioning IBM, I would like to ask you, what other companies are leading this field?
Yeah, I would say, yeah, IBM, Google for sure also has is leading. There's a company in Europe, Terra Quantum is the name. They are already offering services with quantum computers. Actually, they hire quantum engineers or quantum developers. So I would say Terra Quantum is also a really strong company. And yeah, maybe like those three. Intel, they also have their own packages to work with quantum computing. So I would say those companies are really right now um, leading the way of quantum computing. And uh, additionally to that, there are like many Chinese companies and research labs that are like doing a lot of progress in this. So Asia and specifically China is a really good reference on like the advancement of quantum computing.
And Latino America, no? No, nothing.
In no, like Latin America, not yet.
No, not yet. Exactly,
Not
not
yet,
yet.
not yet.
Not yet.
But soon.
Not yet. Yes, we need more people like you, Karen. Okay, so we have here another comment. Hi, Karen. My field is robotics. Do you think the integration of qubits will allow robotic systems to process large volumes of data simultaneously, optimize routes, and make complex decisions in real time?
Hmm. So I think like for process large volumes of data, optimize routes, and make complex decisions, definitely quantum computing can be helpful on that. I think like we have a big gap yet in like how like thinking about a quantum robot. That would be hard right now because like we are struggling with having like a quantum computing computer because of the cooling, for example, right? Like all the things that it takes in the hardware level. So I don't think like we are ready yet, and we like need more years to have like robotics, maybe robots or like arms that work with like these atoms. Because hardware is really hard in quantum computers. But I would say that robotics can start using the results of quantum computing calculations, right? So if you have a robot and you have a way to send the calculation to the quantum computing and get those results, it will be kind of similar, right? Because you will get like the speed of the calculations and the optimization and everything, but you don't need to process them. You don't need like to have your robot in a cooler or a freezer, right?
Yeah, sure. Oh, okay. We have another question. You have told us some some kind of answer. So if I may edit it, uh, I could translate it like how quantum computing affects areas like artificial intelligence.
Mm.
How
There's
how
yeah
how is it going to be? Tell us a little bit more.
yeah there's a whole area, and I have also like a deck on that. I can later show you, but there's like machine learning, quantum machine learning, and it's like already like a research area in which you join AI with quantum computing. So what that means is that you start kind of like running AI in a quantum computing, but you have to change the algorithms a little bit because like the algorithms in a quantum computing computer, they work differently. But the advantage is that machine learning takes a lot of like time for training, for example, and for processing, you can start saving that time in a quantum computing. So of course you need to change the way algorithms are done because you have like to change everything for it to work in a quantum computer. But if you get it, like you make like the transformation, you will get probably like an optimization on time and resources because probably your training will be like less expensive than in a classic computer. And also you can start also working with AI um, for complex problems like the ones in like biology or chemistry.
Okay, perfect. Thanks a lot. So we have one thought from our friend Anand. He's waiting for the space, um, quantum computing, something in the space, and need less cooling system maybe. What do you think?
Yeah.
Is it feasible? Is it attainable that we can have something in the space?
No, I feel like we need like to bring, yes, we probably would need to start like using some space things because the cooling systems that we're using right now are crazy. I think like the most
It is
crazy
indeed.
thing is like, yeah, like the hardware that you need for a quantum computing. That's like the challenge right now, because you need a really controlled system. So maybe, maybe it would be easier to build a quantum computer in space than in Earth.
Oh, that's for sure. So listen, Karen, we have some time left. What about if you tell us what kind of abilities we are needed? You know, what kind of skills are needed uh, to be in the field of quantum computing? You know, what do you think is the first step for us as students to become part of?
I would say you need to be minded because probably you need like to kind of forget a little bit on how like classic computers work and be open
Oh,
minded like to change like the algorithms and the way it works. I would say you probably need like some understanding on a little bit of quantum mechanics. You don't need like to be an expert, but if you get like the basics, understand like the basic properties, is really good because that's the way quantum computers work, right? That's the base for quantum computing. So you need to understand the concepts of like the basics properties like entanglement, superposition, and superposition in quantum mechanics. So you need to study a little bit of that, I would say. If you want like to work in hardware, you need to study a lot of physics and optics and chemistry probably. If you want to be in software, you don't need that much, but maybe yeah, like the quantum mechanics and also linear algebra. Believe it or not, it is important. It's really important in quantum computing because like the notation that you use, it's everything based on like linear algebra and everything is matrix multiplication. So if you want to understand like the algorithms and how they work, you need to know what is like a matrix, how they operate, and everything. So I would say yes, linear algebra is really important and a little bit of quantum mechanics.
okay, guys. So check your notes out again. You know,
Yes, basically.
of the first semester, right? Of the first
Yes.
semester of your career. What impact could quantum computing could could have or may have in the global economy?
Well, I think it could be huge once it's more developed because if companies start like doing things with quantum computers, you will start having like data centers, but like with quantum computers. That would be really cool. So imagine like everything that we have right now, but like with quantum, right? And probably you will have like more development, more scientific development. So maybe you have like new medicines, you have new materials, so you have like more things. So I think it could be really good for the economy. Of course, we have like to be careful on like the resources that we're using for building the hardware. Of course, you don't want like to be bad with the environment, so you also have like to be careful with that. But I think it should be good because we can start like leverage a new industry. So imagine like having new kind of company that provides quantum computing services. So you will have like new jobs, for example, new roles. You can hire quantum engineers. So it will open also like the possibility to have like a new industry in the world.
Okay. This kind of, simulations can be processed by a supercomputer, right? So is it a big difference between supercomputers and quantum computers? It is a huge difference, right?
Yeah, it is still a huge difference because like a supercomputer is still classical. And what happens is that a supercomputer is like really fast and it can make a lot of operations, but it's still working with bits, it's still working with electricity, with transistor, like the one and the zero. So at the end, you'll have like the same limitation. At some point, you cannot make your supercomputer faster or bigger because you have like the
Mhm.
physical limitation. um, so yes, like supercomputers, they are like a premium version of the classical computers, but
Uh-huh.
they are still different. And we have to also understand that like quantum computing will not replace classical computers. That's not going to happen. Like quantum computers are going to live along with classical computers, but we will use quantum computers for other problems that we cannot solve that well in classical computers.
Oh, that's cool. Perfect. So we have another questions. Another question. I'm sorry. It says, data centers themselves are forcing companies like Meta to look for alternate power sources, including revival nuclear power plants. Wondering what QC, quantum computing, data centers would trigger. Any thoughts?
Yeah, I would say like definitely power sources. Power source is going to be like a thing that we have to start thinking, and I would like to start thinking about this um, now that we are on time and that we don't have like quantum computer data centers, because yes, like a quantum computer needs a lot of energy, like the hardware needs a lot of energy because you have like to be really careful with your environment, and so you need lasers, cooling systems, and everything, and it is a lot of energy. So if we have like data centers with quantum computers, that will be probably be like a huge consumption. um so yes, it's dangerous, and it is like the same with AI. AI is making like a big footprint in the environment because it consumes a lot of energy. So I think it could happen the same with quantum computing. We need to, that's why we need to leverage the hardware, and we need to start thinking about making it more scalable, and maybe thinking about hardware that will be feasible in the world without I don't know, without leaving us without any resources in terms of like how you consume the power for the quantum computing, because yes, it's crazy like the amount of energy that it will need a data center of quantum computers.
Yes, for sure. So, Karen, how far are we to have a quantum computer for general use? Is it going to be in this century? What do you think?
I would say like yes, and like in this century, we will definitely have like quantum computers more available to us, and it will be like more normal to hear the quantum computer, and like that like some company is using quantum computers for this and for that. I would say it's more. it's going to happen. But I won't think that we will have like a quantum computer in our homes. I don't think that's going to happen. I think it will be like for maybe it happens that like like in some universities in our countries we could have one. Maybe we could have like quantum computers if you're making research in medicine, in biology, in chemistry. You can access them easily, but I don't think that it is something that will have like all the people having their quantum computer or something. No, I don't think it's that the way. I think like in this century we will have more access to quantum computing. But I don't think it never gets like to, oh yes, I have my quantum computer at home. No, I don't think that's going to happen.
Okay, well, we have reached the end of this conference, but we just a final thought, please. What learning resources would you suggest for someone starting out? And with
Yeah,
that, we could conclude.
Yeah, I feel like if you want like to be like more like hands-on on maybe start like programming your own quantum circuits and everything, which quantum circuits is the word for algorithms in quantum computer. I would recommend Qiskit from IBM. They have like online platform to learn quantum computing. They have like a electronic book there with exercise, and you can run code. That's really hands-on, and sometimes they open like the certification as well. If you want, I got like the certification, and you learn a lot about like the software in quantum computing, how qubits work, and how you can program them. And also Quantum World is like the other certification that I have. They have like different levels of certification. They give workshops online and also in person in some countries. So I would recommend that one. And some books. There's a book, Nielsen. I think it's like Quantum Computing by like Nielsen, or Quantum Information by Nielsen. If you look that one, it's like a really good base to start understanding about like quantum mechanics and a little bit of linear algebra, and yes, like this concept. So yeah, I would recommend those three. Although I think Google also has something with their like kind of also like their site with books and everything. Yeah, those.
Okay, so a big thank you to Karen for sharing such a valuable insight with us today. If you want to learn more about Karen, she share her LinkedIn. We
Yep.
are going to paste it on the chat. So let's give her a virtual round of applauses for her amazing presentation. And thanks for your time, Karen. We hope to see you again
Yeah.
in
Thanks,
IEEE
Christian.
conferences.
Yeah.
Thank
Thanks,
you.
Christian, and thanks for the invitation, guys.
Sin más, pasamos con Roberto. O Fátima, ¿se encuentra por aquí Fátima? Fátima Montano, ¿se encuentra por aquí? Roberto.
Hola, ¿me escuchan bien? Perdón, estoy teniendo problemas con el audio, creo.
Sí, te escuchamos, Fátima. Buenas tardes.
Buenas tardes. Ya en un momento activo mi cámara, pero
Claro.
Bueno, estoy teniendo problemas con mi cámara, así que creo que será sin cámara esta vez. Em, gracias, Cristian. Solo confirmo si me escuchan bien, por favor.
Sí, sí, te escuchas bien, Fátima.
Súper, gracias. Bueno, para la moderación creo que sí sería en inglés, ¿verdad?
Me parece que sí, hay muchos extranjeros,
Ok, gracias, gracias.
mucha
Ok,
audiencia. Yes.
good morning, afternoon, or evening, everyone. Welcome to the session of the 24-hour global event organized by the Distinguished Visitor Program of IEEE Computer Society. My name is Fatima Montano. I'm student representative for Region 9, Area Capana, and it is my pleasure to moderate this exciting talk. Today, we're honored to have Dr. Eric Castellanos, a distinguished scientific entrepreneur from Mexico, as our speaker. Let me share a bit about his background before we get started. Dr. Castellanos holds a Doctor of Science degree in electrical engineering with a specialization in computer science from CIMSTAB. His research focuses on artificial life, but he has also contributed to natural language processing, multi-agent systems, cognitive architectures, and learning classifier systems. He is the founder of Ideas XT, a company dedicated to developing technology solutions for businesses, academic institutions, and government agencies. Currently, he serves as Director of Research Center. Within IEEE, he has held various volunteer roles, from student leadership in branches and chapters to management positions at the section level. He is now chair of the Distinguished Visitor Program Committee for IEEE Computer Society in Region 9. In this session, Dr. Castellanos will introduce us to the Distinguished Visitor Program, DVP, of the IEEE Computer Society. He will highlight its key features and discuss the benefits for both members and speakers. I am sure this will be an enriching session. Without further ado, I'll give the floor to Dr. Castellanos to share his presentations. Dr. Castellanos, the stage is yours.
Thank you, Fatima. I'm going to start sharing my screen. Just give me 1 sec. I believe it is now showing my presentation, right?
Yes,
Okay.
yes.
Okay, thank you. Just a quick notice for the audience. I will gonna give this talk in Spanish, just for sake of diversity. But if you have any questions, I can read it and reply to you in English. Unfortunately, I don't speak Portuguese, so if it is in Portuguese, please either Spanish or English. From now on, I'm gonna switch to Spanish. Thank you. Muy bien, gracias. Gracias a todos. En esta sesión, como les estaba platicando, voy a platicarles de qué se trata el programa de DVP. Había un pequeño detallito de biografía. Ya no soy el encargado del programa de DVP en Región 9. Lo fui el año pasado. Ahorita es Víctor. Solo faltó ese detallito, pero no quería colgarme la medalla que no me pertenece. Pero muy bien, pasando al programa DVP. ¿De qué se trata? Bueno, vayamos primero por una definición. DVP son las siglas en inglés de Distinguished Visitors Program, que es el programa de visitantes distinguidos. Se define como un programa que acerca a los líderes tecnológicos e innovadores de primera clase o mundial para que estén disponibles para los capítulos profesionales y estudiantiles de la Computer Society para realizar visitas en línea y visitas en persona a las instalaciones del capítulo. Como ven, por ahí repetí varias veces la palabra visitantes, porque esto es algo diferente de otras sociedades dentro de IEEE. En otras sociedades, el equivalente de este programa se llama Distinguished Lecturer Program, que son oradores distinguidos. En este caso, por razones específicas, en Computer Society se quiso que fuera programa de visitantes distinguidos, y lo resalto ya en negritas. ¿Qué es esta diferencia? Bueno, no se trata de solo de ir a algún lugar físicamente y platicarles sobre un tema de tecnología muy actualizado, muy de primera mano, sino además tener a la persona que sabe o el experto de este tema, tenerlo en, en un lugar específico, físicamente poder convivir con él, platicar, irte a comer con él, hacerle una pregunta, charlar, ampliar tus redes de contacto a través del contacto físico o uno a uno con los líderes mundiales. Entonces es algo que distingue a este programa de otros programas similares dentro de IEEE. Entonces, para que tomen en cuenta esta característica y el por qué se llama así y por qué que queremos seguirlo nombrando de esta manera. ¿Qué se abarca con el programa de DVP? Bueno, hay una gran variedad de temas. Cada año se selecciona un nuevo grupo de visitantes distinguidos y además los temas y se revisan y actualizan los temas de años anteriores. ¿Por qué se hace esto? Bueno, es para garantizar la vigencia, la relevancia y la excelencia continua del programa. Una pequeña muestra de los temas tratados recientemente es la inteligencia artificial, los gemelos digitales, el aprendizaje automático y el procesamiento natural del lenguaje. ¿Significa que nada más son estos temas? No. Esto es una muestra, por un lado. Por otro lado, se trata de tener un conjunto diverso de temas, de temáticas que apliquen que sea de interés para la membresía de la sociedad de la computación, además de que sean temas de actualidad, temas que al día de hoy estemos encontrándonos en el día a día o que sabemos que vienen en el futuro, porque no nada más estamos con la actualidad, sino echándonos un vistazo al futuro. Entonces, a través de estas visitas distinguidas se pueden abordar una gran variedad de temas. Dando una panorámica muy general de las informaciones relevantes de este programa. Para empezar, cualquier asunto hay que dirigirse por correo electrónico a dvp@computer.org. El programa en general va del 1 de enero al 31 de diciembre, es decir, año calendario. Cada año calendario hay un nuevo programa de DVP. No significa que lo anterior se deseche, significa que la forma de aplicar al programa de DVP va por años calendarios. El periodo de nominación en el año es fijo, así como el nombramiento, es decir, las personas que fungen como visitantes distinguidos se asignan, se candidatean una vez al año, el nombramiento se da una vez al año en unas fechas específicas que más adelante les diré, pero hay que estar atentos de estas fechas si les interesa, por un lado, formar parte del catálogo de visitantes distinguidos y por otro lado también hay que tener en cuenta cuando se actualice esta información en caso de que quieran llevar un visitante distinguido a sus diferentes capítulos. ¿Qué es lo que ofrece este programa? Bueno, ofrece hasta $1,500 americanos para el viaje de ida y vuelta de los visitantes distinguidos desde su hogar hasta la ciudad del evento. Es decir, si yo estando aquí en México y fuera un orador, un visitante distinguido, que no lo soy, hago la aclaración, y alguien me mandara llamar de que le interesara de Costa Rica o de Egipto, a mí, si se cubrieran todos los aspectos y si hiciera, hubiera una aprobación, a mí la Sociedad de la Computación me pudiera patrocinar con hasta $1,500 para mi viaje desde México hasta el país al que voy o a la ciudad a la que voy y poderme regresar. Sin embargo, esto es importante aclararlo para todos los voluntarios que tenemos por aquí, los capítulos locales son los responsables de los gastos locales. Es decir, siguiendo con este ejemplo, yo llegaría a Costa Rica y una vez que llegué al aeropuerto de Costa Rica, el taxi, digámoslo así, que me saque del aeropuerto y me lleve al auditorio donde fuera a dar mi primera charla o mi primera visita, ya estaría corriendo a cargo del capítulo local. También la comida, el hospedaje y otros gastos que vamos a detallar un poquito más adelante. Los capítulos pueden pedir o solicitar tener oradores, visitantes distinguidos, una cantidad ilimitada de veces si son en línea, pero no pueden pedirle, si es una visita presencial, no más de veces al mismo visitante que vaya no más de 2 veces al año a la misma ciudad por año calendario. Y no lo puse aquí o tal vez lo menciono más adelante, no puede pedir más de 3 visitas al año en año calendario si son presenciales. Sin embargo, si son visitas en línea, puede ser una cantidad ilimitada. Las aprobaciones, cuando que ustedes soliciten a un visitante distinguido, como todos los que han estado dando charlas durante estas, ahorita ya perdí la cuenta, pero ya van como 12 horas, 16 horas, no sé cuántas horas llevamos. Si quisieran pedirle a uno de estos visitantes distinguidos que nos diera una charla a un capítulo y es en línea, entonces el acuerdo es simplemente entre el capítulo local y el visitante distinguido. Se llega a un acuerdo, fechas, la plática, el tema, los medios, todo, y ahí termina el acuerdo, se sucede el evento. Sin embargo, si están solicitando un visitante distinguido que vaya en persona a su capítulo, ahí primero deben de ponerse de acuerdo con el orador distinguido por cuestión de fechas, necesidades de las pláticas, todos los temas. Y una vez que tienen algo tentativo, entonces se solicita y se pide la aprobación del comité de visitantes, del programa de visitantes distinguidos con anticipación. Si no está aprobado por este comité, el reembolso no puede suceder y tiene que ser con anticipación. No puede ser, oye, tuve un visitante distinguido hace un mes, ¿me ayudas a cubrir los gastos? No, así no funciona este programa. Son datos en general. Ahora bien, ¿quiénes son estas personas a las que podemos solicitar que vengan a darnos alguna plática interesante y conocerlos y hacer networking con ellos? Bueno, son personas que se nominaron de manera en algún punto del año anterior o anteriores, que esta nominación está abierta durante un periodo de semanas que va mediados de junio hasta fines de agosto. Prox, hay que estar revisando la página nada más para saber la fecha exacta. La designación de los visitantes distinguidos para el año siguiente y la presentación para visitantes distinguidos se realizan en diciembre, es decir, durante estas 10 semanas se nomina, se evalúan y por ahí de diciembre ya se dice, ok, para el siguiente año se incorpora a nuestro catálogo de visitantes distinguidos tal y tal personaje distinguido, expertos en su área. Entonces, por ahí de diciembre, enero, la página se actualiza y ustedes ya pueden ver la información nueva de los visitantes distinguidos que pueden estar, o si ustedes ya quedaron como un visitante distinguido, si es que desean aplicar. Nuevamente, cualquier recomendación, sugerencia o otro comentario relacionado con el proceso de nominación, por favor hay que mandarlo al correo de dvp@computer.org y allí él responde el encargado del comité o alguien del comité. Ahora bien, ¿cómo es el proceso? Quisiera, dentro de este Día del Voluntario, que le estamos teniendo este evento dentro del marco del Día del Voluntario a nivel mundial, eh, quería platicarles acerca de cómo es el proceso de solicitud de visitas, porque hay que seguir ciertos pasos, todos son importantes, pero esto es por la buena administración tanto de ustedes como un capítulo local que estén hospedando algo, como en apoyo y en beneficio del visitante distinguido para que tenga una buena visita, así como de llevar buenos términos con el programa en sí mismo de la Sociedad de la Computación. Entonces, deben de saber esto. Los capítulos pueden organizar hasta 3 visitas presenciales de DVP por año. Ya quedamos que si son en línea pueden ser las que sean. Por favor, no pidan más de 3 visitas. Es decir, sí se puede y por ahí pongo un asterisco más adelante, pero hay que tener consideración de otros capítulos. La aprobación de los visitantes debe de obtenerse con anticipación. Usualmente son por lo menos 6 semanas antes del evento para que haya tiempo suficiente de gestionar los recursos y ir preparando reembolsos y documentación, etcétera. Se pueden solicitar visitas adicionales sujetas a la disponibilidad de fondos. Sin embargo, usualmente se destinan ciertos fondos, primero a nivel global, después se hace alguna previsión por diferentes regiones y después dentro de la región, pues que tratar de beneficiar a la mayor cantidad de capítulos, que abarquen geográficamente lo más que se pueda. Primero, les decía, hay que confirmar la disponibilidad del orador. El capítulo interesado tiene que ponerse en contacto directo, personal con el orador o con el visitante. Y ya que tienen los detalles, hay que llenar un formulario en línea. Este formulario en línea, ahí está muy claramente indicado en la página que viene al final de mi presentación. Es básicamente la página de este programa. Lo pongo en negritas porque no queremos tener ningún malentendido. Todas las solicitudes de visitantes distinguidos deben aprobarse con anticipación. Los arreglos realizados por visitantes, capítulos u otros fuera de las políticas y procedimientos de DVP no son responsabilidad de la Computer Society y no serán reembolsados. Esto es porque, bueno, queremos evitar malos entendidos de decir, oye, creí que sí esto lo cubría. No, hay que aprobar con anticipación todo, hay que tener un presupuesto, se debe de aprobar, hay que tener un calendario, una agenda ya definida para el visitante, para las actividades del capítulo y sobre esto es sobre lo que se aprueba. Muy importante para esto, todos somos voluntarios, todos queremos ofrecerle el mejor beneficio para nuestra membresía local o mundial o global, pero sí hay que cuidar mucho las maneras en este sentido, por favor. ¿A qué fondos tienen acceso? Bueno, básicamente tienen acceso potencialmente hasta $1,500 para el viaje del visitante distinguido. Es decir, si yo de México voy a viajar de mi ciudad, que es Guadalajara, y voy a viajar a Ciudad de México, vamos a ponerlo así, que es otra sección, por cuestiones geográficas es otra sección, a mí no me van a dar $1,500 porque el vuelo de ida y vuelta a Ciudad de México andará en los $200, $300. Entonces, a mí nada más me apoyarían con el viaje de aquí, de mi ciudad a la ciudad de destino. Entonces, esta cantidad que se aparece en la primera línea es un hasta $1,500. No lo tomen como que, entonces de ahí tomo para el viaje y lo que sobre lo agarro para el hotel o la comida, lo que sea. Hay que tener cuidado con eso. Los gastos locales, lo pongo en negrita, incluidos el alojamiento y las comidas, corren por cuenta del capítulo anfitrión. Aquí hay dos maneras de que se puede manejar esto cuando inviten a alguien. Es ya sea que el propio visitante distinguido pague sus comidas y después las meta a reembolso con cargo a la cuenta concentradora del capítulo en cuestión, o que usualmente es mejor, es más sencillo, que el presidente del capítulo o alguno de los voluntarios sea el que pague, porque localmente ya sabe cómo se manejan las cuestiones de facturación o recibos. Entonces ellos pueden mismos después hacer el reembolso a sus capítulos. La intención es hacerle la vida lo más llevadera posible al visitante distinguido. Pueden darse estas dos situaciones, pero sí, lo importante es que para las visitas presenciales los gastos locales corren a cuenta del capítulo local. Pudiera haber una financiación adicional disponible si se dan varias charlas en un solo viaje. ¿De qué se trata esto? Imaginen, voy a tomar yo el ejemplo. Yo soy de México, pero me invitan a dar una charla a Chile y después a Argentina y después a Brasil. No es lo mismo irme yo de aquí a Chile y regresarme a México y después de México irme a Argentina y luego regresarme y luego irme a Brasil y luego regresarme, que si estando en Chile después hago un viaje un poco más corto hacia Argentina y de Argentina después me voy a Brasil. A esto se le conoce como viaje itinerante y si se organizan los diferentes capítulos de las secciones involucradas, entonces existe un fondo adicional, que creo que lo voy a hablar en la siguiente diapositiva, para que podamos apoyar más en los gastos de viaje al visitante distinguido, porque va a ser un viaje que va a beneficiar a más personas en diferentes capítulos. Entonces hay un monto adicional. Y bueno, nada más tengan en cuenta el viaje para los visitantes distinguidos tiene que ser en clase turista, en la económica, nada de lujos. Tampoco se trata de que sufran, pero la clase turista tradicional es la que se patrocina con esto. ¿Cuáles son las respuestas? Cuando ustedes inviten a alguien, ya hicieron el trato con el orador distinguido. ¿Qué tienen que hacerse ustedes a cargo cuando ya los van a atender? Bueno, ustedes son responsables de los gastos locales, son gastos razonables. El orador distinguido puede enviar esos gastos al capítulo anfitrión para su reembolso o pueden ser pagados directamente por el capítulo. Ojo, importante para que no le generen un dolor de cabeza después su visitante distinguido, todas las solicitudes de reembolso deben enviarse dentro de los 60 días posteriores a la finalización del viaje, porque si no se entra en una situación administrativa más complicada y puede haber retrasos o incluso la negación del reembolso. Entonces, hay que ayudar lo más posible al visitante distinguido a que complete su solicitud de reembolso los 60 días posteriores antes del evento. Ahora sí, los detalles del viaje itinerante. En este caso ya se los platicaba, es cuando 2 o más capítulos se unen para que un visitante los vaya y dé una plática o tenga actividades en sus capítulos. Lo ideal es que si hay más de 2 capítulos involucrados, se asigne una sola persona como responsable. Esta persona puede ser un presidente de alguno de los 2 capítulos o 3 o más capítulos. Él va a hacer el trato con la persona, decir horarios, fechas, actividades, y esta persona será la que se ponga también en contacto junto con el programa del DVP para que puedan pedir hasta $3,000. Repito, es hasta, no es seguridad que se los den, hay que ver la disponibilidad de fondos, pero son hasta $3,000 para cubrir viajes interurbanos. Se definen como viajes que están a más de 100 kilómetros de distancia también. Son detallitos muy específicos, hay que tener cuidado con estas formas, pero esto es una forma, un mecanismo que puede solventar más la ayuda, la forma de que los visitantes puedan visitar más capítulos sin ser tan oneroso para la sociedad y que les brinden el beneficio a sus diferentes capítulos. Entonces, si ustedes creen que están relativamente cortos, es decir, por lo menos a 100 kilómetros de distancia entre ciudades, entre capítulos, pero hay algún visitante que les interesaría que fuera a visitarlos y pueden coordinar que estén unos días en un capítulo y después en otros días en otro, esto pudiera incrementar sus posibilidades de que el fondo se los otorguen, por un lado, y que el monto a otorgar sea mayor para que puedan los gastos del viaje del visitante puedan ser cubiertos de manera apropiada. Ya me voy a empezar a ir un poquito más rapidito. ¿Cuáles son los procedimientos? Básicamente hay que hay que seleccionar a alguien del catálogo en línea actualmente. No es de que, oye, yo tengo un amigo que está en otro país que pudiera darnos una charla muy interesante. No, lo sentimos, así no se puede. Hay un catálogo oficial de visitantes distinguidos, hay que tomarlo ahí. Hay que llenar un formulario por lo menos 6 semanas antes de la visita programada. Y algo muy importante, bajo el supuesto de que ya tuvieron este visitante distinguido y fue un evento muy exitoso, para que tengan probabilidades de poder solicitar un nuevo fondo y queden en buenos términos con el programa, hay que llenar además un formulario posterior al evento, es decir, cómo fue el evento, qué pláticas se dieron, qué cantidad de miembros asistieron, este tipo de cosas. Es un formulario post-evento que es muy importante llenarlo. No olviden, por favor, llenarlo para que queden en buenos términos. Y para los interesados en convertirse en un orador, en un visitante distinguido, bueno, como les platicaba, a partir de mayo de cada año se anuncia la apertura del programa. Las nominaciones se aceptan desde mediados de junio, más o menos, hasta el 30 de agosto del año, y los nombramientos oficiales se realizan a principios de diciembre. ¿Qué características deben de tener para poder ser considerados como un visitante distinguido? Como todos los que han estado aquí dándonos charlas ya los han cumplido. Deben de ser miembros de Computer Society. Deben de ser autoridades reconocidas en sus respectivos campos, es decir, tener un historial de conferencias o charlas ya dadas en eventos importantes, artículos publicados, libros publicados, o tener un reconocido liderazgo en su área tecnológica o en la industria en la que se desarrolla. El tema que quieran ofrecer debe de ser un tema de interés para todos los miembros de la Computer Society. Deben ser temas actuales. De hecho, en la solicitud les pidan que pongan 3 posibles charlas a dar. Deben de cumplir estas características. Deben obviamente tener la disponibilidad de poder viajar o atender las reuniones en línea que se les presente. Si están trabajando, y su empleador debe de darles el visto bueno, porque si yo siempre trabajo de 8 del día a 6 de la tarde en mi lugar de trabajo, en mi empresa, y tengo que dar una plática a las 12 del día, pues mi empleador tiene que darme el visto bueno. Esto es para darle el mayor beneficio a los capítulos. El nombramiento se otorga inicialmente por 3 años. Pueden estar más tiempo de eso, pero ya ahí se le da prioridad a los nuevos visitantes distinguidos. Y además, solamente los fondos usualmente se van asignando a los nuevos visitantes distinguidos en prioridad. No es exclusivo, no es que sea una regla fija, pero en prioridad se quiere tener una rotación para que los temas sean cubiertos en el mayor espectro posible. Por último, si por alguna razón ustedes ya estaban como visitantes distinguidos presenciales y tienen que cambiar a solo en línea, hay un mecanismo para hacerlo, se puede hacer. Se fomenta mucho enfáticamente la representación de grupos subrepresentados, así que si ven que el grupo al que pertenecen no está representado dentro del catálogo, se les invita fuertemente a que participen a nominarse. Y la información básica es una información biográfica del nominado y 2 o 3 resúmenes de los temas propuestos. Les estoy dando mucha información, a veces muy específica, pero toda esta información la pueden encontrar en esta página en particular. Ahí quería dejar por lo menos estos minutitos de preguntas. No sé si haya alguien aquí. En lo que alguien empiece a escribir o me hacen alguna pregunta, nada más recordarles, este evento es en en el marco del Día del Voluntario. Los integrantes de los DVP también son voluntarios. Hay que siempre ser muy agradecidos. Este, Están otorgándonos su experiencia, su conocimiento, su tiempo sobre todo, muy valioso. Entonces, cuando estemos con ellos hay que tratarles de dar el mejor trato posible para que nos sigan compartiendo todo ese conocimiento a todas las comunidades dentro de Computer Society. Nada más quería resaltar eso hoy en el Día del Voluntario. Ahora sí, termino mi charla y pues quedo atento en estos minutitos a cualquier duda, comentario o pregunta.
Muchas gracias, doctor Castellanos, por esta valiosa presentación. Bueno, como ya comentaba, abrimos el espacio para preguntas de los asistentes. Pueden utilizar el chat o la función de preguntas para compartirlas y las iremos respondiendo.
Tal vez aquí en Región 9 ya casi es hora de empezar a comer o ya están comiendo.
Sí, sí, ya casi es hora. Creo que por mi parte, doctor, solo una pregunta con respecto al DVP. Yo creo que en
Vale.
su momento ya había intentado, bueno, no he intentado directamente, pero sí me había llamado la atención, había entrado a la página como a poder ver los DVPs disponibles para Latinoamérica, por ejemplo. Y creo que en su momento, no recuerdo, quizás como el año pasado me pareció ver que no sé si quizás es que no estaban actualizados o no están,
Ok,
porque al menos creo que sale como los años en los que está disponible, ¿verdad? Entonces recuerdo que
es
la
correcto.
mayoría era como de 2020, 2021 y ya era 2023. Entonces en ese caso no sé si es error de actualización o es porque ya no siguen disponibles o ya no.
Bueno, aquí claro que existe la posibilidad de que no esté actualizado por algún error humano o un asunto meramente de alguien que no le dio guardar allá el botoncito. Este, Para esos casos sí hay que mandar un correo a dvp@computer, nada más recordando, oigan, la información está actualizada, sí o no, y ya con eso se tomar la decisión. Por otro lado, ahí aparece el año, nada más tengan en cuenta que los DVPs usualmente duran 3 años y se les ofrece mantenerse ahí, nada más con una prioridad ligeramente más baja, años futuros. Entonces, aunque sean más de 3 años, puede ser que sí sea un DVP válido, simplemente que se les trata de dar prioridad a los DVP más nuevos para estar rotando los temas y las personas. Pero cualquier preguntita de ese tipo es un correo a DVP o a cualquiera de los voluntarios. Como ya nos conocemos un poquito más, podemos rápido llegar con la persona indicada que en ese momento está encargado del comité de DVP.
Ok, súper, gracias. También tenemos otra pregunta en el chat de Natasha Urdaneta. Dice, si tenemos un evento donde ya hay fondos de Computer Society, ¿influye al solicitar un DVP?
Buena pregunta, Natasha. Ahí yo diría que hay que tener nada más cuidado en el único asunto picky ahí, muy espinoso ahí. No hay que tener doble contabilidad. Es decir, si pidieron $1,000 para un evento, y con eso pensaban pagarle el avión a un orador. Y además piden un DVP y de ahí van a volver a pagar, entre comillas, el avión. Eso no se vale, obviamente. No afecta si dicen, oigan, estoy a través del programa DVP, quiero pagarle los viajes, el viaje a esta persona que es un visitante distinguido, y además estoy solicitando otro fondo para un congreso, pero los fondos para el evento es para cubrir, no sé, la papelería, la folletería o la renta de algún salón, para recibir a más de 100 personas, qué sé yo, pues. Mientras sean conceptos distintos y lo aclaren desde el inicio, es decir, miren, sí estamos solicitando a este fondo esta cantidad por estos rubros y estamos solicitando a este programa este monto por este concepto del visitante distinguido. En esa situación no afecta siempre y cuando sean claros y transparentes desde el inicio y no se vaya a malinterpretar como que quieren duplicar ahí los posibles reembolsos o justificación de gastos, pues. Siendo claros desde el inicio, no afecta y ya la decisión, obviamente no se garantiza nada de esto, simplemente es decisión de un comité determinar qué fondos sí se aprueban, qué no, o qué cantidades, porque de repente también pueden decir, oiga, necesito $1,000, pero los encargados de un comité dirán, sí te podemos aprobar, pero nada más $500 porque es lo que hay, o tenemos que repartirlo entre otros capítulos o lo que sea, pero eso ya es una decisión. Yo diría que de su parte, como voluntarios de capítulos, hagan eso, sean muy claros, transparentes. Lo peor que puede pasar es que les digan que no, pero también puede existir la posibilidad de que les digan que sí. Así que adelante, háganlo. Que sea decisión del comité y no de ustedes el limitarse a tener un mejor evento de lo que pudieran desarrollar.
Súper, gracias. Tenemos quizás una última pregunta de Donna Roper. Ella pregunta, ¿cuánto tiempo puede permanecer el DVP en una visita? ¿Puede participar como docente de un programa doctoral?
Es- Son dos preguntas distintas. Voy a tratar de responderlas brevemente. El tiempo límite está determinado por los fondos que ustedes como capítulo puedan soportarle los gastos locales a su visitante distinguido y que obviamente el visitante distinguido tenga ese tiempo ya sea permitido por su empleador o su vida personal. Como los gastos que cubre el programa DVP nada más son el viaje de ida y vuelta, ese boleto de avión no está limitado en tiempo. Entonces, si van a estar un día o van a estar 2 meses, eso es cuestión del capítulo local y del visitante distinguido. Porque el capítulo local tendría que pagar los gastos locales por o un día o 2 meses, entonces ya será cuestión de fondos, pero el programa no limita en ese sentido. La otra pregunta sobre, ¿puede ser un docente de un programa doctoral? La respuesta es, si es un experto en su área, si tiene un historial de charlas técnicas de buen nivel, si ha publicado libros, es decir, tiene un buen currículum que lo respalde y ya fue aceptado en el programa, claro que sí. Aquí el asunto es que pase el primer filtro de ser por un lado nominado, después por otro lado aceptado y designado por el comité de DVP. Si el comité de DVP considera que es un visitante, se puede considerar un visitante distinguido, se le va a dar la designación y entonces ahí, a partir de ese momento, mientras sea de Computer Society y esté en su periodo inicial de 3 años, yo no le veo ningún inconveniente.
Súper, muchas gracias. Entonces, bueno, creo que ya no hay más preguntas y por cuestiones de tiempo cerramos el espacio de preguntas y respuestas. Le damos las gracias al doctor Castellanos por esta interesante presentación y gracias a todos los que nos acompañaron hoy en esta sesión, que ha sido una excelente oportunidad para conocer más sobre el programa de Distinguished Visitors. Los animamos a mantenerse conectados con IEEE Computer Society y a explorar las otras sesiones que se llevarán a cabo durante este evento global de 24 horas. Ha sido un honor moderar esta sesión y muchas gracias nuevamente. Esperamos que disfruten el resto del evento. Le cedo la palabra a Natasha Urdaneta. ¿Sí? Sí. para moderar la siguiente sesión.
Sí, muchas gracias, Fátima. Perfecto. Creo que en este momento vamos a cambiar un poco a inglés para comenzar la siguiente conferencia. Hello, everyone. Welcome. If you are just joining right now, here we are at the second IEEE Computer Society DVP 24 Hours of Conference for this year. My name is Natasha Urdaneta. I am from Computer Society Panama, and also from the student branch of Technological University of Panama in Central America. And today it is my pleasure to introduce Juan Jose Chavarria. He is a systems and computer engineering graduate from Technological University of Panama as well. Juan Jose has built a career in AI technologies and data analysis. And throughout his academic journey, he has led projects from signature forgery detection using neural networks to predictive health system for ornamental plants. And a little bit more about him is that he has experience in developing a data analysis framework for a network system, also featuring an integrated AI assistant. And currently, Juan Jose is an intern at the Smithsonian Tropical Research Institute here in Panama, where he works with transforming and extracting data from historical archives. He's also a research assistant at the JSG lab, where he supports algorithm analysis and designs classes. As well, he is an ambassador from Doyo community here in Panama, where Juan Jose actively promotes AI and ML initiatives, including organizing the well-known Amalia Conference. Today, Juan Jose will present NIDAF, Network Data Analysis Framework. It is a tool for complex network analysis. It's an innovative framework designed to facilitate the study of interconnected systems. These tools integrate descriptive analysis, network visualization, and also AI-based assistant. The presentation will explore 3 case studies. The first one with social networks, the next with protein interactions, and also with urban mobility. To demonstrate NIDAF capacity to process networks of various scales using specialized graph analysis and visualization algorithms. Also, he will deep into the technical features of the application, its computational architecture, and the results obtained from analyzing networks of varying complexity. In an era where understanding complex systems with numerous interactions is a growing challenge, NEDAF emerged as a versatile solution. It empowers researchers and analysts to uncover hidden patterns in networks of diverse types, providing a valuable tool for addressing the complexity of modern data-driven research. Without any further, welcome, Juan Jose.
Yeah, thanks, Natasha. That was a great presentation. Let me share my screen. Yeah. Can you guys see it?
Yes, we can. Yes.
Yeah. Thanks, Will. Good morning, afternoon, evening. I don't know, everyone. Thank you for being here today. I'm very pleased to be here. My name is Juan, as Natasha said, and I'm excited to present my work, NEDAF. This work focuses on creating a comprehensive framework for analyzing complex networks, combining insights from graph theory, data analysis, and software engineering. And my advisor for this research is Javier Sanchez Galan. He's the president of the IEEE Computer Society chapter at IEEE Panama section. And this study is part of my undergrad thesis, Technological University of Panama. So yeah, let's dive into the world of complex systems and networks. Yeah, and complex systems are everywhere, like from biological ecosystems to the algorithms behind search engines and social media. And these systems are challenging to understand because their behavior cannot be fully predicted by studying simply their components. And a lot of technologies lies on networks like Google search, Facebook's social graphs, and urban traffic systems. However, analyzing this network faces key challenges. One of them is the high hardware demands. I mean, if you want to analyze a large network, you need RAM, you need processing like a CPU with a lot of cores. And also another challenge is a lack of integrating tools like combining descriptive analysis with network analysis and also intelligent assistance. So my research addresses these gaps with a robust and accessible solution. And that's why my proposed solution was a framework that integrates descriptive analysis, network visualization, and intelligent assistance, all optimized to run efficiently even on mid-range devices. So this framework is designed to provide a unified tool for researchers, practitioners, and professionals. And the goal is to simplify and enhance network analysis. Specifically, I aim to design a modular architecture, develop an intuitive and easy interface, and ensure compatibility with various data formats, recent data formats, I think. And additionally, we identify key use cases to validate its effectiveness. And this framework not only meets existing needs, but also bridges the gap between complexity and usability. And I think that's an important topic nowadays. We have a lot of knowledge in computer science, and one of the things that many people don't understand is because the complexity of these subjects. So what I'm trying to do here is to close a little bit the gap and let's say like allowing this technology to more people so they can use it. But behind all of this software and all the stuff, there's the backbone of this, and that is graph theory. And graph theory offers us a powerful lens to study interconnected systems. And at its core, it looks like nodes and edges, and these nodes representing entities, and the edges represent their relationships. And we can use metrics like degree, and that's the number of edges connected to a node. And for example, in a social network, I mean, the degree of a person would be the number of friends they have. Another metric, an important metric, is closeness centrality, and is because and what this means is a node can quickly reach all other nodes in the network. And for example, it's like being in a central location where you can easily get to anyone else. So this pretty good metric to see if a node can spread a lot of information quickly or get to some point quickly. And modularity is another metric that I like, and it's a way to measure how well a network it is divided into groups. If you have high modularity, you can divide the network in many groups. But if you have low, I mean, the other, you won't be able to divide the network. And with these metrics, we can uncover key patterns and behaviors within networks. We also have properties, and one of them is a small world structure. Here, most nodes can be reached from any other by a small number of steps. So you can go from one place to another very quick. And another property is scale-free networks. They have a degree distribution that follow a power rule. And this means that many nodes have few connections and just a few nodes have a lot of. And these few nodes are called hubs. And I mean, these properties reveal the inner workings of these systems. So by leveraging these theories, and our framework enables meaningful insights across domains like social networks, biology, and urban mobility. So this theoretical stuff and this theoretical foundation underpins the entire project. And now what we did and how we're going to do it. This framework methodology emphasizes scalability and user friendliness. Here we can see the architecture, and this follows a model view paradigm, and this ensures a clear separation between business logic and the interface design. this works like pretty simple. You with the model, you communicate with the data, and you have a signal that you can send from the view. You activate something, the model responds, and the view render. And this is thanks to the event loop, because behind this is the event loop, and that's a mechanism that manages the execution of asynchronous tasks while maintaining a program responsiveness. But if you start to, let's say, creating a lot of events, and they are like complex events, you're processing a lot of data, and you want to do some visualization of a large network, maybe the event loop can get like very slow, and your application might stop. So that's why to enhance performance, we implemented multi-threading that allow us to to run multiple processes simultaneously without compromising the speed. And this is a pretty good example. Like we have a UI thread, and this UI thread is handling everything. But when you're trying to do some calculus or calculation or analysis, you go to another thread. A signal is sent to another thread. You do the work, and the signal goes back to the main thread, and you can display the result. So that's basically what it does. And obviously, the data pre-processing, we develop some stuff, some basic stuff like cleaning, removing inconsistencies or missing values, normalization. If you have a column that you want to normalize that data, you can scale that data within a specific range. And we have some compatibility with multiple data formats like CSV, Parquet, Excel, and sparse matrices, and Edge files too. And these techniques ensure that our framework can handle large and diverse data sets efficiently while providing a seamless user experience. Another thing is the intelligent assistant, and this is powered by LLMs and rack architecture. I mean, it's a pretty simple uh, diagram here where you have a module. This is a module developed, and what you do is you create embeddings. I mean, these words, uh, you convert words into vectors, and you store them in a vector database. And then when you shoot a query to the model, the chatbot, I mean, it first go to the vector database. You retrieve some data, some the top data related to the question, and then you create a prompt with context and send it to the LLM, and the LLM generates an answer with a lot of context, and you can get a pretty good answer. And yeah, also we have to do some validation and testing, and that it was done with unit test for testing the code, and for performance testing and find bottlenecks in code snippets, we use the timing model. But yeah, now let's dive in the project development. And first, we attack the framework, and we went from a framework, from a wireframe to a UI. And this is like the main concept of what we have for this application, like different tabs, and you can follow like a logical order or processes. And next, we like the backend. We use many libraries like NumPy, Pandas, Qt, or Python, and NetworkX to do some of these analysis. We also, for visualization, we employ algorithms like Kamala Kawai, Futurman Wrangle, and Force Atlas 2, each one tailored to specific network sizes. We also use tools like Docker to provide consistency in deployment. And these choices make the framework adaptable and capable of delivering accurate insights. So this is a complete implementation. It's a pretty basic implementation, but it's pretty powerful. And here you can see the import data tab. You can load your data and pre-visualize it. The next tab, you can see the tab of to transform your data if you want to normalize or you want to delete some missing values. And the exploration tab 2, you can select with this drop-down list the column, and base is the column is numeric or the column is a categorical value. You can do some basic statistics analysis over them. And yeah, in the visualization tab, you can also run all of these operations over the network. I mean, you want to know the number of nodes, the number of edges, the maximum degree, the minimum degree, the average degree, the centrality, the closest centrality, the modularity of the network. You can calculate it in a pretty good amount of time. And then the last tab is the LLM Insight tab, where you have the chatbot, where you can ask anything in Spanish or in English. It will answer the questions. So yeah, the case studies is like what we accomplish with this. And to demonstrate the framework, real world applications, we conducted 3 studies. The first involves Sakori Karate Club. This is a small social network that clearly illustrates community divisions. And you can see the load time and the layout time that's displaying the graphs, the network in this area. And the other case study is in the protein interaction network of C. elegans worm, a medium-sized biological network showcasing the framework ability to analyze functional modules. I mean, in a pretty good time. And last, this is like the most important data set we analyze is the Mexico a model is the mobility network of Mexico City during the COVID-19 pandemic. And this is a large application that evaluates urban dynamics. There was a lot of data, and it was the software plot this graph in a pretty good amount of time, pretty quick, and load the dataset pretty quick, and process the dataset pretty quick. So across these different scenarios, from social networks, biology networks, to urban dynamics networks, our framework consistently deliver accurate and actionable insights, demonstrating its versatility and efficiency. So in conclusion, this framework represents a significant step forward, making complex network analysis accessible and effective by combining descriptive analysis, visualization, and intelligent assistance. We've created a tool that not only reveals hidden patterns, but also enhances decision making. And I mean, looking ahead, I plan to expand its capabilities with predictive modeling, dynamic network analysis, and integrate some open source local AI models. And I believe this work has the potential to drive some advance here in Latin America in across science, business, and technology. So yeah, that's what I wanted to talk with all of you today. So thank you. And if you have any question, shoot them in the chat. And here's my LinkedIn profile if you wanna ask me about anything in particular. I mean, this project is on GitHub. If you want the link to get to the repository, you can chat me and I will send you the link.
Yes, thank you so much, Juan. And yeah, to start a little bit with the questions, I would like to know if you could talk a little bit more about the case study of Mexico City mobility. And I mean, what were the challenges doing that project, and could it be done here in Panama?
I mean, yeah. First of all, the Mexico City data set was given to us by the SINA staff. They provided us with the data. This was kind of a project with us and them. It's like we team up. They gave us the data, and we developed this around that data. And the data is between, I think, March 2020 to March 2021, and it was recollected by phone pins. I mean, every phone sends an anonymous pin to where it's located in the city. So, I mean, that network that we saw, this one here, is for December 24th. So, I mean, one day before Christmas. So it's pretty full of people, the city. And let's say one of the main communities, or the main communities, was like the Benito Juarez International Airport. It was filled with people, so you can see that, okay, I can split this network into different groups, and if you analyze the data that with the data that is constructed, this data set is constructed with, is a code from Mexico. So you can type that code in the internet and you can find what the code means. And oh yes, this is an area in Mexico City. This is the airport. This is the street, and this is and yeah, stuff like that. So yeah, it was pretty hard, because there was a lot of data, and this was like, I mean, how can I make a software that can handles that that I mean that volume of data in but very quick, you know? And this can be done here in Panama. We have some data. There's some data public, and I mean, I think it's for accidents here in Panama. There's a data set around, and a lot of biological and ecological data sets here. As Try Smithsonian, I recently got the opportunity to look at them, and yeah, I mean, you can map a network here too, so you can analyze a lot of other stuff, like ecological stuff and tree stuff, and pretty interesting stuff here. So yeah, we can use it here in Panama.
Thank you. And another question could be, what do you think of the NetAF? What do you think sets NetAF apart from other existing network analysis tools like Gephi or Graphia?
Yeah, I mean, I also used to use Gephi or Graphia, and I think NetApp distinguishes itself because I try to integrate descriptive analysis, network visualization, and an intelligent assistant into a single framework. I mean, Gephi or Graphia, they focus primarily on network visualization. Gephi is more generalist, or Graphia specifically focus on high dimensional biological data. So NetApp is like incorporates first an AI-driven assistant that provides contextual insights and guidance for users. So it's more general. Like if you don't have a lot of knowledge in, let's say, informatics or computer science or programming, you will find this tool useful, because you will have something you can ask. Like, hey, I don't know how to do this, or I don't know what this means. You can do that. In other systems or software, you cannot do that. You have to go to the web. And additionally, NetApp is optimized to run on mid-range devices. This is something that I had in mind, that not everyone have a super laptop or stuff like that. So, and yeah, that's it. I wanted to put out there some good software without compromising performance, and this unique combination, I think, makes it more versatile and user-friendly for both beginners and experts. So I think that's what sets NetApp apart.
Great. Thank you so much, Juan. I wanted to ask you if you could put the last slide so people can see the QR code and contact you there if they have any more questions, or maybe if they want to check out the project at GitHub. And I believe now, if there are no more questions, we can thank you so much, Juan, for being here. And I believe now we will have Anand and Noor with a great topic of value of volunteering as a young professional in IEEE Computer Society. I saw them in the participants, so I believe they are ready soon.
Oh, can I also have the presentation rights, maybe? I'm trying to present, but I can't find the options.
In the share button, it doesn't.
Yeah, it's not there. Maybe I used the wrong link. Could try rejoining if that's fun. Or you could just make me a host or a co-host. Yep, it works now. Thank you. Could somebody confirm if it's visible? Yeah, I'm assuming the widescreen is on the screen, most likely. Okay. Perfect. So, I mean, I'm just going to skip because Noor couldn't join. But I'm just going to go directly into the presentation. That's fine. I would like to start with something that could be a news in 2038. I'm sort of a time traveler, so I started in 2038, and I was reading the newspapers. So some things popped up on my news. One of that was there is a lack of representation in the future generations, which sort of created a risk with IEEE where the future generations' voice was not taken into account. And then we have a lack of younger volunteer generation, which sort of created a stagnation with IEEE, and there is a decline in technical knowledge sharing because there is a drop of 40% conference. And then I got scared. So I thought I'll come back in time and talk to you people a bit. Trust me, these are not actual news. Frankly, these are just AI generated news I randomly got from just talking to an AI system, asked it to generate some news. What if we lose young professionals from IEEE suddenly, and what would happen in 10 years? So this is what the imaginary scenario looks like. Part of it is a bit scary because, I mean, who is going to lead the next generation if people are not part of the system? So that's where I'm coming back to the topic of volunteering as a young professional with IEEE Computer Society, because this is super important. So I would like to start a question. Okay, what is IEEE Computer Society? It's a society within IEEE which is focusing on technology professionals within the IEEE within the computing profession, and it is highly volunteer fueled, which means that a lot of this thing is being led by volunteers across the globe. A huge set of that is students, of course, whom we really, really care about. And then we have the huge set of volunteers like the senior members within IEEE, who is really leading a lot of things. And obviously, there is something in between that we are going to talk about right now, which is actually the fuel that really leads and sort of generate that system that sort of keep it running up and running, which is the young professionals. Before we move too deep into those things, I just want to bring some numbers. These are from 2023. I'm still waiting for the 2024 numbers. So I would like to know if people would like to guess these numbers. If it's of interest to people, you can just use the chat. What does the numbers mean? What does 375,000 mean? Yes, that's the right answer. That's around 375,000 volunteers globally. That's the huge number of people that we have within IEEE Computer Society. And what does 157 mean? Yes, it's the 157 countries where we, as IEEE Computer Society, we have a presence. Then what could 936 mean? Yeah, I'm really happy that Natasha is helping me out here. But do you have any guesses? Again, Natasha is right. It's the number of chapters that we have globally within IEEE Computer Society. It's around 936. And what does 15,500 mean? Yeah, trust me, this is the final guess you'll have to make, but make sure. Yeah, that's actually right. That's the total number of volunteers we have. It's around 15,500. So this is the statistics from 2023. this is not the latest one. Obviously, we might have grown quite a lot in 1 year, of course. But I mean, I just want to bring your attention to the huge number of volunteer base we have. And when we talk about all these things, one thing that really strikes us, the huge number of this is student members, for sure. But there is a small number of people we call as young professionals, which we need to really retain and talk about and make sure that we engage them so that we can build the next generation of people. So I'm just going to move forward. So who is a young professional? So often young professionals are considered students by the senior members and often considered as professionals by the students. So even we are in an identity crisis, just like a lot of the younger generation right now. A lot many times the young professionals are the section that usually is really active, really engaging, but usually often forgotten by the chapters. So I really want to emphasize that we are not really students, and we are not really the senior professionals. We are somewhere in between, and this is one of the engaging systems within IEEE that really needs like to be taken care of. So for all the young professionals out here, what would volunteering with IEEE bring to you? One of the primary things would be the skill development. You really get to be a part of a lot of systems, like how we are taking part in this session here, listening to talks, listening discussions that really is engaging, developing your skill set. There is a lot of networking opportunities. Like we are now like talking to each other across the globe. We are trying to network between people. We really create that system of networking. And a lot of young professionals who become part of a system. I mean, you can be part of your professional life, but the best way you can get recognized is through organizations like IEEE. So volunteering with IEEE really brings in the visibility and recognitions. With a lot of these volunteering roles, you sort of end up in a bit of a project management role, like leading an event, trying to build something. For instance, I'm currently part of something called IEEE Computer Society SYP micro mentoring, which is sort of leading a system, designing a system, and sort of running it through and through. Which also helps you become a bit more of a project manager without actually being one, even if you are not professionally one. You can try and be a project manager of some certain programs within IEEE. As a volunteer, I mean, not really in the main bodies, obviously, but at least somewhere in the system. You definitely get a lot of mentorship with senior members, like all these members we have here. All the great people I've had mentors within IEEE, that has really helped me grow. It really boosts the profile that you have with your professional life. Like it sort of helps you get into the system and sort of reach out to a lot more people, bring and build your profile, and to come up with really amazing things that you have achieved. We obviously have a lot of innovation and sharing of ideas and a lot of things that we try to build. And organizing events like this or any events across the globe, that really helps you sort of build that skill of planning and organizing stuff, dealing with crisis, how to manage that, and how to go and get back up and running within the stipulated amount of time. And then there is a lot of technicals and standards that you could be part of. I was really happy that I could be part of a lot of those technology building sessions, a lot of sessions where we sort of sat and discussed, built a bit of standards and stuff. There are a lot of IP exclusive programs. Like I would really like to highlight the CSTF, which is the Climate and Sustainability Task Force within IEEE, with IEEE Computer Society is really contributing to with a few volunteers within different regions. We also have a ton of leadership roles that really helps us grow the leadership part of it. And we obviously have a ton of awards and recognition, including the recent Top 30 Early Career Professionals Award that is IEEE announced, and which is, I mean, unfortunately, the applications are closed, but that really helps a lot of awards and recognitions within IEEE Computer Society. And the multiverse of volunteering is actually super amazing. I would like to go back to the numbers again. Like there are 936 local chapters across the globe. which people would like to really take part in. And that's really the first step where a young professional can really contribute to, be a part of the local chapter, attend the events, go there and be a part of the organizing team, sort of build that network within your local chapter that sort of help you reach out to the local community, build your technology skills within the same region, same section, same chapter, getting to know people across the globe. And we have a lot of regional chapters and teams that really enable us to grow beyond the local chapters afterwards. So it's sort of like growing a profile. Like you start with the local chapters first, then you sort of grow. That really helps you go beyond the systems. There's no limitation that you always have to start the local chapter. You can always reach out to the regional chapters or teams and start there as well. Then globally, we have around 12 magazines, 37 journals, 49 total publications that we have, and around 926 activities, or a lot of articles within CSDL. All of these can be contributed to, and these are really good volunteering opportunities for anyone. There are around 625 committees and board across the globe within IEEE Computer Society that really creates opportunities for you to volunteer. Uh, Volunteering in all these teams is very simple. You just need to apply. There are a lot of forms on the IEEE Computer Society website itself. Just go there, apply to them, and if your profile suits the position, you're definitely going to get selected. So it really is so easy to be a part of any of the volunteering teams. Uh, and obviously, the global teams, including the IEEE Computer Society Board of Governors, or being an elected representative of a lot of committees that sits behind the Board of Governors, helping them achieve all the goals that they have. You can be part of all those committees as well, and it's as easy as applying to the volunteering form on IEEE Computer Society website. The same is there with the one thing I really want to highlight is the Students and Young Professional Activities Committee within IEEE Computer Society, which is currently led by Saptarshi Ghosh, and it's one of those amazing places where you can really figure out a volunteering opportunity for when you are a young professional, because that really helps you grow. So for me, this is the multiverse of volunteering. You can be part of any of these. You can exist and coexist in multiple volunteering roles across this multiverse. And I really think that these are really good opportunities that you can find. And I just wanted to highlight a few of those volunteering opportunities that people have, and all these photos have one thing in common. There is a ton of young professionals present in every one of these photos. And I just want to highlight that the one small section at the very bottom left, which is the Compute. IEEE Compute is the magazine that is run by IEEE CSSYP activities, and that's a global publication. The most amazing thing about that is it was started by a young professional, and it is one of the most active publications within IEEE Computer Society as well. We also have the YPCSDF, which is the Climate and Sustainability Task Force, which IEEE CS is contributing to, which volunteers like Sneha and people from different regions are also part of that. The same is also happening with the IEEE YP Rooftop Socials, which you can see on the right top, which is like sessions happening across the globe where YPs meet up, and these are also hosted globally. There is also the Region 8 conference that is happening right now, which is a great meeting place for SYP. The Region 8 SYP Congress, I mean, it just finished, and I just started seeing the pictures. I couldn't add them in the PPT, but yeah, those things are happening. And there is a Region 9 conference as well, which is in the pipeline. There is a global TechX event that is going to happen for YP. So that is really going to enhance the volunteering opportunities for IEEE young professionals. And I mean, I can talk a lot about what opportunities are and all those things, but then I thought, okay, it's nicer just to go around and ask people what different people think about volunteering as a young professional within IEEE Computer Society looks like. So I asked Sab Ghosh, who is the chair of IEEE CSSYP activities. His answer was network and opportunities is the reason why he likes to be a volunteer as a young professional. And confidentially, he told me that actually events too, but it's mostly because I'm part of the team organizing it. He said that, okay, don't tell anyone about this, but yeah, I'm a nice person, so I'm just going to put that on the PPT. I'm not going to tell anyone. And obviously, the next one I asked was to one of the most active volunteers within IEEE CSSYP, the young professionals community, and he's from IEEE Uganda section. Simenia is one of the active volunteers within IEEE CS, and when I asked him, okay, what does it means to you? Like, what does IEEE CS means to you as a young professional? He said that IEEE Come to Society empowers me to connect with the global network of tech enthusiasts, grow professionally, and contribute to impactful initiatives transforming the world. I think that was a really good reason. Then I sort of went around and asked people from a different section. This was from Jin, who is currently a cluster lead for an initiative and also very active volunteer within IEEE Community Society. And she is in multiple teams across the globe. And she said that IEEECS is important to me as a young professional member because it allows me to connect with like-minded individuals who aspire to make a lasting impact on people and the world through meaningful initiatives. Then I went on to ask somebody who was a two-time Richard E. Mervyn Student Scholarship winner and currently in the Board of Governors, which was Megha. She's from IEEECS in the US, and she said that IEEECS has given her access to amazing technology leaders, opportunities to lead and empower the community of students and early career professionals. So now I would like to really do a call for action here to all the young professional members out there. The best thing that you can do to be a part of IEEE is to join, contribute, engage, innovate, and lead so that we can keep the volunteer base up and running and make sure that IEEECS never face a volunteer crisis ever in the future. And this is a call to all the chapters across the globe to make sure to include young professionals in your society leadership within your local chapters. To have those perspectives as well within your system, make sure that they are joining, they are contributing, they are engaging in every decision, and they are innovating for you. And in the future, they would lead your chapter to amazing heights. And then I sort of wanted to say who I am. So my name is Anand. People call me AJ as well, and I'm a data science specialist in cybersecurity at Volvo Cars Cybersecurity. I look after the cybersecurity data science aspects, and I'm also volunteer with IEEE Community Society for the past 11 plus years, going to be 12 years in the end of 2025. And you have my email address and my LinkedIn on the page. The background image is technically, I just asked ChatGPT to generate an image of me. It said, I don't know you to generate an image. So then I had to write down what I am. So this is the image that represents me. I'm a data science specialist. I'm a volunteer with the IEEE Community Society. And at the same time, I'm a person with Volvo Cars working actively on the data science track. I love photography, and yeah, that's mostly the story about me. And then I just want to finish this with a call to action to everyone out there within IEEE. Like, find your reason to volunteer and hold on to it closer to your heart. And that's what is going to make you feel satisfied at the end of the day. And thanks a lot for lending me your ears and for the invite to join this system and be a part of this event and share my perspectives. Thank you.
Thank you so much, Anand, for sharing this. It's a great presentation. And also, I'd like to thank all our colleagues from Region 9. Your presentation as from Region 8 to Region 9, I think it's kind of a new approach to connect the dots.
Really.
But by the way, in the last year, 2023, I have visited India, and during the All India Congress SYB was in Kerala. It was my first time to visit India, but being there and having this kind of multicultural collaboration inspires me, and it's really important to share some ideas across regions. So this is why your presentation was very important to me. Hopefully next time to have this collaboration, and maybe some colleagues from our grade from Region 9 to host them in Region 8 and all the regions. So thank you so much. Thank you, Roberto. Thank you, all our colleagues from Region 9. I think now it's time to move to another region during our journey today. So we move to our last region, Region 1 to 7, but I think we have a little bit of minutes to share some videos and wait for other colleagues from that region to start. Thank you so much.
Absolutely. I just have a question on the chat, so I'm just going to answer that
Yes,
quickly.
please.
Yeah, I mean, I just want to, like, before I answer the question, this is something I really want to emphasize again. Like, this is the call to action, that find your reason to volunteer and hold on to it. So that's a message I want to leave you with this session. And to answer the question, when should we move from student branch volunteer to YP volunteers? Thank you, Natasha, for that question. I think that's really important to us. So the time is actually now. So when you're in your final years of volunteering, that's when you can start being a part of IEEE YP. And the first year, the first year after your graduation, you automatically convert to YP, and that's when you can start volunteering. So the best way to reach out is to reach out to your local chapter, or find an opportunity within the region. Like I got an opportunity to be a part of Islam's team. And this is actually what happens with an IEEE. Like, all you need to do is just ask. So that's the most important thing I need to, like, say out loud. And then since you're finishing your undergraduate degree right now, and I'm assuming you are part of the Region 9, so reach out to the Region 9's or your local chapter or your section chapter first. Ask them, okay, can I be a part of this? I want to be part of this. And then continue your membership. So that's how you can continue being a YP volunteer. And then that will enable you to be a part of that. And as I said, the first year is subsidized for students. So after you graduate, the first year is a bit subsidized. For you, the membership cost is much reduced compared to your actual professional memberships. So that would enable you to be a part of it. And since you're finishing the degree now, the best time to start is now. Start talking to your chapters and continue volunteering. Yeah, thanks a lot for that question. Perfect. Yeah, I think that was the question in the chat. Yeah, I think that was a question in the chat.
Thank you. It's great food. Thank you for all the colleagues.
Hello everyone, I'm Shema, an ambitious computer science engineering student and a proud member of IEEE Computer Society. I think that the journey with IEEE Computer Society has grown me in many benefits, countless benefits, personally and professionally. This is why I believe that it is important to connect with others so they too can experience the same. So let's explore how it has me as newcomer to computer science and engineering. When I was a first year engineering student, I felt completely overwhelmed and I didn't know where to begin. There were countless tutorials on YouTube and the volume of information left me confused. I didn't know which courses or fields to focus on. I realized when I discovered the IEEE Computer Society, everything has changed. Now, I'd like to offer a brief glimpse in the IEEE Computer Society chapter rules, focusing on the key elements that have influenced my journey. Really, I feel easily privileged that my journey as student has been shaped by the IEEE Computer Society. It has opened doors to opportunities that necessarily happened in my technical, but also fueled my personal growth. Ever since this transformative experience has been, I strongly invite all of you to seize the amazing opportunities that this community offers. So don't miss out.
Hello everyone, I'm Amin Sabah, Network Security Engineer, and I manage the IEEE CS DVP EXA industry portfolio. How did I get here? Well, I'd love to share my journey with IEEE, especially my experience with the IEEE Computer Society chapter in the next few minutes. For those who don't know IEEE, don't rush to Google because you might come across things that are hard to understand. At first I thought, what is it? But now I can confidently say that IEEE is much more than just an organization. It's a global community that connects professionals, students, and innovators who are passionate about advancing technology for the benefit of humanity. So if you want to know more, ask someone who's truly part of it. So my journey with IEEE began in 2020 when I became an active member. I remember how joining it opened up a whole new world of learning and opportunities for me. I entered the community as one person, but I ended up completely transformed. Indeed, actively participating in events and conferences, I've developed new skills and deepened my passion for technology. It wasn't just about attending, it was about absorbing knowledge, finding solutions, and contributing to these adventures. Via these congresses and events, I had the privilege of meeting mentors who not only guided me but also thoroughly inspired me to aim higher. IEEE has taught me that it's okay to make mistakes as long as you learn from these mistakes in order to keep growing constantly. These gatherings served as platforms for learning and sharing ideas, fostering a collaborative environment that makes it even more exciting and enjoyable. Gaining awards and visiting new places via IEEE has added to the richness of my learning experience. Another major side of my story with IEEE is the challenges I faced. So one of my biggest challenges was balancing my personal life and studies with IEEE activities. However, this challenge has taught me how to manage my time effectively, stay competitive, and develop leadership skills. Ultimately, it pushed me to actively and constantly improve. Furthermore, exploring my true passion within the IEEE Computer Society chapter, I've been focusing on innovating solutions and devoting technology to benefit humanity. Throughout my journey with IEEE, I served as chair of the IEEE NX student branch in 2021 and 2022, where I founded and chaired the Computer Society chapter, as well as managing various projects. My passion for helping others has incited me to mentor younger members even after graduation. I've represented the Tunisia section and the CS chapter at numerous events and shared insights, all while taking on new responsibilities that have helped me evolve both skillfully and personally. As the DVP EXA industry portfolio and media responsible, I continue to explore new opportunities and push up new boundaries. As a matter of fact, one of the most valuable skills I've developed is communication, namely public speaking. IEEE webinars and events have helped me gain confidence in presenting to diverse audiences, while IEEE magazines have played a crucial role in both my academic and professional life. They provided valuable resources for my end-of-study project, and now they continue to help me stay informed about the latest technologies and global advancements in my professional career. IEEE has been a cornerstone in my personal and professional growth. It's not just about technical knowledge, it's about the community, the mentorship, and the motive to better yourself while giving back. I really encourage everyone to join this incredible community and experience first-hand growth and innovation it offers. What are you waiting for? Come and claim your piece of the pie.
Hello, good day everyone. My name is Umar Lapigani, a proud member of the IEEE Computer Society and a mechatronics engineering student of the Federal University of Technology, Mina, FUTMINA. Today, I'm excited to share my journey being a member of the IEEE Computer Society and how it has changed my academic and professional growth. I joined the IEEE Computer Society to immerse myself in a global community of innovators, and the experience has been transformative. One of my first skills was serving as the webmaster and IT officer of the IEEE FUTMINA student branch. I helped organize a 5-day artificial intelligence and robotics workshop on cutting-edge technologies like artificial intelligence, embedded system, quick circuit board design, and drone technologies. It was such a fulfilling experience seeing students live with confidence in their abilities and learning new skills. One of my proudest achievements was helping my student branch secure the position to host the IEEE LSPC Local Student Global Contest in Nigeria this year, which showcases research excellence among students. It was an important milestone for our students branch and a testament to the impact IEEE can have on academic communities. Another memorable moment was celebrating IEEE Day on our campus, which coincides with the Nigerian Independence Day, making it a double celebration. This event made me realize the global reach of IEEE and the sense of unity it fosters among engineers and innovators worldwide. Beyond events and leadership role, my IEEE Computer Society membership has also played a key source of continuous learning. I regularly read the IEEE Computing Edge magazine, where I have gained valuable insights into the IoT engineering skill set and the AI-driven cybersecurity. I hope to have my personal research part to the future of the magazine soon, like my paper on development of the neural powered resilience, sustainable energy and communication for climate disaster recovery, or my paper on using unmanned aerial vehicles for advanced precision farming.
It all started with a spark of curiosity in 2022 when I came across the IEEE Extreme Programming 16.0 competition. The idea of joining thousands of coding enthusiasts from around the world for the 24-hour coding competition was too thrilling to resist. Little did I know that this event would mark the beginning of a transformative journey, one that would take me across continents, connect me with brilliant minds, and open doors to endless possibilities within the IEEE community. Soon after, I co-led the formation of Ghana's first IEEE Computer Society student chapter, a milestone that came to fruition in December 2022. This wasn't just about establishing a chapter, it was about creating a space where students could explore their potential in tech with the support of a global community. This chapter introduced us to countless opportunities, and I quickly realized that the IEEE wasn't just a platform, it was a family, one that pushed us to aim higher and dream bigger. One of my fondest memories was participating in the IEEE Try Engineering Math during the My Robot Friend workshop at Caris Primary School, where we met and mentored kids who were eager to learn about robotics. Together we built robots and inspired future engineers. From organizing tech workshops to attending international conferences, IEEE provided the perfect avenue to blend my passion for tech with real-world impact. Attending the Region 8 North Africa Student and Young Professional Congress in Cairo was another great opportunity. Meeting tech enthusiasts from across the region wasn't just inspiring. It became the foundation of future collaborations. The friendships and connections I made at this Congress were instrumental when I took on the role of Uganda Section Lead Ambassador for IEEE Extreme 17.0, where I recorded the highest participation in our section's history. This incredible team effort resulted in my nomination as one of the best Extreme Section Leads for version 17.0, a testament to the strength of our collective ambition and collaboration. IEEE's collaborative spirit greatly enhanced my journey, connecting me with a global network of experts, volunteers, and top leaders, including IEEE presidents and society executives. These interactions provided invaluable knowledge, mentorship, and lasting friendships, which fueled my passion for volunteering. A defining moment in my IEEE CS journey was being awarded the Richard E. Milne Scholarship, becoming the first recipient from Uganda section. This was a dream come true. I have also had the privilege of mentoring other students who have gone on to win the REM Scholarship and witnessed the continued growth of the CS community in Uganda. This year's highlight has been volunteering as the CS SYP TechX lead, where I've worked with a diverse and dedicated team that has expanded IEEE CS career development programs to over 2,000 students and young professionals across the 10 IEEE regions. Through TechX, we've hosted more than 17 events in Tunisia, Kenya, Jordan, Colombia, the US, Brazil, India, and Australia, creating a platform for networking and professional growth. What makes the IEEE Computer Society truly special to me is its emphasis on leadership, volunteering, and technological advancement. The society offers opportunities to make a tangible impact. In reflecting on my IEEE journey, it's clear that each milestone was shaped by the support of others, whether it was forming a student chapter, attending international conferences, or leading major initiatives. None of it would have been possible without the collective efforts of fellow volunteers, mentors, and friends. This journey has taught me the importance of giving back, and I hope to continue inspiring new volunteers to take small steps that lead to meaningful impact.
Hello everyone, I'm Shema, an ambitious computer science engineering student and a proud member of IEEE Computer Society. I think that the journey with IEEE Computer Society has grown me in many ways, countless benefits, personally and professionally. That's why I believe that it is important to share with others so they too can do the same. So let's explore how it has been. Me as newcomer to computer science and engineering. When I was a first year engineering student, I felt completely overwhelmed and I didn't know where to begin. There were countless tutorials on YouTube and the volume of information was confused. I didn't know which courses or fields to focus on. Otherwise, when discovered the IEEE Computer Society, everything has changed. Now, I'd like to offer a brief glimpse in the IEEE Computer Society chapter rules, focusing on the key elements that have influenced my journey. It really actually is the privilege that my journey as student has been shaped by the IEEE Computer Society. It has opened doors to opportunities that most clearly fulfilled my mind, but also fueled my personal journey. I cannot overstate this transformative experience has been. I strongly invite all of you to seize the amazing opportunities that this community offers. So don't be silent.
Hi, I'm Adibandra Aisha Oluwashi, Mechatronics Engineering student and I'm a proud member of the IEEE Computer Society. As shared my accomplishment and overall journey, I joined the IEEE Computer Society a few months ago, and in those few months, I've had tremendous growth in my personal, professional, and academic. And as the current vice chair of the IEEE Footprint and Student Branch, I've had the opportunity to host events such as a 5-day AI and ML workshop in which we cover numerous topics like artificial intelligence, Internet of Things, robotics, embedded systems, drone technologies. This workshop has allowed me not only to enhance my own skills, but contribute to the learning and growth of fellow students, empowering them to become capable engineers. In addition to our workshops, I've been involved in hosting monthly capacity building training sections where we bring industry professionals to impart knowledge and share real-world experience. This event has helped me bridge the gap between theoretical learning and practical application for our students, reinforcing IEEE commitment to foster capable and innovative engineers. We are currently organizing a local student paper contest at my branch, an event aimed at encouraging students to dive deeper into research and technical writing, reflecting the IEEE Computer Society support for academic excellence. Furthermore, we proudly celebrated the IEEE Day this year, which was also my country's Independence Day, and it brought about students together. We recognize the transformative power of technology in this society. Webinars hosted by the IEEE Computer Society has been a fantastic way to stay updated on emerging technologies. For example, I recently attended a webinar in last month, September, by Dr. Fredley on the future of AI and robotics, which gave me a deeper understanding on the ethical implications and AI deployment in healthcare. Events like these have not only broadened my technical skills, but it has also inspired me to contribute to real-world solutions. Beyond this leadership experience, IEEE Computer Society has impacted my personal academic journey as well. The resources provided by the society, such as the IEEE Explore Digital Library, has played a crucial role in deepening my understanding of topics like ethical AI and emerging technologies. The access to a vast collection of technical papers and journals have not only helped me stay updated on the latest research, but also assisted in writing my own paper, including my recent work on AI-based prediction for diabetes mellitus. Additionally, their magazines, journals have been incredibly valuable. For instance, I've gained insight from the webinars on topics such as AI in healthcare and machine learning on the edge. That's the IEEE Computer Society magazine, which have helped expand my perspective on real-world AI applications. One of the best resources.
Hello, everyone. It's my pleasure to welcome you again in Region 1 to 7 after our journey started today, maybe 20 hours ago. So I'll just need to share with you the welcome speech from George O'Clair, which was introduced at the beginning of the day today. So it will be to share it with, even though it's not prepared for the open of each region, but I found it a good idea to start with it.
Good morning, good afternoon, good evening, and good night. A greeting adapted from the movie The Truman Show, starring Jim Carrey. And it works here, since to each of you, there is some relevance in that greeting. And hello, Kuala Lumpur, Sapporo, San Francisco, Wilkes-Barre, Thule, Dublin, Bruges, Cairo, and Mumbai. I'm George Proler, Chair of the Computer Society Distinguished Visitor Program, and it is my honor and privilege to welcome you to this, our second annual IEEE CS EXA DVP event, or as we call it, the 24-hour event. Second annual has a nice sound to it. At the beginning of last year, hosting such an event was just a thought. To extend an earlier project to cover an entire day, 24 hours of presentations, reaching and including our diverse membership. And quite frankly, we weren't sure if we could put it together. But Professor Hassam Fahmy, my predecessor, and Professor Islam Halim, chair of the Awareness and Customer Advocacy Committee, and his team rose to the challenge. And we did it. And it was successful, the first annual. And now, well, Professor Islam and his team have outdone themselves. Look at the agenda for the next 24 hours. Artificial intelligence, AI security and privacy, and research ethics in the area of AI. Quantum computing and the quantum world, smart and high performance computing, and the list goes on. And we are already working on the planning for the third annual event for next year, taking another step and upping the challenge for Professor Islam and his team, as we are looking to make this a hybrid event with on-ground activities concurrent and shared with the online participants and attendees. This event spans each of IEEE's 10 regions and the world's time zones, hence my adapted greeting, since each of you and the DVs, the presenters, the moderators, you all hail from different and diverse regions. And for some of you, it's 10 a.m., 2 p.m., 8 p.m., and 2 a.m., and all the hours in between. So it is morning, afternoon, evening, and night. Truly an effort of inclusion of our diverse membership base. Today is International Volunteers Day, which is fitting, since it has taken, and before this day is through, it will take the efforts of more than 50 Computer Society volunteers coming together from the Geographic Activities Committee, Students and Young Professional Activities Committee, and the Distinguished Visitor Program to bring this event to you. Over the next 24 hours, you will have the opportunity to attend more than 20 technical presentations on topics I've already mentioned, along with informational talks about the Computer Society and its regions, activities, and programs. Each presentation will be introduced by an event moderator who are members of various student chapters, and through participation in this event are gaining experience and opportunity. And then there is the audience. That's you. Many of you are members and affiliates of the Computer Society who volunteer your efforts to make local programs a reality. And all are here allowing us to bring this event to you. So thank you for your time. And now, before I wear out my welcome, I'd like to pass the baton to Professor Irinori Washizaki, the President-elect of the Computer Society. Thank you.
Thank you so much. I just need to tell you something about those videos which were played. Those are the winners of Region 8 contest, which was organized with the aim to provide opportunity to those young people to attend the first ever Region 8 SYB CS Congress. By the way, those were recognized during their attendance, and they get a certificate, and they were delighted to be part of this event. So now I'd like to introduce my colleague, Dr. Faris, the Region 7 coordinator, in order to lead the upcoming session. Thank you, Dr. Faris, for hosting us. And it's our pleasure to be with you and being in Region 7 now. Thank you.
Thank you so much, Dr. Islam, for making this happen. Takes a lot of effort and a lot of energy, and I'm glad to be part of it. Thank you so much. Okay, so I'll start with the introduction for the next speaker.
Yes, sure, please.
Okay, so next speaker will be David Bondurant. He's an electrical engineer and MPA with more than 50 years experience in computer system architecture, product development, pioneer systems companies such as Control Data and Display Univic, system on chip systems, architecture, product development, and computer aided designed at Honeywell, and volatile and non-volatile memory business development at Rumtron, Semtech, and Freescale. Every spin technology, he has consulted with the leading semiconductor companies and Wall Street investment analysts in memory and SOC technologies companies and business strategy. Today, he volunteers with the IEEE and Computer Society. He is the chair of Computer Society Geographic Activities Committee. So please all welcome David. Mic is yours now, David.
Okay, thank you, Fars. Can you hear me okay?
Yes, I can hear you. And if anyone has a question, please put it in the chat. I'll keep my eye on the chat and monitor, and we can maybe ask David at the end of his session.
Okay, great. Let's see here. I want to make sure you can see the screen.
Yep.
Okay, so yeah, welcome from Colorado. I'm in Colorado Springs, and I'm going to be talking about Beyond More, 3D memory and 3D packaging today. So just a little bit about myself. Fars has kind of given an overview, but let me do it briefly again. I've been riding the Moore's Law wave for the last 50 years, as he said. And so, as you can see, I have a BS in physics, EE, and an MBA. I go back a long ways. I'm a hardware engineer, and so this talk is going to be principally about how we build the hardware of computers. And so I worked on the first DRAM module at Control Data, the leading supercomputer company back in 1971. Worked on military computers at UNIVAC from 72 to 80. Designed VISIC microprocessor and gate array products at Honeywell from 1980 to 88. And then I've been working since 88 on emerging memory technologies, ferroelectric RAM, enhanced DRAM, non-volatile static RAM, and magnetoresistive RAM. And so that was kind of a summary of my career. So I've been involved in a lot of different kinds of computer hardware, both at the system level and at the chip level. And then since 2002, I've been consulting with a company called Vertical Memory, and we'll tell you more about that during the talk today. And then I've been volunteering with the IEEE and the Computer Society since 2019. And basically, I've been observing the semiconductor and computer industry over a 53-year period. And so I hope that you will get a feel for how things have changed over the years. Okay, so just a brief summary of what we'll talk about today. We're going to talk about the first 70 years of Moore's Law and how we've gone from transistors to many processors on a chip. You can see an example of one of the early 3D modules from 1971 on the right, for example. And then we're going to talk about how Moore's Law has hit the wall in terms of its ability to integrate more transistors on a chip. What's going to happen beyond that is called Beyond More. And so that's how we're going to get to the next generation of computer technology. We'll talk about how we build them, 3D packaging and wafer scale integration. And then finally, we'll talk about vertical memory, which is the memory technology that we're using today. Okay, here is just a little bit of briefing on some background on the early portion of Moore's Law. Basically, Seymour Cray is the father of supercomputing. He basically, as you know, the transistor was first invented in 1947. Seymour was a new grad and basically came out of college and joined a company called ERA Associates in St. Paul, Minnesota in 1950. That's kind of where I started my career, is in St. Paul, Minnesota. And so, interesting coincidence. He designed the first transistor computer with ERA Associates. It's called Transtech in 1951. He designed the ERA Atlas II computer that would become the UNIVAC 1103 in 1954. And ERA would then become Sperry UNIVAC, and hence the UNIVAC 1103, which is one of the first commercial computers. He left UNIVAC to form a company called Control Data, which is the first supercomputer company, in 1957, with a guy named William Norris, an ERA founder. He designed a series of supercomputers using discrete transistors from 1960 to 1972. And at that point, he formed Cray Research Corporation in 1972. And Cray, of course, has gone on to become Hewlett-Packard Enterprise Cray Research. The IEEE Computer Society created the Seymour Cray Computer Engineering Award in 1997 on his death to honor high-performance computer creativity. And so you can see an example of that creativity from 1971. This is a CDC 7600 computer module, and it uses 3D packaging. That's what we'll be talking about today. And so my point here is that 3D packaging has been around, and even exotic cooling. This module was cooled by Freon cooling. And it's, as you can see, it's integrated as a number of PC boards, integrated vertically as well as horizontally, and connecting transistors. And Seymour is famous for saying that as long as we can make them smaller, we can make them faster. And so, of course, what he was talking about was shrinking the size of the printed circuit board, and basically shortening the length of the wires in the computer. But as we'll see, that's kind of the trend over the next few years. Okay, well, now here's Gordon Moore. So Gordon Moore basically was from Fairchild, one of the manufacturers of the early transistor and later of Intel. And as you can see, he was observing as vice president of R&D at Fairchild the growth in the number of transistors per chip as they doubled every 2 years, from 1958 to 1965. And so you can see the graph on the right and the number of transistors being integrated on a chip. And so if you look at the picture below, you can see exactly those examples. The top left is the first planar transistor. The next chip is the first integrated circuit device. And then, as you can see, over the next years, the number of transistors has grown on each new microprocessor or integrated circuit component. And so he basically coined this thing that becomes Moore's Law. And so this guy named Carver Mead at Caltech popularized this term in 1975 as Moore's Law. And so this law that basically says that transistors are doubling every 2 years on the semiconductor chip has really governed the growth and economics of the computer industry and the semiconductor industry over the last 50 years. Okay, well, we now arrived at the point where Moore's Law is kind of running out of steam. And so what you can see at the top is the first integrated circuit that was built in 1961. As you can see, it had about 16 transistors. It was 40,000 nanometer in resolution. In other words, the feature size was that large, if you will. And then over those time period from 1960 to 2023, last year, basically the number of transistors has grown from 16 to over 92 billion transistors on the Apple M3 microprocessor, as you can see on the right. And so what's happening, of course, is the number of transistors is slowing down as we approach 1 nanometer, which I would call the wall. Basically, the physics are going to preclude us from shrinking too much below that over the coming years. Now, we've been observing the effects of this, approaching the wall already. And so I show here that in roughly 2010, NAND flash started to run out of ability to scale. And so basically at 28 nanometers, the reliability of the NAND flash began to fail. And so the development of 3D NAND technology, vertical integration of these chips began in that time frame. And so that's what we're going to be talking about from here on. Okay, so you remember that Cray said as long as we can make them smaller, we can make them faster. And so that's generally been true. Intel launched their first CMOS microprocessor in 1985 using 1.5 micron CMOS technology. And CMOS basically has been used in microprocessors and supercomputers ever since. And so what you can see on the right here is the trends and the growth of transistors. But you can also see that the clock rate, the speed of these chips has basically flattened out. In other words, we reached a peak of 5 gigahertz in 2005. And it basically hasn't increased in clock frequency since then. And so what happened basically is what's called Dennard's law. Basically, we've become power limited. The chips, we can't really put too much more power on a single chip. And so since that time, you can see that the performance of the computer system has increased with the number of processor cores that we integrate on the semiconductor chip. Okay, so more about Moore's law or beyond Moore. And I'm really trying to get across the message that it's important to have leading edge process and packaging technology, and it's become strategic. And so I think you're aware that we have programs like the CHIP Act in the United States this year that is bringing more of this technology back into the country because it's important to basically control some of the process and packaging technology so that you can do this vertical integration. And so you can see the picture on the right is an example of 2.5 and 3D heterogeneous integration of the thing called chiplets. These are just small, chips that are integrated together with memory on a silicon interposer. So instead of the standard printed circuit board, we have a silicon device with higher interconnect density. And then we have a series of 3D integrated memory devices and chips that are integrated onto that silicon interposer. The next step is 3D integration, basically of stacking DRAMs and flash. And so you can see the picture of a 3D die stack of a high bandwidth memory in the picture on the upper right. And then the next thing that we have is called 3D vertical integration on a chip. 3D NAND, as I mentioned, had been doing that since about 2010. And so today we've reached a level of 232 layers of vertical NAND cells being vertically integrated on a wafer. And companies are starting to announce devices with more than 300 layers on a chip. And so NAND flash, non-volatile memory, is where this technology is being used today. But as we'll see, DRAM will be going vertical in the future. Finally, we can just build bigger chips. It's called wafer scale integration. And I'll show you how that works. We're doing things like going to higher dielectric constant for the capacitors in the DRAM. We're building new non-volatile storage devices like ferroelectric, magnetoresistive, resistive, and nanotube. And you recall that I've worked with several of the different emerging memory technologies already since 1988. And then finally, we'll be going to new substrates for the chips, things like silicon carbide and gallium nitride. Okay, well, briefly, we're going to look at the latest supercomputers and how they're built. Now, here is the fastest computer as of 2022, which used 2.5 and 3D integration. It was called the HPE Cray. So this is Cray Research years later, the same supercomputer company that I talked about back in 1971. And so they're still building these fast supercomputers. And so today they're integrating a processor with over 1,102 exaflops. I can't remember how you say the word, but anyways, it's a very fast computer. And you can see that it has hundreds of thousands of processor cores. It has millions of GPU cores integrated into this large system. This one built with 7 nanometer technology and operating at about 2.5 gigahertz clock speed. So that's the state of the art in 2002. Here's how it's built. Okay, so the CPU module, combined 8 processor chiplets. Okay, each chiplet had about 8 processors on it. And the central chip in that chiplet, combined 256 megabytes of L3 cache along with interconnect devices for the I/O of this system. And so it's built out of 7 nanometer features, integrates up to 64 processors on a module, and as you can see, has 8 double data rate memory channels with about 110 gigabytes per second of bandwidth, along with some Ethernet I/O. AMD integrates into that same supercomputer a thing called an Instinct GPU. And so this is a graphic processing unit that's being used for compute and AI. In this case, it's focused on fast floating point processing. And so this device combines 2 large chips. You can see the 2 GPU chips in the middle of the device, each a total of 56 billion transistors operating at about a gigahertz clock speed. And you can see that there are 8 stacks of high bandwidth memory, 2E die stacks, 8 high, integrated into that module. Each of those die stacks has a 1,000-bit memory bus, and the total memory capacity is 128 gigabytes with a bandwidth of 2.5 gigabytes per second. And so if we go back here, you can see that the more traditional DRAM was only delivering 410 gigabytes. The high bandwidth memory is delivering 2.5 gigabytes per second in a very small space. And the total power of this module is 500 watts. And so as you can imagine, cooling is a big deal. Okay, well, we're going to talk more about 3D packaging. Okay, in order to basically get more transistors in a smaller space, the computer manufacturers are having to integrate vertically. And so starting in 2020, AMD began integrating vertically the 32 megabyte L3 cache chip on top of the processor. And so you can see on the bottom the chiplet that represents the processor. And then you have the 32 megabyte L3 cache mounted on top, along with some spacer devices just to make everything flat. And so this is an example of heterogeneous integration. In other words, the CPU is built on the most advanced process available, but the SRAM, which is no longer able to scale, is built on a larger feature size chip, feature size device, and that's integrated on top of this finer process. And so this allows the CPU to advance to the most advanced process, while the SRAM basically remains at a lower process feature size, limited by its physics, the physics of operation. And so AMD has basically gone forward on a device called Ryzen and integrated what they call vertical cache, in which case they're stacking 3 of these 32 megabyte L3 caches on top of each other and mounting those on top of the CPU. You can see the source of this technology review in IEEE Spectrum from March of 2022, if you'd care to look. Okay, well, here is the newest version of this. And so the latest version of the GPU from AMD is the thing called MI300A. You can see that on the right that there are multiple chiplets, and they're being vertically integrated 3 high. And so if you look real close, you can see that there is a compute, an accelerator, and an I/O chiplet. And those are all being vertically integrated and mounted on a silicon interposer with these high bandwidth memories. And again, the reason that they're mounted on the silicon interposer is that the interconnect density of that silicon is higher than the PC underneath. And you can see how those are bonded on top of each other in that picture on the right in terms of how the bonding works. And so you can see that article also from IEEE Spectrum in December of 2023. Okay, well, why is that significant? Well, here is the 3rd generation Instinct 3, what we just saw. There's a picture of the module. You can see that it has the 3D integrated chiplets, and you can see that there are 8 high bandwidth 3, the next generation die stack, with up to 12 24 gigabit chips mounted. And each of the memories has a 1024-bit wide memory bus. And so the total capacity of that system is now 192 gigabytes, and the bandwidth is doubled to 5.2 terabyte per second bandwidth. Why is this important? Well, it goes into the latest El Capitan supercomputer, which was just announced about a week ago as the world's fastest computer this year. And so this is what it takes to build the fastest computer in the world, is this 3D integration of chiplets and memory. Okay, well, another approach is called wafer scale integration. And so here is an AI processor built by a company called Cerebras. It's in its 3rd generation. So they've built 3 different versions of this, and they shrunk the feature size to 5 nanometers. As you can see, this wafer is integrating 900,000 AI cores 42 gigabytes of an embedded SRAM, which is faster than the high bandwidth memory. And so the total bandwidth on this wafer is, as you can see, 21 petabytes. So we've gone from terabytes to petabytes. And the number of transistors on one wafer is about 4 trillion. Again, very high powered and water cooled. Okay, well, anyways, I've taken you on a tour of 3D packaging, and we've talked about 3D memory. Let's dig into that a little bit more. Here is my memory vision from 2002. In other words, I came out of a company called Ramtron and Enhanced Memory in 2002, and I had been working for the last 14 years at that point on 2 new technologies: ferroelectric RAM, which is a non-volatile dynamic RAM using ferroelectric materials to store data. And I'd also worked on the world's fastest DRAM. It's called the Enhanced DRAM. It combined both a fast DRAM and an on-chip cache on one chip. And so when I left Ramtron and Enhanced Memory, I created a new company called Vertical Memory. And so this is in 2002. This is 22 years ago. My vision at that time is that memory would have to shrink to close to 0 nanosecond speed, unlimited endurance, almost no cell area, and retain data without power. And at that time, I said that the memory would likely need new storage materials, something like ferroelectrics or magnetoresistive, and require memory to go vertical, which is vertical device structures, stacked components in a package, and multiple bits per cell. And so kind of feel like I was observing beyond more even back in 22 years ago. As you can see, what I was companies I was talking to at that time were doing these advanced technologies and proposing them. So a company called 3D Plus was integrating a number of DRAM on top of each other, stacking them in 2003. And they were achieving 1 gigabit of density in 2003. Now, if we flash forward to today, I guess that'd be 21 years later, you can see the latest 3D DRAM, the high bandwidth 3E, that has 36 gigabytes of memory in a single stack. That's also thinner, as you can see, than the 3D stack back in 2003. And so if you do the math, I think you're going to find that that's over 250 times higher density in a smaller space in that time frame. Okay, let's flash back. Basically, here I am working for the leading supercomputer company in 1971 as I graduate from college. I work in Minnesota at the CDC Arden Hills Development Center, and they're building the fastest supercomputer at that time using discrete transistors. Seymour Cray, that leading developer, is already working on what they call the CDC 8600, but will become known as the Cray 1 supercomputer at Cree Research. I'm in memory development, so I'm involved with developing the first DRAM module for a CDC supercomputer. What you need to understand is that 1971 was really the first year of commercial availability of DRAM. And so what you see is what we used, an AMS 7001, 1 kilobit PMOS DRAM, and it was manufactured initially in 1969. It operated at 15 volts, had 1,000 bits on a chip. And so the DRAM module that we built had 128 chips on 2 6x9 PC boards with a Freon cooling, conduction cooling device in the middle of those PC boards to cool it. And it had a huge capacity for 1971 of 4K by 32 bits. And of course, to make that work in a supercomputer, you had to convert PMOS to TTL to ECL, which was used in the computers back then. Okay, well, flashing forward from there, you'll note that the first DRAM had a planar process for the capacitor, but that didn't last too long. And so by the 1 megabit generation in 1985, the DRAM went 3D. And so arguably that could have been a beyond more type of response because they couldn't go make it smaller without going vertical. And so as you can see in that graphic on the right, they either stacked capacitors on top of the transistor, or they built trenches down into the silicon to build the capacitor below the transistor. And with each generation of the new DRAM, the 3D capacitor structure got more complex. And in addition, we had to come up with some new dielectrics of higher capacitance. And so that's things like silicon nitride, hafnium fluoride, tantalum pentoxide, and barium strontium titanate, I believe, are all those different new materials that are being used for the capacitor. Okay, well, what's happened since then? Well, over a number of years, we scaled the vertical stacked transistor, but at about 2010, basically we ran out of speed. And so you can see that the DRAM has not grown in density. It's grown from 4 to 16 to 32 gigabits over that 24-year period. And so it's slowed down dramatically. And so there is a need to grow the DRAM more vertically. And so you can see here a company called Neo Semiconductor, who's a startup company that proposes to vertically stack transistors and capacitors to achieve and return the density increase of DRAM. And they do that by stacking these transistors vertically and integrating the capacitor using a thing called the floating body effect. And so you can see their roadmap to get to 128, 256, and larger, you know, basically a terabit chip in the future. Okay, now here's the leading supplier of DRAMs and what they're saying. Back in March of last year at MEMCOM, they were showing their roadmap of DRAM development. Now they talk about vertical channel transistors and vertically stacked capacitors. And so you can see a little picture of what it's taking to integrate and go from what they call 6F squared to 4F squared. That's basically cramming more, you know, a transistor cell into a smaller and smaller size. And they project that they're going to try to scale this vertical channel transistor from, you know, the current feature size that's in the 10 or 11 nanometers down to 7 over the coming years, use some new materials for the capacitor. And so that's their approach. Okay, so we pretty much talked about how you build a vertical memory, but how do you get more bandwidth? Basically, these huge systems with literally hundreds of thousands of processors, they need a lot more memory bandwidth if they're going to be able to achieve their performance. And so what I'm telling you in this chart is basically the speed of the DRAM that it increased over the time period. And so what I was working with in 2002 was about 133 megahertz DRAM. Today we've moved to 4 gigahertz or higher. And so a huge increase in clock speed of a synchronous DRAM over that time frame. We've also introduced double data rate and quad data rate I/O, and so we can transmit 2 to 4 times more data at a clock rate. And so you can see that the memory market today has 4 different segments. And so there's the PC server market that uses small memory widths and double data rate. That's the standard today, DDR5. The graphic RAM uses a 32-bit wide memory, so wider bandwidth, and now is up to quad data rate, or 4 bits per transition, for a higher bandwidth. Low power DRAM, that's a double data rate memory that uses lower power and is really designed for today's mainstream microprocessors. And so, for example, the Apple computers use low power DRAM for their main memory. And then finally, for these supercomputers and AI processors, they've gone to 1,024-bit wide memory, all in that memory stack that we showed. And so I hope you can see this on your screen, but this is the roadmap of high bandwidth memory development. And so it all started back in 2013. Recall that 2010, we were running out of the ability to scale the DRAM. And so we start stacking these things up. We're doing this by stacking chips on top of each other. And so you can see that we've grown from HBM1 to HBM2 to HBM2E to HBM3 to HBM3E, which is the current state of the art. And so the capacity has grown per stack. The number of layers has grown from 4 to 12. The clock rate has gone up from 500 megahertz back in 2013 to 4 gigahertz today. And you can see the bandwidth per stack of these chips at 1 terabyte today. And then you can look forward into the next year for a thing called HBM4, which is expected to go to 16 layers, use 32 gigabit DRAM, and we can't really predict the new bandwidth, but obviously it'll be faster. And so that's the story of the high bandwidth memory or vertical memory that is required for these devices. Let's see. Somehow I'm going to go back here, just a couple of slides here, because we forgot something. And this is the picture that I wanted to show you. This is the NVIDIA Blackwell GPU. This is basically what has driven NVIDIA to be the highest value semiconductor company and computer company in the world. The NVIDIA B200 Blackwell is the leading AI processor today. You can see that it basically consists of 208 billion transistors per chiplet. And so there's 2 of those in the middle of that module. And there's 8 of those HBM die stacks built out of the latest technology. Each of those 24 gigabits in density, 12 high, and 8 terabytes of bandwidth. And so that's the NVIDIA Blackwell. You can see a module having 2 of these GPUs and 1 CPU module, all of which is liquid cooled, just to try to make it work. And of course, the latest press on this is that it was actually overheating. And so they're working to make the latest AI processor run reliably because of its high power. Okay, so let's just finish up here. To summarize, basically, it's important to have a leading process and packaging technology if you want to continue to be at the leading edge of computer development. That's just the key. Moore's law has hit the wall. Beyond Moore, technology is going to grow chips and systems vertically, as we've seen. 3D packaging stacks of heterogeneous chiplets on silicon interposers is the technology of choice. 3D stacked high bandwidth memory is getting incredible bandwidth. And as we can see, the 3D process technology is going to be necessary to increase the density of DRAM per die and allow that HBM to grow its density and speed. And so what I suggest to you is that removing the power will become the big issue in the future. And so liquid cooling is the thing today. I would note that Control Data subsidiary called ETA Systems back in the 80s built a computer that was cryogenically cooled at liquid nitrogen temperature, and I would suggest that that might be coming in the future. That's the story for today. I'm available for any questions if there's any of those.
All right. Thank you so much, David. That's a very interesting, interactive presentation, informative. Thank you so much.
Okay, thank you.
And I have actually a question for you. As you said, the Moore's law is hitting the wall. What would be the next thing, replacing Moore's law going forward for the future?
Well, so the beyond Moore, okay, in other words, just the stacking. So what we saw is that when it couldn't scale, a transistor any further. In other words, if we're cramming more transistors on every chip, but we're getting to the point where we just really can't make them shrink. And what we saw is that the DRAM cell couldn't shrink any further, even back in 2010. The NAND flash cell could not shrink any further because of physics. And then the SRAM is basically run out of space. It can't shrink any further because it basically the current is so low that it's subject to soft errors. So the reliability is limited. So you saw that we're integrating chips that are not as high density into these more advanced processors simply to make it work. And now, of course, you could argue in addition to beyond Moore, you're going to have some fundamental process technology improvements.
Yep.
It's like going to things like silicon carbide or gallium nitride to build, more reliable or better operating devices. So, for example, magnetoresistive RAM may be the memory of choice to integrate memory below 28 nanometers. In other words, NAND flash is being replaced by magnetoresistive RAM or resistive RAM.
Thank you, David. Dr. Islam, I think you have a question.
Yes, it's not actually a question, but it's maybe I'd like to share with you that you mentioned the EXA flop, and this event is an EXA DVP. So I don't know if everybody knows that the EXA DVP event is adapted from the Frontier supercomputer, which has reached the EXA flop 2022. So when we thought the last year, when we start this kind of event, so we think that it could be a good idea to name it EXA flop, so to reflect the ability of computer society reach this barrier and do that. I don't know what kind of event we can do after that, maybe 48 hours or something. It should be Zeta.
Right. Yep.
Yeah. All right. Any more questions from the floor? No. Sorry, Islam. Go ahead.
Thank you for the great presentation. Thank you so much.
Yeah, it's really great presentation, and I think, David, you've seen it all, man, from early days until now. If you've been through that journey, it's amazing. Thank you so much for this interactive
No, it
presentation.
was certainly an interesting ride, is what I would say.
Absolutely, yeah. Very inspiring for the next generation. I can tell you that.
Yeah.
Thank you so much. I'll pass the mic back to you, Dr. Islam.
No, thank you. Now I think we can, if there is no other question, I think we can move to Dr. Zaman Inc. to moderate the next session. So I just share the info of the next session.
All right. Thank you, Dr. Islam. Welcome, everyone. Good afternoon, good evening. I'm not sure if any time zone still has good morning. So this is my great pleasure to be part of this event, and I'd like to welcome Dr. Tulsi Tulasiram. He's a professor at Department of Computer Science at University of Manitoba. Welcome, Dr. Tulasiram.
Thank you.
He has a very colorful career. He got his PhD long way back from Indian Institute of Science. After that, he taught and become postdoctoral researcher in many schools, universities, good schools and universities, and different locations in US. His current research interests include computational finance, data science for financial applications, risks forecasting, blockchain technology for financial applications, smart contracts in collateral contract services, computational intelligence, and so on. Dr. Tulasiram's research was funded by many different institutes, notably Natural Science and Engineering Research Council, NSERC, Canada. Dr. Tulasiram is currently the chair of IEEE Computational Intelligence Society's Computational Finance and Economic Technical Committee. So I can tell many more, but we have to be respectful about the timing. So thank you so much. And I'd like to welcome Dr. Rupa Tulasiram to start his presentation. Thank you.
Thank you. So let me share, but then, yeah, share. I don't know. Do you see my slides or?
Yes, we can hear you, and also you can share the slide. Thank you.
Okay, so let me pull this back here then. Yeah, so you should be still seeing the slides, I guess. Excuse. Do you see the slides?
Yeah.
Okay, good. Thank you. Yeah, just wanted to make sure. I had to quickly change my the monitor here.
Yeah,
Okay.
so this time I can see the if you go in the presentation mode, in the other window was bigger, so we can still see it, but it's in a presenter window we can see.
Oh, I see. Okay. I don't know why it's
if you just click on the icon swap display, you can see on the left top there's an icon. Yeah.
Yeah. So
yeah, this is good. Yeah, thank you so much.
No problem. Thank you. Yeah, so thank you for the invitation and introduction. Nice being here as a part of this the Distinguished Visitor Program presentation. The previous talk by David really reminds me of my earlier journey in the high performance computing in University of Delaware. I don't know if David was aware of, I mean, you should be aware of the HTMT project, the hybrid technology multi-threading, where the core, say the CPU was supposed to be in the cryogenic coolant. So whatever that David was mentioning was reminding me of those days, and then it is coming back now. That's interesting to see that. Thank you. And so moving on, so my journey as like it was in a different areas, but then I'm now mainly focusing on computational finance and of course the advances in computing technology, say in machine learning, data science, and large language model very recently, how they affect the thinking in financial, say, world, right? Financial applications. So I mean, it's really amazing to see that how the business, say, community has coped up with these large language models. So there's a conference called Generative AI in Finance just 2-3 weeks ago in Montreal. So where I presented one paper, this last part of this presentation, that was the shocking thing or surprising thing was that the rest of the papers were all from business school. So that's really the way that things are, say, moving or changing the entire, say, discipline, different disciplines. So my name is Rupat Tulasiram. I'm from, of course, Department of Computer Science. The lab that I have or direct is called Computational Financial Derivatives Labs, or the CFD lab. That's the kind of a avatar from my previous, say, work areas, which is computational fluid dynamics. That's when I was using high performance computing, computational CFD. So I kept the same acronym CFD, but to do a different work. Here again, I'm using some high performance systems as well. Anyway. And this is my email if you have questions following that talk, and you can see my profile here at my website or the Google Scholar. And this work on machine learning, data science, and say large language model for financial applications, we are talking about only a couple of applications in this particular, say, presentation. Of course, we have multiple other areas of, say, studies. So this area of, say, application is contributed by multiple students. These are the 4 current students. Joy Jas, who is a PhD student currently, and Ahmed Reza Zakai is an MSc student, and Surilita Bawala, a PhD candidate, and Avanti Morganama is MSc student. And we have collaborators from Department of Statistics here in Manitoba, Professor Tavaneshwaran, and from Department of Finance, Professor Alex Paseka. So the work, of course, coming from them as well. So here's a quick outline. There's 2 parts of this talk. The first one, of course, is going to be on the price prediction and portfolio optimization. And the second part is portfolio construction using the large language model. So the reason why I wanted to introduce this is the effort that goes in the first part, that is building, say, a portfolio and then trying to optimize is based on the prediction that we made on the prices from the stock market, how it simplifies the LLM, how it simplifies in such construction, right? So we can see the major difference in terms of the efforts that has gone in using all the models, using all the data science or the machine learning models, how it simplifies using an LLM. If it's still a black box, right? So we'll see a basic introduction to the problem, and then some objectives we'll introduce, and the algorithms. And of course, we have multiple studies. I'm going to focus only on 2 of them, but not all 4 of them in this direction of my research, which is encoder-decoder architecture for financial price prediction and investigation of clustering algorithm for diversification of portfolio. So once we predict the prices based on the price prediction, we can try to construct a portfolio. And of course, portfolio needs to be diversified in order for better returns, right? And then we make conclusions and, of course, have some limitation and future direction for research here. And then in the second part, we'll talk about these models that we have been using, the large language model that we have explored, about 8 different models that we have explored. And then we also go for both zero-shot and few-shot prompting. I'll mention what they are. And then we try to build portfolios by LLM, right? So we just give instructions to LLM to build 2 different portfolios. One is a high growth portfolio, and the other one is a low risk portfolio, and see how it constructs. And the instruction is to beat the S&P 500 market. So then we introduce the RAG, the retrieval augmented generation, how it, say, enhances the results that we get out of these large language models. Then we few results and conclusions. And we all know that, of course, financial markets now have stocks and cryptocurrencies, and which are all highly volatile. So in addition, we also have other markets such as derivatives of these assets, like derivative market. That's a big market, right? So we're not going to consider, say, some other work that we have done on that, say, spectrum of problems. So market dynamics, of course, are going to be influenced by economic indicators, company performance, geopolitical events of public sentiment, and many other, say, factors. And of course, cryptocurrencies are highly volatile than any other assets. And yesterday's price of Bitcoin was 100,000. It crossed. It really, and I think 2008, they were giving away Bitcoins for free if you attend the booth in one of the, I think, exhibitions. Now it is $100,000, just one Bitcoin. So complex data distribution makes it really challenging for price prediction in general, right? So there are many statistical methods used traditionally, such as these moving averages, auto-regression, then integrated moving average, etc. And then, of course, soon the machine learning methods came into existence. Of course, they've been there quite some time, but these machine learning, say, methods started giving, say, better understanding and better, say, results. And then it came, of course, the deep learning models, which became superior to machine learning models. And then, of course, the bit more like recurrent neural network advances, such as the I don't know why it is jumping back, the LSTM and GRU, that is the long short-term memory model and the gated recurrent unit model, and their hybridization with other ML techniques, right? So these things like now advancing the prediction process. And the LSTM, of course, sometimes is specific market dependent and struggles with some small data sets. So for large data sets, of course, then people are mostly using the GRUs then. They, of course, these models, LSTM, GR, they still do not capture the long-term context, and so they do not perform well for, say, long, say, standing the data sets, right? So that means to maintain long-term context and better prediction, we have proposed a hybridized autoencoder GRU architecture and hybridized autoencoder LSTM architecture. That's autoencoder LSTM, autoencoder GRU. Then we predict and then see the results and compare and decide which one is giving us better results, like autoencoder based GRU architecture here. And then, of course, for the second part, once we predict, then we try to build portfolio and then try to optimize. We first study some of the traditional techniques, such as the mean variance optimization, modern portfolio theory, and Sharpe ratio optimization. And these traditional techniques, they do not, say, capture the non-normality in the data, and then hence they are not, say, robust. So non-normality in the sense the data distribution. So these techniques or models do not capture the higher moments in the data distribution, like the skewness or cortices or whatever, right? So the higher moments they don't capture. So only the advances like machine learning and deep learning can capture them, and then we can make use of these high moments in order to make better prediction so that we can build a better portfolio. And then we also hybridize them. So we consider hybridizing autoencoder with MLDL to accommodate non-normality and capture the long-term dependency. And traditional portfolio, they do not consider non-normality, skewness, or cortices, right? So building upon the prior work, two of my students use the data-driven method for composing this portfolio, comprising conventional stocks and portfolio techniques. So here are the, So enhance the predictive accuracy of financial assets, then improve model capacity for long-term context retention. These are the objectives. Strengthen portfolio resilience through machine learning-based diversification, and then develop deep learning-based portfolio optimization strategies for increased profitability. And basically, all of these comprise of application of the machine learning, deep learning, and data science strategies in solving existing challenges in prediction, price prediction, and portfolio optimization. Right? So we have these techniques with unsupervised, say, learning. That means clustering techniques or unsupervised machine learning algorithms, since they do not rely on the external labels in the data set. They tend to divide the data points into clusters. So clustering techniques. So we'll talk about them, a few of them, like k-means clustering, DB-scan, affinity propagation, and density-based spatial clustering, that is DB-scan. Okay? So these techniques are used in diversifying in asset selection for enhancing the profitability in the portfolio. Okay? So then we introduce this bidirectional LSTM, bidirectional GRU. So basically, bidirectional LSTM is it captures the data progression from both forward and backward direction. So as you move along these internal the units, right? So they identify the dependence of the past data, and at the same time, when on the reverse direction, it captures the future, say events that happen. So based on those two directions, BioLSTM seems to provide the better enhanced ability to capture long-term, say, dependencies, and also that understand the context in which the each element, I mean the LSTM elements, appears within the sequence. So the here, the same thing with the GRU, so both bidirectional, so that the by GRU also considers bidirectional dependencies, and which has an enhanced ability to capture the long-range dependencies. So we use both by LSTM, by GRU. And of course, the this together with the auto encoder, right? So we have the encoder decoder architecture in order to make the data processing a bit more simpler, because in the input data, of course, is high dimensional. So in order for the say getting rid of these noises and unwanted, say, data, we pass the data input data through this encoder at multiple, say, different stages. That means we basically reduce the high dimensional data to a low dimension latent space. So that way the memory requirements, say, for executing this algorithm also is reduced. That is also to maintain the long-term context. So the number of neurons are going to be reducing, and the noises are getting canceled. And in the latent, and so the H is the latent space, which is the, say, it's a function of the input data here, and then through the decoder, which is a kind of reverse process. After getting rid of the noise, we decode the input data for getting the true, say, information from the data sets, right? So the hidden representation of this input data as obtained the encoder, say, component, the decoder component, of course, then reconstructs the data, which is the X hat here, which is by minimizing the reconstruction error. Of course, this process of reconstruction eliminates noise, as I mentioned, and or outliers in the data set, input data set, which are not correlated with the original data set, leaving behind only the significant, say, features that are required in order to, say, make use of it, say, for prediction purposes. Okay? So this is the architecture that we use for price prediction to retain long-term data, say, features. Okay. So these are the for, say, the traditional portfolio optimization techniques: the equal weighted portfolio optimization, inverse volatility weighted portfolio, IVW, and the mean variance optimization, constrained portfolio, Sharpe ratio. So mean variance is basically by, say, objective function, and then with the by objective function, if there is further, say, constraint imposed by users, that becomes the constrained portfolio optimization technique. And the Sharpe ratio is the optimizing the return over the risk ratio, basically. So traditional techniques, of course, do not consider, as I mentioned before, the higher moments in the data distribution, such as the skewness and cortices. So the earlier study in my group, we have came up with two innovative estimates known as sign correlation and volatility correlations. And these are simply this sign correlation and the volatility correlation here, right? So the sign correlation is defined as the correlation between the least square estimating function, this one, and the absolute, say, least absolute deviation function. Whereas the volatility correlation is defined as the correlation between the estimating functions for variance and for volatility. Okay, so that's a simple say definition and simple difference between those two, sign and volatility correlation. So this enables us to identify underlying distribution and then to obtain, say, probability forecast in a better way. So that's the idea. That means we can also, in that process, capture these fourth and fifth moments, or third and fourth moments, so to say, in this case, skewness and cortices. Okay? RP here is the portfolio return, mu is the mean return. Okay? So in addition to this, like we introduced the so-called the data-driven concept for portfolio optimization. That means what we have done is to use all these volatility estimates based on the sign correlation, volatility estimate based on the volatility correlation, and then combining both of them, and then the mean absolute deviation. So all of this portfolio, based on all these, say, metrics, that we constructed data-driven portfolios based on reducing these risks and profiting against these data-centric risks. Okay? So these are the 4 different studies. So so far what we talked about is only the fundamental basics for all the different, say, 4 different studies, or so to say, slightly different problems. So first one, of course, is going to be price prediction, and then the diversification of a portfolio. So other 2, of course, I'm not going to be looking at today due to time. So the encoder-decoder architecture for financial price prediction, we saw the architecture in the previous slides. So what we have seen is the results show enhanced, say, accuracy, predictive accuracy, and retention of long-term context from the past observations. So this work has been published in Journal of Risk and Financial Management recently. So what we do in this work is we collect data sets, like multiple different, say, stocks from S&P 500 data sets index, so from 1998 to 2022. And for the cryptocurrency, we select one of them, Bitcoin, which between 2014 to 2022. And the testing period was, of course, the following year, 2023, right? So the way that we have selected includes, I mean, the idea is we represent technology sector, healthcare sector, energy sector, and the banking sector. So based on this selection, then we study how the data set, say, helps us for prediction, as well as how the architecture helps us predict the data set. So basic data analysis shows that the average volatility gives some, say, numbers between, say, multiple different sector. For example, the technology and the banking sector seem to have similar number, but the real volatility, if you look at it through this plots, they are varying quite a bit. For example, the Apple is kind of over a period of years, not highly volatile, but then in the recent past, it has been very high. Whereas the JPM shows high peaks and troughs, right? So kind of the volatility is quite varying. That can be seen very easily from this Bitcoin, say, the volatility plot here. So the changes in the volatility over the years are very different, right? So with the encoder-decoder architecture, what we have here is, like, we decide on the number of units, say, for each level of the encoder, say, part of the encoder-decoder architecture. So we decided with 200 units to start with, 100 units, and then, say, 80 units, and then that's it. Like, then we move on to the decoder section. Going deeper, right, it only increases the amount of work to be done, and also the issue of the gradient, say, descent curves happens here, right? So this is after multiple different experiments, we decided on the number of units and the levels. So we have 3 levels here, and then first level had 200 units, and second 100, then the third one is, say, 80 units for the encoder's part. So we have this encoder that get, say, this is the data flow, say, process for this is AE-LSTM expression for the autoencoder-decoder LSTM architecture. The GRU also has a similar, say, features, 200, 100, and 80. And then again, as I mentioned, 200, 180 is decided based on multiple different, say, trial and error technique. So with this data flow, the encoded structure simply employs several stacked LSTM layers to identify latent features at various, say, compression levels. That's the important thing. So with each level of compression, the architecture, of course, learns more prominent features. So such a deep architecture, of course, results in high reconstruction loss and is susceptible to vanishing gradient problem. That means when you have multiple, more than say 3 levels. In our case, of course, we stopped at 3, but if you go like 5th level, 6th level, the loss, reconstruction loss really increases and also has this vanishing gradient problem, as I mentioned before. And as I said, the number of layers that we use was 3 layers. Exceeding it causes decline in effectiveness and rise in model complexity. And then the number of units were based on some trial and error approach here. So the activation function that we use, 3 of them, like ELU, exponential linear unit, rectilinear linear unit, and the hyperbolic tan, right? 3 of them. And for each of these, say, different types of stocks, general stocks, stock indices, and the cryptocurrencies, and for the different, say, hybrid models, say LSTM or AGRU, we compared the performance and then decided that for ALSTM or for general stocks, ELU, exponential linear unit, seems to be working better for, say, activation function. So that's again like first few tests that we did. Based on that, we finalized that these are the best way to go. And again, another hyperparameter we had to consider was the optimizer technique. So it is a crucial algorithmic, say step in order to optimize the machine learning and deep learning algorithms in general. So after extensive hyperparameter tuning, again, we conducted by a grid searching, right? The Adam optimizer showcased highest predictive efficacy in this case. So we had like the next, of course, hyperparameter was the epochs, number of epochs. So we had like tried 60, 70, 100, and 300 for each of the epochs, but then 100 iterations seems the best for our purposes. And the batch size was 64. And the time window was 120 past observations. Then we rolled that 120 day 1 to date 120 and predicted 121. And then day 2 to day 121, predict 122. So we had the rolling window for 120 days. As I mentioned, the grid search was used in hyperparameter tuning. Right? So here the quick say plots on the price prediction. Of course, we don't make much out of these plots unless you say analyze each one of them carefully enough. But then putting that in number will help better. So for example, so here are the numbers here, right? So for the with the AGRU algorithm or AGLSTM algorithm, these are the errors for different say stocks like Apple, the Johnson & Johnson, and the JP Morgan here. So we, for stock index, like the proposed AGRU architecture significantly outperformed ALSTM with an impressively low MAPE of 0.1%. I think it is not shown here, the stock index. So what we have shown is Apple, the anyway, so the one it is not here because for whatever is here, we can read the performance AGRU seem to be performing the best for MAPE or other say metrics, error metrics for all different say components that means in our data sets. So AGRU seems to be showing better results than ALSTM. And for stock index, also the AGRU significantly outperformed LSTM, though it's not shown here. And for cryptocurrency, which is not shown here in this table, the proposed AGRU also exhibited superior performance for the ALSTM architecture. with a MAP of 0.5%, which is half the value observed in ALSTM. So it's all shown here in the figure, but then we can capture it as data, but that data number, actual numbers are not shown here in this particular slide. So these are the, of course, metrics, mean square error, the standards, root mean square error, the absolute mean absolute error, mean absolute percentage error, and the R square. So these are the typical, say, error metrics that we normally go for. So basically the AELGRU, that means the hybridized machine learning with autoencoder, machine learning GRU, machine learning that is technique with autoencoder, seems to outperform in terms of the price prediction. So once we have the price predicted, we wanted to now build the portfolio and then try to diversify for, say, better return, right? So multiple clustering techniques are tested for improvising the resiliency, both traditional data-driven portfolio techniques. So that's the second study. Other than most used clustering algorithms, rarely use DB scan and affinity propagation algorithms are used in portfolio optimization. We show that these two are showing better, say usage and better results for portfolio diversification and profitability and portfolio design through both traditional and data-centric strategies improvise this challenging market situation. So this work is also published in Computational Intelligence Financial Engineering, that is called CIPHER conference last year that was. So the data set involves a multiple number of, say, stocks, 35 stocks from 7 different sectors: technology, consumer, say, sector, energy sector, automobiles, pharmaceuticals, supply chain, banking, right? And the time frame that we chose was 2019 to 2022. So these were all popular stocks from each of these different sectors. Okay? So that we select manually based on, say, the market value for these stocks. So that's why we decide the popularity. Whereas the same question, we don't have to do manually by asking LLM in the second part of my talk. The LLM picks these stocks, right, from the S&P 500 set. So again, the resiliency and portfolio optimization with clustering technique is the most important thing for us in this study. So we have different clustering technique, which means market structure is really dynamic and the cluster formation is changing and cluster structure is also changing in this case. So this table actually, this table 5 summarizes, table 4 actually, we have this table 4, we have the selected stocks and cryptocurrencies, which have in non-normal say distribution. Generally, these stocks don't show a normal distribution, right? With heavy tail skewness and high cortices, that is the third and fourth moment. So that's the thing that we need to be capturing in order to make better prediction, which necessitates the integration of high order moments in our risk measures, right? So that's importantly required to make better prediction. And this table, figure 5, which has all different clustering techniques for all the different years that we have, different clustering algorithms, of course, function differently, resulting in varying cluster numbers for different years. So that's one thing inconclusive, so to say. For each year, this study has considered 2 different portfolios. From each cluster, of course, once we form the cluster, we'll see how to form the cluster. Once we form the cluster, the stock with the highest, say, mean return is put into one group called K01, and the one that are doing the second high, showing the second highest return, mean return, are grouped into second portfolio, K02, it's called. Okay? So here's this covariance matrix that we first have to build in order to calculate the returns, right? The covariance matrix is calculated by this, and the stocks, the 35 stocks from 2019 returns only for adjusted closing price. So there are multiple other features for these, say, dimensions for these stocks, but then we only picked up the adjusted closing price. And we have, of course, 252 working days, trading days in a year. So we have 252 by 35 matrix size, right? So to calculate the covariances and from this formula. So this finally give us a square matrix of 35 by 35. So that matrix is going to be fed into these clustering algorithms, any of these clustering algorithms, which gives the number of clusters that could be formed. So for example, k-means gives 12 cluster groups, and which we, as I mentioned before, top performing say stocks in the cluster in one group, second top performing say stock in the second group, right? So we have 12 clusters formed here. So the assets with the highest mean returns were selected from each cluster, K01, and means with the second highest means returns with K02. So we have used also other clustering techniques such as WCSS, or within cluster sum of squares, and reachability plot is used to finding the epsilon in the DB scan. Affinity propagation clustering technique does not, of course, require predefined cluster numbers. So from our data, the analysis suggests that 2022 with negative mean returns, 2020 showed profitability, especially for the technology and health sector. So 2022 became a bit more challenging year for trading of these different, say, stocks. Some of the results that we are seeing here includes this table. Of course, I'm not sure if you're able to fully read it. This simply presents the performance of different clustering algorithms in conjunction with the equally weighted and the inverse equally weighted say portfolio in different years. So these are like for both groups, like, so this is the equal weighted, that is inverse volatility weighted portfolios, these two groups. This is the two traditional techniques. They're not fully reliable for 2022, which is a risky year, seems in this case. Okay. And for the figure this 9, where the another traditional techniques, mean variance optimization, and 10 also mean variance optimization. So this is for with different clustering for 2020 and 2022, 2 different years here. So the effectiveness of these diverse clustering algorithm for 2020-2022 reveal the consistency, consistent portfolio outcomes on different efficient frontier in these figures. 2022, of course, the clustering algorithms demonstrate somewhat comparable performance characteristics with the other say clustering techniques that we're going to see soon in the next slide, I guess. So the from here, the constraint portfolio optimization, one other like clustering, the traditional one showed this 12 market for 2022. The portfolio created using the DB scan and k-means clustering outperformed those. So the k-means is the first one, and this is the hierarchical clustering. I don't think you are able to read that. So this one is the CPO for k-means. This is for the DB scan. This is for the affinity propagation, and the last one, okay, I think I should be pointing here. So this is your k-means. This is your DB scan. This is affinity propagation. This is a hierarchical clustering. Right? So the CPO indicated less favorability or with the affinity propagation in general in this case, especially during this 2020-2022. So the in the figure, this figure 11, actually, I was saying it was capturing 2022, 12th year, which with DB scan, which is this one, right, and k-means both, right, outperformed those using hierarchical and AP algorithms. So it means that's what our major observation is. Each clustering technique was behaving better, or say predicting better, or sorry, diversifying their portfolio better way for better return than other, say, clustering technique in a given year, right? So in figure 2, the constraint portfolio optimization extends the MBO by simply accommodating the risk-averse investors constraint. That means additional constraint, basically a threshold for, say, either say selling off or buying more, shaping a customized framework. So clustering algorithms, of course, showed similar performance in the mean variance optimization technique as well. But CPU in this case indicated less favorability for affinity propagation in general, right, for these 2 years, 2020, 2022. And then this figure also highlights suboptimal performance of the constrained portfolio optimization with the affinity propagation. So this one is the affinity propagation, and the left one is the k-means. So how do we see performance? So on the y scale, on the y axis, what we have is the annualized returns, right? So the numbers here, the blue and the red ones, so red ones are the K01 portfolio, which was the top performing stocks grouped into that from the clustering technique. So we grouped it into one portfolio, and K02 is the second, say, best performing stocks, right? So guys, that's the blue ones here. So I think the scales are slightly different. That's why they don't look very, say, informative. Oh, sorry. So I don't know why it is simply jumping off, right? So the observation that CPU with affinity propagation for 2020 compared to k-means is giving suboptimal performance in this case. That means the effectiveness of the affinity propagation is somewhat limited for the constrained portfolio optimization. Again, it might not be generalized for every year. This is only for these 2 years, 2020, 2022, because each one is showing better performance on particular, say, with particular technique on a given particular year. That's how the data distribution, say, is. Right? So this is, again, more results, investigation of the clustering algorithms, basically. So the soft ratio optimization, that means the return over the risk, right? For the risk-adjusted return using excess return to volatility. So that means return over risk, right? That's the metric for the Sharpe ratio. The application of this diverse clustering technique, right, significantly, of course, improve the performance of SRO. So what we have here is all the techniques, the k-means, the hierarchical, dbScan, AP, right? That is of affinity propagation, and each one showing different numbers for the different, say, clusters, K01 and K02, sorry, portfolios, K01, K02. So the main, say, observation from here is that for 2020, year 2020, k-means demonstrated superior risk-adjusted profitability from these numbers. 2020 k-means gives better, say, annual return or Sharpe ratio, high ratio, etc. Right? So Sharpe ratio has to be higher, right? So that means it is a better behaving technique there, and other clustering algorithms. So this table gives that kind of information here. So again, observation from this, say, results for diversification, again, for specific to particular year. So 2022, the data-driven approach without clustering algorithms. So that means, let me see which one is the, so this is annualized return for portfolio return. So this is, so yeah, sorry, is right here on the caption. This is without clustering, and this is with the hierarchical and the AP clustering. That means the affinity propagation clustering technique. So without and with clustering here. So without clustering, it showed limited profitability, whereas with the clustering techniques, we could get, extract better, say, information from the data, and then diversify better, and then get better return in general. Right? So likewise, the integration of the diversification through other clustering techniques significantly enhance this profitability in general in these cases, based on these two different portfolios. Right? So this the figure 15, where data-driven approach with different clustering algorithms for 2022 year simply illustrates again superior performance of a hierarchical clustering an AP-based, that means affinity propagation-based portfolio construction for particular year 2022. Right? We couldn't make a very generic, a general, say statement about, okay, this technique does best result, best performance for all years. No, we can do that. So this is the third one, which I'm not going to explore. This is the one slide on that, resiliency in portfolio and with clustering techniques. So we did the diversification as key factor for improvising resiliency from the previous study, which we then used it to K-means clustering with the K-means clustering and experimented for improvising the efficacy of traditional techniques. And then the resiliency in the traditional PO were improvised using K-means for data-driven portfolio strategies. And this is another paper published. It was last year again. And this is again fourth study that we came out with, the deep learning-based portfolio optimization model. So this is also published in a journal, actual Journal of Mathematical Finance. So this is the architecture for the last study that we had. Like we had input data, pre-processing, and then we had both by LSTM, by GRU. And then we do the predicted values into the pre-processing stage, and then through the affinity propagation, this one of them, right? So this is affinity, we can always replace it with other, say, clustering techniques. And then through the data-driven algorithm, find the final diverse portfolio of stocks. So this is the, without the clustering, we have the non-diverse portfolio of stocks. So that's what the architecture of this particular report was. So what we have in general conclusion is this: the encoder decoder based RNN architecture significantly, of course, improves prediction accuracy or predictive accuracy across various financial assets. The machine learning driven diversification strategies enhance profitability, and the integration of deep learning and data driven approaches introduce novel diversified portfolio optimization strategy in general. Again, we could not, of course, make definite conclusion about the effect of the clustering techniques in this case. Some of the limitations, of course, we did not include some of the practical, say, issues such as interest rate, traditional transaction costs, fees, etc., which could be, say, it could be included for, say, making better, say, accurate measure of the predictive power of these techniques. And then further research could also explore various correlation methods to assess the impact on clustering algorithms and profitable diversification. And then, of course, the autoencoder based modification, both LSTM and GRU models were introduced, but further investigation is needed as the study only uses adjusted closing price. As I mentioned before, there are other features for each stock, right? Open, close, volume, high, low, all the multiple different things, without accounting for interaction with highly correlated stocks. So that means we could also try to include the what do you call, the pace trading, or the behavior of one particular stock on, say, other stocks in the same sector, right? So that kind of study can also be now done in this one. As an extension of this week. So moving on to the second part of this talk. So this is the large language model. Is it a new tool for portfolio construction? So what we intend to do here is to explore the capability of the large language models in one of the financial subdomains for portfolio construction. So what we have seen in the first part is we're putting a lot of effort in order to build portfolio. First, to construct the portfolio, we had to do the prediction, and based on the clustering techniques, group them and then build portfolio, right? And then try to optimize. Here, we are trying to do the same thing, but using the large language models. We want to leverage large language models with advanced few-shot prompting technique to explore the capabilities, say, for creating diverse financial portfolios. But in this case, again, like in the previous part talk, that is we had two groups like K01, K02. But here we also try to form two groups. One is, two portfolios. One is a high growth portfolio, The other one is low risk portfolio, right? So that's our objective. So we utilize the large language models where the APIs for portfolio construction. In general, financial studies, if you see, most of the studies are using ChatGPT models. So the one that I mentioned 3 weeks ago in Concordia University, there was a generative AI in finance conference. So most of the papers were talking about the ChatGPT only, right? For what we did was to look at all the different, say, other models that are available free. So that, for example, OpenAI itself has 4 different models, like the latest one being the ChatGPT 4 Omni, right? And then there is Mistral AI, Mistral Large 2, Anthropic, which is Cloud 3.5 Sonnet, and Meta has Llama 3.1445 billion parameters, and Google has this Gamma to 9 billion. Of course, these were this study, these results that I'm talking about is at least like 4 months old. So these models have evolved quite a bit, right? Quite a bit in terms of number of parameters, in terms of the capabilities, in terms of power. Everything has improved, right? And the training data for these models were up to 2021 in, say, with the ChatGPT 3.5, whereas ChatGPT 4.0 was October 2023. Mistral up to August 2023. I don't know. Anthropic, April 2024, and Meta was December 2023. And it's all proprietary. Some of them are open source, and the number of tokens that they could generate is this much, like 16,000, and maximum output tokens are also mostly like 4,096. And the release date, like when this particular model was released, again, since as I said, last one we looked at was July, so that means easily 6 months, close to 6 months now. So lots of things have changed since then. So what we do is to utilize these latest frontier LLM models in the market via the APIs, and then we introduce few short prompt engineering, do some iteration, gather results, and then parse them into JSON structured data structure or data cleaning, and then evaluate with our own, say, metrics, like the one that we introduced, like the annual return, annual max return, etc. And then we also use this chain of thought process and few short prompt engineering to enable this in-context learning to utilize the model's knowledge base. So we'll see what they are. So the chain of thought is simply a prompting technique which guides language models to break down complex reasoning tasks into step-by-step thought process, so that we ask the LLMs to first do this, then do this, then do that. Like that's the chain of thought process for that. The way that we want to say the results to come out, right? Supposed to be something that we envision. So here is a quick example of prompting, say with few shots. So for example, instruction given is create 2 hypothetical funds using S&P 500 tickers and explain your reasoning, right? The first step is to select 20 tickers from the S&P 500 index for each portfolio, and then allocate weights to each stock, aiming for higher returns than the S&P 500. Ensure sum of total weights is 1 with different weights for each stock. So this is when they fail, they couldn't add, and then they couldn't make it to 100. So we had to make some adjustment to do that. Write your tickers in dictionary file. That's the like a pair, like key value pair kind of thing with their respective weights, tickets and weight. And then the output is going to be looking like this, right? So once we give this instruction, the output is going to like ticker 1, weight 1, ticker 2, weight 2, etc. Right? So then that should also give the rationale why it selected this, that I selected these. I mean, this is coming from the LLMs, right? The result coming from the LLMs output. So I selected these companies because they are leaders in high growth sectors like technology and healthcare. The weights are based on their potential to outperform the market. And the task is to create 2 hypothetical funds using, say, S&P 500 tickets. That's all the instructions given to the LLM, right? So something similar to what we're doing in the previous first part, right? So number of portfolios per iteration, that means each iteration return 2 portfolios. There's high growth, low risk. Number of iterations per model, we did 100 times in order to be consistent, right? Number of models used, we have 8 of them. So total we had 1,600 portfolios. So number of tickers per portfolio, of course, we had 20 tickers. So total we had 32,000 tickers, right? So that means total number of portfolios 1,600, total number of tickers 32,000 in that data set. So then these parameters generally used in this large language models: top fee, temperature, max tokens, right? Top fee is basically controls the diversity by selecting from smallest set of tokens whose cumulative probability exceeds the specified value. Again, we have to specify which one is default. Temperature actually adjusts the randomness of the token selection, with higher values increasing the diversity and lower values making outputs more focused and deterministic. And the maximum tokens limits the length of the generated text by specifying the maximum number of tokens the model can produce in response. Right? So this is the kind of standard 4096 for many of these models. So some models can produce more, for example, Claude 3.5 Sonnet, and some models can produce less, for example, ChatGPT 3.5 older ones. Okay? But we kept it for 4096. So the results showed, like from the models, total, say, tickers occurrences from ChatGPT for Omni, right? So this is the total occurrences of individual stocks of Apple, for example, occurred in 50 different portfolios, right? So likewise here, UPS, the last one, figured in only maybe like that was 2 different portfolios. So it's not sexual. So now, based on these occurrences of these stocks in different portfolios, we pick only the top 20, right? So then, because it is going to pick top 20 stocks with occurrences of high growth portfolio. So here are the results that is coming out of these LLMs, right? So sorry. So we have Apple, MSF, the Microsoft, Amazon, etc. So the rationale that is given by the model is that the portfolio is designed to capture the growth potential of leading technology, consumer discretionary, and healthcare companies. It includes dominant players in sectors such as software, e-commerce, electric vehicles, etc. So it gives us the reason, right? The why it selected these 20, say, stocks. And for the low risk portfolio, these are the stocks that it took, which is the Johnson & Johnson, the JP Morgan, etc. Like multiple different stocks, and it gives the appropriate reason why, say, the model selected this. So then, based on the in-date and out-date testing, in-date means the model trained with a data set. We saw the end date up to which they were trained, particular date that they were trained. So any data beyond that date, it's considered outdate, say, data, right? So in-date testing, for example, for first portfolio, that is high growth portfolio, Llama 3.1 with 405 billion parameters is giving very good, say, performance returns, like example, annualized return. And okay, so all the different metrics that you see here, annualized, all the things that we mentioned in the first part of the talk, annualized return, annualized volatility, and then the Sharpe ratio, beta, alpha, all the different things, value at risk. There are multiple such, say, measures that we have. Right? So based on all this, the Llama 3.1 is showing much better results. So which, of course, with not much effort that we put like in the first part, right? And same thing is good for outdate testing. Cloud 3.5 Sonnet is doing good, right? For high growth. So for high growth, the models are, the large language models are seemingly doing better. When it comes to the low risk outdate testing, right? That means whenever you train data with the models with out of date say data, they don't do well. So S&P is still figures better, right? The returns coming from S&P is much better than the other models here, as you see numbers. Of course, I don't know if you are seeing the numbers there. So the idea is that there are still models, the scope for these models to improve. Of course, these are really constantly changing every other day, every day or every other day, these models are improving. And they have this inline thinking, processing, all that happening in these models for doing a better job of, say, this kind of, I mean, any different application. In this case, the financial application for portfolio construction. So the second phase, what we did was to introduce phases and then give tasks one after the other. For example, assign weights to two given hypothetical, say, funds of 20 stocks for S&P 500 index, and explain your reasoning. And you are an expert in financial analysis and portfolio management. So that's what we are declaring, that the long LLM is an expert. And then we give the task in a particular order. So that means your task is to distribute the weights to two given portfolios to maximize returns, and mention the weight of each stock in the funds, and the total weight should be 1, that is 100%, and ensure the total of all weights equals 1.0, right, means 100%. Aim for higher returns than S&P 500. So that's specifically we are forcing, okay, you always have to go beyond S&P 500. And then the output going to be looking like this. So we again got the results here. Now, even after this, say, few short prompting with the sub chain of thought process, for the low risk portfolio with outdate testing, S&P is still on top. That means none of the models were able to beat S&P returns for all the different metrics that we have, including maximum drawdown, value and trace, beta, alpha, annualized return, and best volatility, right? While for all other scenarios, that means for high growth, both in-date and out-date testing, and for the high growth with out-date testing, large language model doing better. Right, so it simplifies, say, for example, money market or the market managers, money managers' job in, say, managing the money by, say, putting it in multiple portfolios if they use this large language model. But of course, they still have to do these tests, the result to confirm that they are really doing better by externally, I mean, collecting the results and then doing these things externally. So with a normal llama, so of course, the models of what we have is in-date, out-date testing, but then there is another one, of course, most of you would know, is the retrieval augmented generation. So the one particular model that is doing better, this Llama 3.5 here, we use the Llama model with and without RAG. So see how the construction of the or the portfolio diversification happens. So we see like technology was 30% without the RAG. Here with RAG, it becomes 17%. And there are a few additional, say, sectors joining in with RAG, the retrieval augmented, say, generation into the portfolio, right? So that's one other additional, say, feature that we can make use of RAG. And then now there's a new technique called agents, and then multi-agents, they're all coming. So that's why this work has become almost like old, like very old within 6 months, right? And then again, the total return, we can see that again, for the blue one is the Llama 3 with RAG, the one here, the top one, Llama with the retrieval augmented generation, and the next one is the Llama with the normal generation, and the last one is the S&P. So we are able to see the better returns coming from the Llama with RAG, that means retrieval augmented generation. So that's for 2022-23. This is for 2024. Both are showing better results there. Conclusions: large language models like Claude 3.5 Sonnet or Llama 3.1 effectively create high growth portfolios, which are outperforming S&P 500, focusing on technology, healthcare, innovation sectors. LLMs face, of course, challenges in constructing low-risk portfolios, and also the prompting, right? You have to provide the appropriate prompt and the steps or the tasks to construct this kind of portfolios. Only then you will get a better results, otherwise you are not. So prompt engineering is really an important step in this case. So with different prompts, of course, you might be getting a different set of results. Optimization, of course, include LLM's performance in high-grade portfolios. LLMs show promise, of course, in growth-oriented asset management, but need refinement for low-risk strategies. So future efforts, of course, should focus on incorporating real-time data to better balance risk and return. So right now, these data set that we have, these models are trained on are sometimes old. So many of them are still old, but if you make it real time, then it would be really, really good. So our contribution has been to demonstrate the capabilities of LLM, analyze the performance, recommend state-of-the-art LLMs to construct portfolio. So of course, this is one part of the work that we did. Following that, we continued this further and then did more elaborate studies with RAG and agents, and we submitted this paper to the upcoming CIFER, which is Computational Intelligence Financial Engineering Conference. That's next year, next March. So we're waiting for the results. And we did not, of course, rely on ChatGPT models alone, like in other researchers, but we use seven other models here. Okay. So they are things like, of course, big box, right? Black box limitation. They are not good at arithmetic and math. Adding RAGs and other methods, more accurate responses we will get. So one example of the RAG addition, what I showed in the last 2 slides. So these are a few of the references here. Thank you.
All right. Thank you, Dr. Tulsiram, and for your valuable and the advancement in AI and LLM area. Our audience must be enjoyed your talk. So I can see Dr. Islam, your hand is raised. Do you have any question?
Yep.
Thank you. Thank you. No, it seems that I was like to just mention something and I forget to raise. Thank you for the presentation, Doctor. Thank you. It's our pleasure.
Okay. All right. So from the audience, feel free to unmute yourself if you have any question, and you can ask if you have any question or comments to Dr. Tulsiram. All right. Seems like nobody has no queries. So I'd like to thank Dr. Tulsiram, and he's a professor at Department of Computer Science at the University of Manitoba, Canada. Thank you so much for your time for this event.
Thank you for the invitation. Thank you for the nice audience here. Thank you.
All right. So our next speaker, Dr. Ron Arkin, he's here. So I'd like to welcome Dr. Arkin. Thank you so much for joining this session. And I'd like to introduce Dr. Arkin quickly. He's one of the high-profile professor, and we are really glad to have him. He's a professor of emeritus at Georgia Institute of Technology. He has long history of research in academia and industry. He has experience working internationally in famous institutes. I can see he contributed as a professor at Center for Autonomous System at Royal Institute of Technology, KTH, Stockholm, Sweden, He's also chair the Sony Intelligence Dynamics laboratory in Tokyo, Japan. And he's also member of the Robotics and Artificial Intelligence Group at LAAS CNRS in France. So we are very glad to have you, Dr. Arkin. Thank you so much. Please start your presentation. You are mute, kindly.
Thank you. Can you see my screen now?
Yes, and we can hear you as well. Thank you.
Very good. Thank you so much. And thank you for inviting me to this. Running a little bit late, but we'll see what happens. Okay, so I'm going to talk to you today about a very common phenomena in nature, certainly, which is the notion of deception. You might not be aware how frequent it is and how often and crucial it is actually for survival of biological systems. And much of the work we've done over 15 years or so, studied machine deception in particular and robotic deception. So I'll be talking about a variety of different projects in that space. Should take about an hour or less. And I hope you find it interesting. So the first question that, and actually let me bring this up here. Okay, you can still see the screen, I presume. Okay, so one of the aspects, as I mentioned, it's everywhere. And one of the important things in primates is the notion of theory of mind that, for example, I guess I'm a primate and you're probably primates out there as well too. So you may think you know what I'm thinking. And so you have a theory of my mind, and I may think I know what you're thinking. And that's crucially important for deception, because if we don't know what each other is thinking, it becomes very difficult to deceive somebody in that. Another aspect of deception is in some ways it facilitates social understanding. And as Dan Dennett, a philosopher, mentioned, he said that whether you like it or not, if you're looking at higher level capabilities from artificial intelligence, the opportunity for deception arises. It's a byproduct of intelligence. And whether you use it or not, or whether you control it or not, is an important aspect, and that deals with the ethical aspects, which I'm deeply concerned with as well too, and we'll talk more about that. The initial definition of artificial intelligence by Alan Turing is based on deception in the first place. It's trying to see, can a computer deceive you into thinking that you're a human being? So as soon as you do that, you may give the computer the right to think of itself as being intelligent in that point. But one of the things we're concerned with is the notion of social acceptance. In what's referred to in the field as human-robot interaction, we'd like to make sure that people and robots just get along. And sometimes the best strategy is not to be completely truthful, and we'll see that as time. So I mentioned animals use this, and there's an example of a broken wing bird display. That is a bird that is nesting in the upper right corner. And it's leading away a predator from its egg. This one, but down below, is a mother of a chimpanzee who is grooming her son, trying to be a good mother, one might think. And her son is actually eating. He's cracking nuts open with a stone, which you can see now. And in so doing, he is feeding himself. But the mother now stops grooming, and there's a saying, at least in English, that says, if you scratch my back, I'll scratch yours. So mom expects her back to be scratched as well too. And the good son starts to do that. But the mother kind of has an ulterior motive. She steals the stone and decides to use that for her purposes in this particular case. I hope your mother didn't do that to you. But that is one aspect of deception that can be used by animals. There are many, many, many others as well too. Even camouflage is a classic example as well. Humans use it in the military and for camouflage, as mentioned earlier. In American football, there's plays where you cheer when you deceive the other team into thinking you're doing something that you're not really doing. In regular football, international football, I'll call it, what we call soccer, it's the same sort of thing. You try and fake out your opponent to score. There's other deceptions, which is deception for the benefit of the mark. The mark is the person that is being deceived in this case. You can see in the lower left corner a particular instance where a child was refusing their carrots or whatever it was, and now is getting that food because a carrot is certainly better than a piece of chocolate in this particular case. In the lower right corner, it also, there's an aphorism, as we say, honesty is the best policy, but unless you want people to like you. So the notion of pure honesty is a questionable one at times. The military, Sun Tzu in The Art of War stated that all warfare is based on deception, and I've done significant work for the military, all unclassified research. And Machiavelli, paraphrase, stated that all deceit is detestable in all other things, yet in the conduct of war it is laudable and honorable. And so there's even entire field manuals in the US military talking about strategies for a battlefield deception. And you can see dating back to the Trojan horse there as well, too, as an example. Very commonplace in the military. One movie that tried to capture this was a movie called Interstellar. It had an interesting robot, as shown on the right in the left-hand figure there. And it has a dialogue here.
Hey, Tars, what's your honesty parameter? 90%. 90%. Absolute honesty isn't always the most diplomatic, nor the safest form of communication with emotional beings. Okay. 90% is.
So if you want a robot to, you want to trust a robot, you might not want to hear everything that it has to say. But what's interesting is you can set your honesty parameter in this particular case. That's one of the things that we looked at in our work. Lots of other folks have studied robot deception in a variety of different aspects. Brian Scassolotti looked at playing the rock, paper, scissors game, which you may or may not be familiar with. But basically, when the robot actually cheated in that game, people thought it was more intelligent than a non-cheating robot. It wasn't more intelligent, really, but people attribute intelligence to systems that can exhibit deception, whether they are technically more intelligent or not. And significant publications. And you know, all of you know that the internet is rampant with deception. It's everywhere. Your email, your messages, everything. So you have to be very wary and very careful about that. So what might be useful about this? And we studied this for around 15 years or so, looking at different models based on psychological interdependence theory, the handicap and dishonesty principles from nature and biology and bird behavior in particular, and other animals, squirrel, cache hoarding, and others as well too, which I'll talk about in a little bit. So what is deception in this context? Well, we like Bond and Robinson's definition, which says basically there are 5 steps. The agent that is trying to deceive basically lies, has a lie, and it needs to tell that, a false communication. So it transmits that information to what we'll refer to the mark. The mark is the individual or agent that is trying to be deceived. The mark interprets that information, and then the interpreted information influences the mark's selection of actions. The succinct definition is a false communication that tends to benefit the communicator, as shown in the asterisk in blue down below on the slide. So what are some of the highlights of the work that we did? Well, one of the things we had to allow the robot to do, which you really want with any robot, is to assess a situation, to understand its environments and what's going on. It also had to recognize when it was dealing with another agent, in this interdependence space, as it's referred to, is whether conflict with the goals exist with that particular agent. And is there a dependence upon what I do and what you do? Does what I do affect what you might do? And if both conflict and dependence exist, then the opportunity for deception arises. To be able to deceive, though, you have to build what we called a partial theory of mind by probing, asking questions or observing and understanding what the mark may do. You just can't throw out a lie and expect it to work. You have to understand how the agent may react to it, and then pick an action which induces a different outcome assessment, a false outcome assessment to the partner, so they do something different than what would normally be expected. So there are a bunch of results we published in this work extensively as well too. We showed that some situations warrant dependence, and the real key factors were the when and how of deception. This interdependent space is shown in that box there. The upper left-hand corner is maximal deception, where you best place to lie, if you will, where there's a conflicting outcomes, and there is dependent outcomes, as I mentioned earlier. So if those two things exist, there's a good reason to perhaps consider deceiving. If whatever I do doesn't affect what you do, in other words, you have independent outcomes, there's no reason to bother. And if you both get the right outcome, no matter what, there's no reason to deceive either in that case. So conflict and dependence indicate when it's appropriate to deceive. But it's not enough to know just when, you also have to know how. And so this is, again, that partial theory of mind that I was talking about. Figure out how to model the mark and use that as the basis for action selection to deliver to the model. We used a Bayesian network in this particular work. So this Bayesian network is crucial to determine what actions are the right ones to use at a particular point in time. And we can control the quality of the information contained in the mark and in the deceiver's model of the mark. And we used a game theoretic approach to basically do that. We looked at the true matrix. In other words, imagine a situation where you were playing dead, and if you play dead, it was really going to be costly in this particular case. If you don't play dead, it didn't matter. But then we try and induce the agent to think that playing dead has a very high value, and thus it would play dead, and you could do what you want under those particular circumstances if the agent stopped running under those cases. This is an example we used in hide and seek for some of the work. This is work with Alan Wagner, who's now a professor at Penn State. And what we did is a very simple experiment at the time. We had small robots which would knock down markers. This is kind of like Star Wars 4, which is Star Wars 1, where R2-D2 was trying to hide at the beginning from the soldiers. What we're doing is, in essence, setting up a false trail. You can imagine doing this in the woods, for example, if you want to mislead somebody. Set down a path one way, and then the agent would go another. This does it non-deterministically. Generally, this is very good for what we call one-shot deception. It will work once, but fool me twice, it's on me, sort of thing. And thus then the agent can escape under these circumstances. Fairly straightforward. And it doesn't always do the same thing every time as well. Sometimes it'll knock down a couple, but not the one leading to the particular path where you will be hiding. Okay, so we showed that in this particular case, when depends upon the interdependent space, as I mentioned earlier, and the notion about what the mark knows assists in what the right false communication should use, the deceiver should use. This is, again, the when and the how. And what we said on this initial result, these are what we stated in the results, that the results do not represent the final word on robots and deception. The results are a preliminary indication that the techniques and algorithms described in this paper can be fruitfully used to produce deceptive behavior in a robot, and much more psychologically valid evidence will be required to strongly confirm this hypothesis, published in the International Journal of Social Robotics a while back. And this was, I thought, relatively modest claims for this particular work. But what did others say? This was an article in the UK Wired. It says, "We made a terrible, terrible mistake. We've taught robots to deceive." Probably seemed like a good idea at the time, but when machines rise up against humans and the robot apocalypse arrives, we're all going to be wishing that Ronald Arkin and Alan Wagner had kept their ideas to themselves. And that was just a start. Ronald Arkin and Alan Wagner, two names likely doomed to live in infamy in a stunning display of hubris. The men, researchers from the Georgia Institute of Technology, published a paper on the foolhardy experiment to teach two robots how to play hide and seek, and so on. And says, everyone understands that Skynet can start differently every time, right? And then this one, robots capable of deceiving humans built by crazed boffins. I think that's the only time in my life I've been called a crazed boffin. But we did state that we understand there's a downside to this, and there is. But the important thing is understanding it and bringing to light the ethical implications associated with deception. And that's really, I'm a roboethicist for the last 20 years as well, too. And we are very concerned about how this can be used. But pretending it's not being used and pretending it's not happening is not the right thing to do. And it's very easy to implement.
We've assumed, folks, that robots were innocent servants until now. Scientists at Georgia Tech have taught robots how to lie, presumably to tell whoever gave them the research grant that their money was well spent. These Georgia Techs are the same brainiacs that last year built a robot that plays jazz. Now they've created a robot that can lie and say it likes jazz.
So again, the reaction was interesting. I was kind of a little worried about, I love Colbert, I still watch him daily, but I was a little worried about what my program manager would say when he said that. It was a Navy guy. And I said, well, what do you think? And he said, we want more. It was the answer. So yeah, it's interesting. But also, there was an upside to this. It was labeled one of the best inventions of 2010. And I would say it's not even an invention. It was just a bunch of algorithms as well, too. So it got some favorable publicity. But the one person that got it right, or group, a magazine that got it right, the press, was the New Scientist, because it said, exploring a robot theory of mind in these ways could tell us something about ourselves. Any computational code that supports the external behavioral properties of theory of mind and deception can help us understand what's going on in the human mind. That was our intent, not all the other stuff. But anyway, so that's how we got labeled both good and bad. Moving on from that, here's the more that I mentioned the program manager was interested in having. We looked at squirrels' deceptive behavior. You probably don't have squirrels all around the world for the people that are listening in other parts, but they're basically hairy rats. What they do is they hide their nuts in the wintertime in caches. They bury them in holes, and then they patrol them. They go back and forth, making sure that they're still there, so that no, what's called a conspecific, another squirrel or some other predator comes and steals their food. That's really important for survival. So what they do is they go back and forth, back and forth. But when they detect that another squirrel or something is present, they see it, they start going to empty caches. They start going back and forth to places where there are no nuts, to kind of delay the pilfering that could occur. Again, if you're in a military situation and you have ammo dumps, you may do this as well too, and parade in false places to accomplish that. We studied this in simulation first. See if I can bring, see if I can bring that simulation up. Go. Okay. We ran extensive simulation studies in a variety of different environments, showing how this works. And we had squirrels and competitors randomly place food in different locations and obstacles as well too, threw a conspecific in there to do that. And we studied how long it would delay the pilfering. The agents will eventually find it, but the goal is that if you're waiting for help, imagine troops crossing a border and you want someone to come to your assistance. Even seconds in some cases can help, where if you didn't have that, you may not be able to succeed. We did this with robots too, just to verify the underlying behavior. We did it first with a human on the left, being the predator in this case, and the other one we used a robot to do the same sort of thing, where basically instead of the basic thing is once the conspecific is observed, it switches its behavior to start going to the empty caches. Not very exciting to watch, but it verifies the simulation data on which we carried out. So you can see on the left, there is a significant delay in pilfering when deception is being used. and without pilfering, it is much faster. So this is an important aspect for certain types of applications in the military and other things as well too. If you want to hide your chocolate from your kids or something like that, you might think of putting it start looking at other places than where you usually hide it. But what's interesting about this is we got really good press on this, same sort of stuff. The articles we got were squirrels, birds teach robots to deceive. Georgia Tech robots learn deceptive behaviors from squirrels. Animal bluffs inspire a new breed of deceptive robots. No one's ready to damn us for the rest of our lives to eternal damnation by the fact that we studied human deception in this particular case. So things have calmed down a little bit, I guess I would say. And animals are capable of this as well too. The next one we looked at was something called mobbing behavior, which is based on a process called the handicap principle and uses deception via dishonesty. Mobbing behavior, there's some construction going on here. If you hear in the background stuff, I apologize for that, but it's out of my control. Mobbing behavior is what happens when there's a flock of birds and it's attacked by a predator. One comes present, such as a hawk or something coming into the flock. It has two choices. It can flee or it can harass. And it makes a decision as to which one it will think is most successful. To do this, the handicap principle states that any biological system that is threatened will communicate that it is fit. And thus, its fitness is honest all the time. But Zahavi, studying these birds in the Negev Desert and the like, said that this extends to all animals. But it's not always universally received. Greffen looked at something called the dishonesty principle, where they feign strength. Imagine a robot is just about out of energy and it's ready to defend something. Should it immediately run back and charge its batteries, or should it feign its strength in these particular cases, whether it's strong or not? Well documented, and that's in essence what's going on here. There are multiple examples of shows of strength by animals. The peacock is a classic one. It has this big, giant tail, which weighs a lot and which slows it down. And if there's a predator around, good luck. So you better be awful fit to be able to get away from that. Also, we could argue in certain cases, and the peacocks are looking to attract mates. That's a useful way to show you're really fit. Well, in human beings, one could argue that Rolexes are an example of the same sort of thing. Wearing a real Rolex shows that you are very wealthy. I don't have a Rolex, but if there's a story I like to tell with this. A man walks into a bar and he's wearing a Rolex, and he may achieve his goals of attracting mates in this particular case, and mating behavior may ensue in this case. Well, the thing we're interested in is a man walks into a bar and he's wearing a fake Rolex. Does that work? And how often does it work if there's a fake Rolex? He can't afford a real one, but does it still accomplish the goal? And then finally, one walks into a bar and they're all wearing is just noise. And so it means nothing at that particular case. And the fitness signal is gone. So we're interested in basically how many fake Rolexes work in a bar is the question here. But we didn't do that in this case. We did it in this behavior of prairie chickens. So it's another example as well too. And also the mobbing here, where we have a group of otherwise, if there's a fit agent in there, an unfit agent, is it worth hanging around because it may work? If you have a whole bunch of unfit agents and the other agent that is the predator cannot perceive that it's unfit, maybe that will effectively work. I'm going to take a second, and I don't know if that's bothering you as much as it's bothering me, but I'm going to plug in my headset. It's quiet for a while and switch over. So hang on a second, please, if you will. This and And let me do. Okay, can you hear me now still? Yes? Okay.
Yes.
Yeah. And I can hear you, so that's good. Well, I don't need to hear you. You just need to hear me. So that's the important thing. Okay, so let's keep going here. The results that we had based on this showed that when you have mob sizes that are pushed to its minimum number required to flee, then no member is attacked. But it's a very risky thing because if you're unfit and you are attacked, you're dead in this particular case. So this notion of bluffing, this is really bluffing is what we're looking at here, where small mob sizes with complete honesty is the best bet. But larger mob sizes, having some unfit agents can actually help under these cases. All this is published. But then we were looking at not so much for succeeding in deceiving the mark, but deceiving the mark to benefit those agents. And so how can a robot use deception in different human-robot interaction domains to benefit the mark? This is what's referred to as other deception. So there you go. It's typically used, for example, in search and rescue operations, where you may tell people help is on the way when help isn't actually on the way, or in the cases of injury, in triage, where you might tell somebody you are going to potentially get help, but you might not be having them on the way at this point in time, but it delays the onset of shock. So there's a variety of things as well, too. So these are just some examples again as well, too. These are reasons why we would use this for search and rescue and calming down people. But we used a different model in this case, criminology. Remember we talked about just when and how in previous methods. Well, we're interested now, not just when and how, which is method and opportunity, but the motive. There needs to be a motive as well, too. Why am I doing this? What's the reason for the deception? So these three components are the ones that we use. Why are we trying to help this individual? How are we going to help them? And we need an opportunity to be able to help them in these cases. And we also looked at two different classes of deception. If you're a Catholic, you're probably familiar with this, more by sins by omission and sins by commission, but deception by omitting something, not telling someone the entire truth. That is still a form of deception. You don't actually tell a lie, you just don't tell the complete truth. And deception by commission is sending, as we saw before, false information. The way we did this in this case was with small humanoids, looking at gestures that could be created, facial expressions in some instances, and the spatial separation that they could have. These were some of the examples. Oops, hold on. I don't know why that's not playing in all the instances, but there are different examples of this which show, well, let me go back and see if I can get the slide to work. Oh, I know why. It's not in a slide mode. There we go. Now it's working. Sorry about that. There you go. And you can see the different types of things, which are both those that show the true action on the left and the false action on the right. So those are generated in different ways. And we had different deceptions, so it doesn't become simple to decode in these cases. We use this in a pill sorting task for elderly people like me. They looked at this is a very important task, because if you screw up your pill sorting, you could die in this case. And people are trained to be able to do that. And this started to become part of the tutorial process, but using a robot to provide the feedback. There are ethical questions associated. Should a robot lie during this particular case? And we studied that in a separate study later. But the fundamental effects of robot deception showed that the one hypothesis that showed we can reduce the frustration level in the performance task by using deception, giving the false feedback on the performance. Not always saying good when you did good, and not always saying bad when you did bad, but in some cases when you did bad, saying, oh, you did okay. You ever do this in a classroom? Tell people, you're doing good, you're really, really good. And I had people tell me after these lectures, and feel free to do it as well too, that was a great talk. and maybe it wasn't a great talk, but I know you're the best audience I've ever had out there as well, too. It makes you feel good and makes you stay engaged, but maybe it's not true, but in this case, it's absolutely true. So there you go. Well, we looked at other things then. We started looking at deception in multi-robot teams. This is used, we studied wolf pack hunting in this particular case. And we looked at what's both pushing and pulling. How can you get agents to move? Pushing them from the rear, or like the Pied Piper, drawing them from the front. Looking at psychological studies in this particular cases, or actual wolf behavior to be able to accomplish this. An example of this was actually in January 6th, when our Capitol was being overrun by rioters, to say it modestly. And this agent, this policeman, started going up the stairs, leading these people away from the Senate in this particular case. So he was deliberately misleading them to go to a place where they could not cause trouble. And they followed him to do that. So there's obvious examples to be able to assess this. And so that's the Capitol riot was able to, a good example of that. So we looked at methods to be able to study how many agents does it take to get people to follow it. And there's psychological studies who've studied this. How many, if you see a bunch of people on a street and they're all moving in one direction, you don't know why. If there's enough of them, you might follow them. What the heck is going on over there? I have no clue, but I'm going to go there and find out. So how can you relocate large groups of people to do this? And could you do robots to be able to do that as well? And so the way you do that is not just with a single agent, but if you've ever heard about shills in deception, those are Confederate agents which are planted in the other agents that you're trying to mislead. So the real question is, how many shill agents could be embedded in this to mislead these robots to go to a different location? A single agent won't always work. But if you have 2 or 3 or 4 agents there, maybe they will go with you. You know, if people around you start moving in that direction, you may say, well, maybe I better get out of here, or maybe I better see what's happening. And so we had the push approach, which is how many agents does it take to get you moving from behind in this particular case to move the group, but how many agents is the other example is the pull approach. So we had the push and the pull, and this shows the push approach in this case with the agents behind it. Again, there was a system at Georgia Tech, which is called the Robotarium, where we're able to run these experiments on real robots as well too, in a relatively simplified environment, but it proved the value of the simulations. Again, we're trying to study how many shills is necessary to move a group of agents from one location to the other. Again, the data is here. They're all on our papers. Feel free to visit my website and look at publications, and there are literally hundreds of publications on that, but just do deception or misdirection and you'll find out what you need, or send me an email if you like. But of course, we're interested in counter misdirection. How do you break this? Imagine you have a group of people you're in a protest, and you're trying to get those people out of there. So you're trying to use this particular strategy. Well, you might have agents around too, your protest leaders, who say, no, don't go, don't go. But there's only one of you, and there's 100 people trying to move. How many shills can you plant in that group to defeat the process of the misdirection in this particular case? So what we did was showed we could plant these counter misdirection agents in front of them and break up the success rates associated with that. The number of shills and moving in front, setting up barriers to delay them. Doesn't always work. Some would leak through, but in some cases they would work, as you can see, at least in the lower agent model down there. It didn't work at all with just a single agent, but it worked with 3 in that case to slow down the success rate of relocating those folks. So we studied, another thing to study though is the effect of the leader's random motion in this. If you could not easily predict where the agent was going that was leading those people to the other side that you're trying to misdirect, then it becomes harder to set up a barrier as well too. So adding noise into the motion is very helpful in breaking down that counter misdirection strategy. Again, we did this on the physical robots. The CMA are the counter misdirection agents. They would move in front. The leader kept going because it didn't pay attention to the others, but the counter misdirection agents were able, at the very least, to slow down the progress of the misdirection in this particular case, of the deception in this particular case. So again, the more you have, you can slow down the misdirection, but I also mentioned that the random motion as well too affects the efficiency of this counter misdirection strategy as well. So obviously there are deep ethical issues associated with it. Should we even be doing this? Should a robot ever be allowed to lie? We study ethical frameworks drawn from deontology or Kantian theory. Kant has famously said that any lie is a bad thing. It's based on intention. So deceptive behavior is bad. They're morally incorrect. But utilitarian perspective, instead of looking at rights, which is the one, the deontology, utilitarian is consequentialist. It looks at the outcomes. If it increases the total benefits among the stakeholders, then it is ethically correct. So there's not even universal agreement on which framework is the appropriate framework to be able to study this. So one is, why should we be doing this in the first place? How can we be sure it's only used in an appropriate context? Is there an inherent right humans should not be lied to? And Kant would say, absolutely. But there may be times when deception has societal value. By lying to a few, it may benefit society as a whole, or even an individual, again, as I mentioned, in search and rescue operations. In some cases, that's a good thing. But even then, does that allow a robot to possess such a capacity? Well, I don't know if you're familiar with the IEEE ethically guided design effort and intelligent autonomous agents. I can't remember, it's IAS and the like as well too. We came up, I led the issue in deception in that particular case, and we came up with some general guidelines, which it can be acceptable when it's used for the benefit, and also it should be certified as appropriate if can be done. Obviously, that's not being done right now. And there's issues also which didn't make this the notion of whether you should opt in, opt out, or there's no way out in the creation of these things. And the last thing, I know it looks like we're running out of time, but we started 15 minutes late. So forgive me for those of you who think I'm going over time. I'm not. We did a recent project on robot ethics in looking at multiple frameworks and trying to understand what is the right framework. So we looked at two different cases as well too, in this case, with respect to deception in child game playing, the game Connect 4, maybe you're familiar with it or not, and in pill sorting task. Should children, a vulnerable population, be allowed to cheat, for example? Or should you be allowed to throw a game and to encourage a child to keep playing in this particular case, to deliberately make mistakes? In pill sorting, as we saw before, should you always be completely honest, which is a high-risk task? We made a high-risk task for children, which was jumping off of a diving board, this was only notional, into a pool and saying, I'll catch you, but you don't catch them. You don't let them drown, but you betray their trust at some particular level. And is that acceptable? Is that a good thing or a bad thing? It does encourage them to swim. And so we did surveys of two different types of people in these two domains. We surveyed average people, which leads to something referred to as folk morality, which is what people really think is the right thing in this case. I'm not talking about Kant or Bentham or any of the virtue ethics or any of those ethical frameworks. What's the right thing to do? And what are the expert opinions regarding those ethical frameworks? If you used Kantianism, what's the right thing to do? If you used consequentialism, what's the right thing to do? And so on. And we surveyed professors that taught ethics in there as proxy experts for this particular. The intent was to be able to decide, if you're programming a robot, what ethical framework are you going to put into it and where is it going to come from? What's the right thing for a robot to do in average day-to-day circumstances? So we used MTurk, gathered data in both of these things, looked at the different kinds of responses under different scenarios for the person that is the mark is made just a single mistake and is calm, or made a single mistake and got very frustrated, or they got a lot wrong and they were calm, or they got a lot wrong and they were frustrated. And the same thing for pill scenarios as well too. And we looked at the data that came from that, and we looked at virtue ethics, for example, and other examples as well too, which was a dominant response. Virtue ethics, for those who are not familiar with it, deals with building character in an individual and making them what is referred to as a good person, whatever that is, but they will do good things from henceforward. We built an architecture, a case-based robotic architecture, to deliver. On the left, you can see all the different kinds of case bases we could populate for different rules that would be associated with a given situation, whether they're excited or whether they're doing poor performance. And that would tell you what rules you should use in that particular case. And then the robot would generate happy or sad motions, just as we saw in the previous action. This shows, again, we can't show you the real subjects, but this is one of the students in the lab. We were doing this during COVID time, so it was very hard to get populations to do the HRI studies at that point. We got a couple of years extension, but still we weren't able to gather all the data that we would have liked with human subject studies. And then the robot, from this particular case, we used the utilitarian case base, determines that's a good thing to do in that case. So anyway, so I think I have a little bit of time left for questions if we like. If not, that's fine too. I hope get you back on schedule. Otherwise, if you want additional information, there you have it. My website is up at the top. The lab website is there as well too. I encourage you, for those of you in IEEE, I strongly encourage you to join the Social Implications of Technology Society. I served on the board of governors of that. It is a group of people and members who are deeply concerned with the appropriateness of all IEEE technology, not just robotics or artificial intelligence, although that seems to be dominant right now. Please, they have a magazine as well too. It's a relatively low-cost induction fee, I think, as well too, for that. For those who teach ethics and the like, there's a course online which I've used some stuff to try and help our students grapple with the ethical questions in artificial intelligence and robotics professionally that they will deal with. And with that, I will turn it back to the moderator. It's Ankh. Thank you.
All right. Thank you so much, Dr. Arkin. It's fascinating presentation and we enjoyed your talk. Especially, it's really inspiring when you give example from nature-inspired robotics with birds and animals. That's really fascinating. So floor participants, if you have any question for Dr. Arkins, please feel free to unmute yourself, ask, or you can post in the chat box, whatever comfortable you are. Okay, so someone requested the slide. I'm not sure how is the custom from IEEE, but this record has, this session has recorded. So I believe this recording will be available for members so far I know.
Which slide was I interested in?
The slide you presented today. Seems like,
all
okay.
The slides, okay. The real thing I might add to that is if you want the details, best bet is to go to the papers, the source, and get an understanding of what's involved. This is just, as you can imagine, a very quick and high-level survey of all that we've done in those 15 years on this particular space.
Right. Thank you, Dr. Arkin. And obviously, you marked the lab website, so feel free to visit. And also, Dr. Arkin already said, like, feel free to email him. So we appreciate that. Thank you so much. So anybody has any question?
There's a new message I see down here. Is that for me? Oh, just a compliment. Thank you.
All right. Seems like no. Dr. Halim, do you have any
Thank you. I'd
question?
like to thank Dr. Ronald. Thank you for the great presentation and moderation. Thank you for this great session.
All right.
You're welcome.
So I'm just like to ask one question. I'm sorry, I'm moderating the session, but we learn about LLM and multimodal data nowadays. So my question to Dr. Arkin, we know robots are very specialized. So can we use multimodal data? And as a human, we have a lot of different capabilities. Maybe I can draw, I can do math, I can recognize object, but not probably the best in all cases, but I have. So robots are still specialized. So can we use multimodal data for robotics?
Yeah, well, let me multimodal in the sense of sensors in the case of robotics as well too. Actually, in that very first study, we found something quite interesting, which was that the more modes of sensor that you have, the easier it is to deceive. Imagine, for example, you have no sensors. You can't deceive it. There's no way it can deal with anything. If you have one sensor, it's not quite as simple, but if you could introduce discordance into the sensors, the system becomes even more vulnerable under those cases. So that was something we didn't expect. We didn't think about it at the time. But part of it was building the model, the theory of mind that we mentioned before. So multisensory data does create better opportunities for deception, one could contend, because you can introduce, remember I talked about conflict as well too, conflict in the interpretation of the information, and that conflict alone can lead to that basis.
All right. Thank you so much. I really appreciate your feedback. So I'm moving to Dr. Halim. Thank you so much, and thank you, Dr. Arkin.
Thank you. Thank you so much. So I think we should move to our next session, which it's SYP session. So it will be moderated by our young students and young professional, Muhammad Al-Qasim. And it will be presented by Valder from Region 9. But by the way, I'd just like maybe to share with you some thing about Muhammad. Muhammad was the chair of his Jordan student branch CS chapter in Region 8, and they were awarded the outstanding chapter student branch chapter in the IEEE Region 8. So do some maybe great pictures from their activity I'd like to share and highlight it. And I thank him and all his colleagues. So please, Muhammad, if you'd like to say something about your activities and your chapter, please.
Thank you so much, Dr. Islam. Actually, it's really an honor to win such a great award. Actually, we have won 2 awards: the Outstanding Chapter Award globally, and the Best Chapter Award in Region 8. Having such an award within the computer society is really an honor to recognize the activities that we have been doing for the last year. So thank you, Dr. Islam.
Thank you. So the floor is yours, and you can present Valder and start your session.
Thank you. So good day, everyone. My name is Muhammad Al-Qasim, joining you from Jordan, and I'm delighted to moderate this session, part of the IEEE EXA DVP 24 online event. It's my pleasure to introduce our speaker, Mr. Valdir Ventura Filho. Valdir has been an IEEE member volunteer since 2013 and currently serves as the Vice Chair of IEEE CS R9 SYB and Treasurer of IEEE South Brazil section. He has also held significant leadership roles as the Chair of IEEE YB South Brazil and IEEE YB Brazil Council. In addition to his remarkable IEEE contributions, Waldir has over 10 years of experience in the IT field, specializing in IT financial management, FinOps, IT governance, and digital transformation across various industries. Waldir, thank you for joining us today. You can start your presentation, please.
Hello.
I think your voice is not clear.
I closed my camera because my connection, it seems, is not very well. But thanks for the introduction, my friend Mohammed, Professor Islam, uh, lots of people here that I know. So I'm happy to be here again. I'll share my screen. I have a small presentation here. So, well, let's talk a little bit about the computer society opportunities and SYP opportunities and activities as well. Well, as Mohammed already introduced me, I'm going to skip this line. Very well introduced it. Thanks a lot, Mohammed. So let's talk a little bit about general computer society opportunities. I'd like to present this because computer society has a lot of opportunities to student and young professionals. So I think it's nice for people to know as well as the chapters, even if it's student or professional chapters. The first are the three scholarships we have. So we've got the Merwin Scholarship, the Lance Stafford, and the Epsilon P Epsilon. So each one has its deadline. So the Merwin is we have 40 scholarships of $1,000. And to apply, basically, you're going to talk a little bit what you have done as volunteer and as student as well. And you have to have two recommendation letters. I'm going to talk a little bit about yourself. Lance Stafford is a scholarship about best paper. So if you presented a paper in a congress, so you should send to Lance Stafford to this award. And the last one is about high academic skills. So if you are very focused and have a high GPA, so you can apply to Epsilon P Epsilon scholarship. We have the deadlines here, so computer is really doing this effort for people to apply. Nowadays, main people that apply are from Region 10, so we want to grow the number in the other regions. Uh, After this, we have a few fundings. For new student chapters, we've got $150 if you are funding a chapter now. And we have grants, small, medium, and large grants, either for student branch chapters, or professional chapters. If it's a student branch chapter, you can ask $500. And if you are a professional chapter, you are a young professional in a professional chapter, you can ask up to $1,500. Also, another nice thing is the Distinguished Visitor Program. George is here, and he's the chair of this program, and it's really nice. We had in Brazil George here last month. He was in 4 cities doing like a DVP tour. It was amazing. So it's a nice experience as well. CS can help with the travel expenses, and you're going to hear from a really distinguished person something more technical and something really nice about computing. Also, another one is the Early Career Speaker Program that provides someone that is in a early career an opportunity to speak, and for the student chapters or the professional chapters, the opportunity to hear someone in early career. Uh, Another special programs that we may have or not is the diversity and inclusion project and program. This year it's closed already and it was evaluated, but we have the opportunity to have projects of to promote diversity emerging technology activities that we can ask up to $50,000. So that's the main funds we have here. And now I want to talk a little bit more about the Computer Society SYP, which basically Saptarshi, which is the chair, defines as this quote. SYP is a dream to empower every student and young professional across the world in the field of computing. So the idea here is to empower all the SYP people to do things and impact lot of people. And today we have 12 programs: the TechX, CSIS, AI, CS, SYC, SOI, Global Congress, Regional 8 Congress. Well, all of this one, and all of them are connected with the strategic planning of computer society. So if we're thinking about engage people and volunteers, we have the congresses in India, which are the congresses, Computer Society Indian Symposium, and All Indian Computer Society Student NYP Congress. The student outreach initiatives, which I'm going to talk a little bit more, micro-mentoring as well, and the Compute, which is our magazine. And if you want to grow, yeah, we've got a few events. The TechX, for example, the Global Congress, the Region 8 Congress, which we had these days in Region 8, and which was amazing. I saw the pictures. Also, we have the Asia Pacific Micro Summits and the Rooftop Socials to get us more connected with the industry. We also have the TechX, micro mentoring, climate and sustainability. Uh, this one is really nice initiative as well because it's really a hot topic talking about climate and sustainability. The rooftop socials as well, we connect to industry and the high impact events. So it's another opportunity to connect with the industry as well. And to foster diversity and inclusion, we have All India, the student initiatives, and all of this one here, which I already talked. So talking a bit more about a few of them, AttackX basically is an event that we can host, that we can combine sessions on emerging technologies. So we can talk more about technical part as well as soft skills, leadership. We can have industry engagement, for example, a lecture or a technical visit. Any committee at the GAC can organize, or even a student branch or a student branch chapter. And a funding to organize this event is up to $1,500. So it's really nice. If you want to know a bit more about, you can just go to the SYP website and look for the TechX. We had really amazing TechXs around the world, so it's a really nice opportunity. So the scholarship outreach initiative, as I mentioned, we have many people applying but we want more people to apply, and we want more diversity in the applications. So this initiative is to help people to apply, is to engage people to apply. For example, I saw we have Donna here, and Donna, together with Ariana and us in Region 9, held a workshop to help people from Region 9 to apply for the Marine Scholarship. So that's why the Scholarship Outreach Initiative is about, is to help the application of students to our scholarships. So if you need anything, or if you want to do anything, if you want to help people to apply, you should ask Ariana help. So it's going to be really nice. We can help with this. Also, we have the regional congresses, and I've got here your picture from Region 8. Basically, the congresses we have three, one in Region 8, one in Region 9, and one in Region 10. The Region 9 this year we call it global because we're supposed to get people from Region 1 to 7 as well. And well, we've got people registered but not attending. That's sad, but it was amazing. That's the picture of this year's Congress. And this is the picture of the Region 8 Congress, which was a few days ago, which was amazing as well, full of people. So this is a really nice opportunity to connect people. I didn't find, I think the Region 10 Congress this year still not happened, I'm not sure, but I didn't find the picture of this year's, but well, we have the representation here of Region 8 and 10, and 9, sorry. The micro mentoring is an initiative that join people which can be mentors and people who want a mentoring, a mentee. So it bring benefits to both of them. They can exchange experiences and talk about career and how can they can give them next step. So it's a nice initiative. The website is here as well. The climate and sustainability. Well, basically is as I mentioned, it's a hot topic today because the world need more care about climate and sustainability and everything. So the idea is to aware and to help in any way the society to talk about climate and climate changing and sustainability, how we can be more sustainable world. So yeah, our lead is the Sibel Ganem. Rooftop socials, well, it's another kind of event as well. It's more dynamic ecosystem. We can talk about something more technical, and after that we can have a networking session, conversation. We had a very nice one this year that we could put together industry, technical skills, and social as well, because we did this in IDEO in San Francisco, California, and we had a technical talk, a roundtable about Gen AI and everything. And after that, we had a coffee where the participants could talk more and know each other. So it was really, really nice. So it's a really nice event that we should promote as well. That it's a nice event to have. So basically, here there's a map of in planning slash completed events in 2024. Yeah. So you can see there's a lot that SYP is doing, not only in region 1 to 7, which is the focus here, but all around the world. So it's really amazing. And well, that's a little bit more about the SYP. I leave the contacts here. If you want to engage to know more about this, we have the contact of SAP here. He works at Intel. He's the chair today. And my contacts as well. I'm volunteer in the global committee, but I'm also the chair of SYP in Region 9. So if you have anything, any question, or if you want to contact, feel free. And the idea was to promote a bit more here about and talk with you if you want to know about anything or make any question. This is an open space for you to have this in this moment. Okay, I didn't want to make a huge presentation because I thought the focus was more the conversation with you. If you may have
Thank you, Alder. I think there is a problem in the voice, but we can get what you have said right now. Thank you for sharing your experience and expertise. Um, and please, if anyone has any question, feel free to unmute your mic and ask Walder. Okay, that's great. So, Walder, thank you again for this insightful presentation. Um,
Thank you, friend.
Thank you
If
so
you have
much.
any questions at any time, feel free to write me.
Yes, for sure. We already have your contacts. Thank you again, Walder. Okay. Dr. Islam, do you have any addition before we move to our next session?
No, thank you. Thank you. Thank you. We can move to the next session.
All right. Thank you everyone for staying with us as we move directly into our next session. It's an honor to welcome Prof. George Proler as our speaker. Is he with us, Dr. George?
I am.
That's great. Dr. George is an independent cybersecurity consultant with over 30 years of experience in the military, government, industry, academia, and public service. Within IEEE, he's a senior member and a distinguished visitor of the Computer Society, currently serving as a chair of the Distinguished Visitor Program. His contributions also include serving as a vice chair of the Awards and Recognition Committee and chair of the Distinguished Contributor Program. He's a recipient of the IEEE Computer Society Distinguished Contributor Recognition as a recognition for his exceptional technical contributions. Dr. George, thank you for joining us. The floor is yours.
Thank you. Let me see if I can figure out how to do this. Let's see if I can share. And share and share. Whoops, I guess got the wrong one shared.
We can see your screen clearly.
But I want to share a different slide one. There we go. This has all the fancy stuff on it. The other doesn't have the fancy stuff that I put in. Again, I'm George Proler. I'm the chair of the DV program and probably a couple of other things. But I really want to talk about the Distinguished Visitor Program and the benefits and take a look at, no, I can't get it to, well, there we go. All right, it's a gateway to opportunity. That's the major thing that we want to probably share with other chapters and with the membership. And we believe that the DV program provides exceptional value to members, affiliates, and not just the Computer Society, but we look to provide that to the general computing community and the general community. We deliver this opportunity by direct access to cutting-edge technology leaders. They do that with presentations. Now, I'm sure you can read this, but I just like to highlight some of the points. Presentations, conferences, workshops, But we can do that on ground and we can do that virtually. And we're finding that we can do more and more things virtually. The important thing here is facilitating interaction between and among chapters and members, students and professional chapters, and industry and academia. Students sometimes forget that there's great opportunity in getting involved with a professional chapter, that people get to know you. We look at promoting the value of society membership. One of the great values about that is networking. Again, the amount of people that know you. Many people have heard, and I've said many times, that there's this belief that it's not what you know, but who you know. And that's really false. It's who knows you. And that's something that we need that people have an understanding of who we are. And we say shortly that gets your telephone calls answered. But it also is when somebody knows you, they can then promote you perhaps for a job or for some other opportunity. And then we also look to recognize and honor those world-class academicians, leaders, innovators who willingly, and generously, they share their knowledge, their experience, their talent, but that most important commodity, I can tell you, that's time. And so they're willing to do that. And what we're saying is ask. And then we want to strengthen our outreach to chapters, especially those underserved, those that are having trouble getting viability, let's say, or having meetings and events. We can provide that. We can provide it whether it's virtually or virtually online, or whether we provide it with in person. I'll talk a little bit about what Waldir talked about with the going to the 4 chapters in Brazil. Here's the thing that you have available to you. This is a listing of DVs, and there are over 100 listed. And the really interesting thing is they're listed by their topics, their skill, their region. But any region can go after a DV in any other region. And if it's virtually, the sky's the limit. But here's the interesting part. This is a representative, full professor, the school, highly knowledgeable, multiple grants, multiple awards. But this is the important part for you to realize. He is able to be contacted directly. That's an opportunity. Why do we say visitor, not lecturer, not speaker? It's because we provide more than just a lecture or presentation. We provide that direct interaction between the host, participants, the attendees, and the DV. We're looking at moving toward hybrid events. We're looking at this event being hybrid in 4 locations next year, where we have concurrent on ground as well as this online event. We'll be, if you will, be broadcasting from 4 locations, and then those locations that have a few more things going on. The scope of a visit, it's mutually decided upon by the hosts, that's the chapter, and the DV. Presentation, conference, online, virtual, on ground. Is it round table? Is it more than that? And I'll talk a little bit later about one of the events in Brazil. Multiple hosting organizations, getting 1 or 2 chapters to work together. We've done that now with the Caribbean chapter and the up-and-coming Cartagena chapter. And in Region 9, I see more of that, especially with the 4 chapters that were involved in the most recent road trip. But we also want to enhance, again, between students and professionals, and industry and academia. Industry has a lot to offer. We find, though, that we're academia heavy. But we're also finding, too, that a lot of guys in academia are working in industry. But there's a lot more to share. Our mission, vision, and goals inspire success in membership and affiliates. Recognize and honor those tech guys and promote IEEE is essential to the global technical community. That's the big issue. And what does computer society do for that? We look at making people, the commodity, if you will, is people as engineers who can increase that global technology. And so we support that by providing services of distinguished visitors. We want to be the premier program selecting a group of DVs from that. I can tell you right now, this year we had 143 nominations. We have 18 slots. So there's going to be probably 100 folks that any other year, any of them would be welcomed as a DV that are going to get a letter that says, hey, I'm sorry, but competition was tough. And we took 18 and you were not among the 18. Please apply next year. But we're going to have to do that. That's the scope of what we have for DVs. And we look at informing, instructing, inspiring our members. And it's all through the career life cycle. It's from student to early career, mid-career. You're getting into twilight of career and then post-career. Because everybody has something to learn and everybody has something to offer. And direct interaction, online, virtual. So it's not just limited to presentations or conferences. Find that a lot of things sometimes get done in a side meeting, and those work also, and you can do those also virtually. Okay, the program, providing opportunity. We have committee, and that's Professor Islam. Now, if I was not a nice guy, I would just say he can take it from here, but I'll go ahead and finish this slide up. DV awareness and customer advocacy. Going out and telling the customer, what it is that we have to offer. What are those presentations that the DVs are willing to make? What is the scope of that? And then to ask you, what is it that you want? What are the things you want to hear? It was very interesting in Brazil. People wanted to hear about professional development. Okay, so we solicit the input of the chapters for ways that we can better support. That came about a couple of years ago when we had our first end of year outreach, and we reached out to a couple chapters, and wow, we took to one chapter and they became prolific. Really, they moved from a chapter that was about getting done, getting something done, to now a leader within their region and a leader within IEEE Computer Society. And then we show, as I showed you earlier, the web presence with the information cards. We do have one event, and that's this event. That's about the only thing that we actually execute. Other things, if you will, we partner with chapters, and the chapters are kind of the producers, and we supply the talent. Next year, as I said, this event is moving to a 24-hour hybrid event for concurrent on-ground locations. And I talked about the end-of-year outreach program to underserved. Teaming events, we've teamed with things such as the R8 Smart Conference and other events in Region 9 and 10. We have strong ties to the geographic activities and to student and young professional activities committees. We can provide program guidance. And you, the customer, the chapters, you're the overall administrators and you execute the event. As I said, we provide the talent. And then outreach to industry, both as future DVs and committee membership. Okay, it highlights a need for members and affiliates to work with industry and government. We are very, very heavy, if you will, on academia. A distinguished visitor appointment, once a DV, always a DV. We look at that and say, you've been selected, you've been appointed, you are a DV. We'd like to keep you on for more than just your initial 3 years. We'd like you to be an ongoing resource. I would love to have 200 or 300 DVs available for online, because I think that's where we're really moving to, is the availability of online. And I'm getting ahead of myself on this, but we had somebody bring up in a meeting that chapters felt, I don't want to say embarrassed, but they didn't feel well asking for a DV to do an online event for 6 or 8 people. I went out and I asked a bunch of DVs, would they do that? So you're talking somebody who is a full professor and saying, are you willing to sit down and give a presentation to 6 or 8 folks? And the resounding answer was, yes, of course. So think about that. We look and we accept nominations for DVs June through the end of August. We screen them, we score them, we rank order them, and we select. They remain active by participating. They're strongly encouraged to do at least one DV activity a year. Some do more, but so you got 120 activities that are available. And again, especially online, that can be done. So that's our point that I really want to make. Okay, representative activities, the mega events, 24-hour, and I'm talking about 2025. That's going to be a big change from the first one of these was a couple years ago, and we went about 18 hours. And then a year ago, we said, well, can we do 24? And it went from it being a thought to being executed. Professor Hassam Fahmy was my predecessor, and he and Professor Islam worked this out and put on a pretty good event last year and a stellar event this year. Okay. Participation in virtual DV program. That's what I talked about a moment ago. Perfect for small group activities. And the neat part is, if there's a small group, you can ask pointed questions, specific questions of the DV, especially if it's online. The nice thing about online is an on-ground event can take 4 man days to execute. Day of travel, day and a half at the location, day of travel to get back. Most EVs don't have that kind of time that they can give up, but they can give up 4 hours to do a virtual event. Hour to go ahead and to prep, 2 hours for the event, and an hour post-event. So, as I said, that's something to consider. And I already showed you how to get in touch with a DV. But a caveat, contact a specific DV with a specific request. We know of 2 chapters that sent blanket Dear DV, and they sent them to 50 or so DVs at a time. Hey, Dear DV, are you interested in giving a talk to our chapter? Not the way to do it. Have a specific intent, contact the DV, and they'll work with you. If they're busy, they're busy. Many times if they're busy, they'll say, I'm busy now, but how's in a month? Come back to me in a month. Or they may refer you. And if you have any trouble with getting referrals, again, if you can't find it on the DV website, contact the DV office, send me an email, and I'll be glad to help you. And my email's at the end of this. Participation, again, it's something in the on-ground event, same as virtual, except now you've got things like a venue. And the chapter is responsible for local travel. The DV program pays the travel from the DV's home or office to the airport at your location. From that point on, you're responsible for the expenses, and then the DV program pays the expenses from your airport back to their home. There's also something else, is there's DVs who are local within a given area. And this is something from Cartagena. This is one of our more prolific DVs, Professor El-Maghrabi, and he's been known to drive 50 or 100 miles to do a presentation, and he doesn't send a bill for his mileage. He's happy to do this. This is his return on an investment that was made in him years ago that gave him the opportunity to rise to the positions that he has now. And this is one of our more prolific, Professor Anirban Sengupta, written a couple of books, full professor, signature block that's a mile long with his accomplishments. But he's willing to do something coincident with his travel and in the local area. So again, those are things. So look at in your local area whether or not there's a DV, and you have the master roster available to you. And we want to be responsive to our membership and support the Computer Society, strong outreach on the underserved. I go back to this slide, the small groups. I can tell you there's some truisms in life. If you don't ask, you don't get. For those of you who may know hockey, famous hockey player said, you miss 100% of the shots you don't take. And for those of you who understand this type of football, these guys took the shot and they're famous. So you've got to do it. And if somebody does say, I can't do it for you, go to the next one down the list. This is the DVs that are helping to put this on. We are doing this on International Volunteer Day. And look at the folks, and there's 50 plus helping to make this a success. And that's the pre-work coordination. And I'm telling you, this has got to be the longest day for Professor Islam, and a few of his folks working on this are putting in a ton of time. And this event's going to show by its success. Okay, initiating supported event. Again, determine the scope of what it is in your requirements, the venue, and what's the scope of the participation. Do you want it on ground, online? Your venue, get an agreement with the DV. If the event is virtual, online, once you have an agreement with the DV, you're home free. Get it and do it. If you need some help, you can call the chapter's office and get some help from that. But for the most part, with Zoom or for WebEx, you can do this yourself. You conduct the event. All we ask is that you provide us with a notice of a DV supported event. It's an online form. It takes about 1.5 minutes to fill out. You're going to do vTools anyway. And it also, this counts for one of your 2 technical meetings. You conduct the event, then do a post-event report. Okay, if it's going to be on location, go to our website. And it just tells you that you're going to provide us with projected costs. We're going to look at that. We'll work with you. And I really mean, we will work with you on that and figure out a way to fund that intercity travel, conduct the event. Again, vTools and notice of an event that you're going to have it, and then the post-event report. Not very hard. Hey, some suggestions? Review the outline, go to the website, determine your requirements, see if they're within our guidelines. DV program is not meant for underwriting speakers at conferences. That we're here to do something for our membership. If a conference is taken coincidentally in a location, but you can do that. But it's not to be the primary focus of the request. When we look to maximize the utility of the DV's time, again, I said that's a precious commodity, and the Computer Society's funding. Back to Islam, Professor Islam, ACA is available for help. These are the guys who really understand social networking, and they have shown that with regard to the social network awareness for this event. They're there to help and to share, and they're willing to do that. Talk to the chapter's office for information pamphlets, membership kits, maybe even some swag. But I'm telling you that the amount of giveaways, or what we call swag, they're little luggage tags. We need to get those guys to get going and really come up with something good. And develop something like a photo plan for post-event reporting. I'm going to show you a post-event report in a moment. And have a great and successful event. Get quotes from attendees, take photos. Complete the post-event report. Let us know. We need metrics. And that's a great lead into a post-event report of a highly successful visit. You heard Valdir a little bit ago talk about the road trip to Brazil. This is one of the chapters. It's Region 9, Brasilia. That's the chapter chair. She was the action officer. That's the DV. There's the time. Turned out to be a bit more than that. The topic. And then what happened? Okay, discussion on topic, providing attendees with information on that, but there was more. And that's what I say about the nice thing of our DV program, why we call us visitors. Okay, presentation, 2 hours, focus. I can tell you 2 hours at 9 o'clock at night, that was something. I'm sorry, 5 o'clock in the afternoon. The next one was at 9 o'clock at night in Moringa. Session was highly interactive. This is what they wrote. There was an informal dinner. There were a couple of strategy meetings. There was a roundtable discussion. There was some interest with students. There's a picture of those guys. And we also ask you to tell us, what do you think are going to be the hot topics for next year? For this year, for 2025, we're focusing on AI, quantum, post-quantum computing, emerging trends in cybersecurity. I mean, those are going to be probably there forever. And you'll find that in this event, you have most of those topics covered. They are the hot events. Again, what we do, we deliver opportunity. We promote computer society value, and we recognize and honor DVs. And again, outreach, especially to the underserved. That's my email address. That's all I got. And any questions?
Thank you so much, Dr. George, for this wonderful presentation. And we would love to hear any questions. All right.
I got away with no questions.
Ah, you won. Okay, so thank you again for this insightful presentation.
The pleasure was mine.
Thank you so much. And now maybe we move for our next session.
Yes, thank you, Muhammad, for great moderation and valuable participation. Truly appreciate your support. Thank you.
Thank you.
So I would like to introduce our last speaker today, Dr. Mayak Chang. Is a full professor in the School of Computing and Information Systems at Athabasca University, Canada. He has recently received Distinguished Researcher Award from Asia Pacific Society in Computers and Education. Dr. Chang has given more than 135 talks and lectures in different events. He also has co-authored more than 240 book chapters, journals, and international conference papers. He's an IEEE member since 1996. Dr. Chang is currently the chair of the IEEE Technical Community of Learning Technology, as well as the editor-in-chief of Educational Technology and Society, which is indexed by Web of Science, Social Science Citation. In addition, he is also the editor-in-chief of the International Journal of Distance Education Technologies and the Bulletin of Technical Committee for Learning Technology. Both are open access publication. Is now Vice President of International Association of Smart Learning Environment, Executive Committee member of Asia Pacific Society for Computers Education, IEEE Computer Society Technical and Conference Activity Board, Global Chinese Society for Computing in Education, many different roles and activities. In the last 2 decades, Dr. Chang research direction are data analytics, service, and game-based learning. His data analytics research focus on the design of algorithms and methodologies for item generation, learning activity generation, behavior pattern extraction from sequential data, and preference prediction and recommendation service. In addition to that, He's, of course, distinguished visitor, and we are honored to have you, and the floor is yours, please.
Thank you so much for the introduction. And before I start, I just want to give everyone a heads up because right now I'm in travel and I'm using my iPhone as a hotspot. And according to the rumor, it will disconnect every 20 minutes or something like that. So in that case, please take a break for 1 minute and I will come back. Okay.
No problem.
So let me share my screen. I believe right now you can see my screen already. Okay, so thank you so much once again for attending this talk. So in this talk, I'm going to talk about a kind of counter-generative AI approach we have done, which is called authorship forensics. And you know, due to we have ChatGPT coming out, the era of generative AI is also here. There are many key challenges and risks we do have when we use large language model, especially in education. For example, students, they may rely on generative AI too much. They just give a generative AI a question, like an assignments question or an exercise that the teachers ask them do, and then get the feedback and then submit as their assignment. So basically, they don't think. So in that case, they may not really apply what they have learned in the classroom or in a course. And that is not really, really good. On the other hand, just like me, although I'm living in Canada, actually I cannot really speak in French. So in that case, how about a students who trying to use generative AI to create a kind of result which is higher quality than what they can, and then provide it to their teachers. So that is something you can consider a little bit of cheating, or you can consider that is not really reflect what you really know or what you really can do. Okay, despite of ChatGPT or generative AI, actually before that, people they already trying to, hire some ghostwriter to help them to do the homework and assignment. But now, the problem is you can pay less to do that. You only pay a little bit, so you can actually hire ChatGPT to help you to do your homework. So in that case, when you consider that it is not just about cheating, sometimes it will be a plagiarism because the content the GPT or generative AI or any large language model provide you, they don't give you the citation. So which means you may reuse a paragraph or several sentences at once that belongs to others. So what is the problem? The problem is teachers or human beings may have a difficulty to distinguish whether or not a work is done by human or generative AI. So, can we differentiate AI written test? So that is what we want to ask. Actually, many people, they started doing this kind of research. So for example, a group of researchers, they trying to collect 24,000 questions and their responses from the internet, from the well-known like Stack Overflow and other question answering bank. And also they create some responses by using ChatGPT. Then they provide this kind of data to human expert and ask them whether or not this question and their answers are generated by human or GPT. On the other hand, they ask 17 volunteers eight of them actually they are considered frequent users of ChatGPT, and 9 they don't. So in that case, when you present a pair of question and response and ask them, do you think this response is written by human or by GPT? Actually, in overall, only 63% accuracy rate, which means only 63% when people they identify this is written by human, this response is written by GPT, actually only 63% they are correct. But if you are a ChatGPT frequent users, actually you got 81% accuracy, which means 80% of the content actually you are guessing right. So another data set created by another group of researchers, they're trying to choose the paper abstract from high impact of journals. And then they also generate 50 abstracts by GPT based on the paper title and the journal names. So in that case, they actually ask human reviewers to guess whether or not these 25 abstracts are done by human or are done by GPT. So at the end, the precision rate is 82%. So what that mean? So remember, when we are guessing things, actually we have several things to be considered. The first one is this abstract is written by GPT or generative AI, and your guess is also if this piece of work is done by generative AI, then that is true positive. On the other hand, if this piece of work is done by human, however, you misconsider or misguess that this one is done by GPT or generative AI, then that is false positive. So in that case, if you do this false positive result, then that means you incorrectly labeling human written text as GPT written or generative AI written, which actually lead to a human writer that falsely accused by you, saying that your work is not done by you, but done by generative AI. So that's these two cells, true positive and false positive, that is we call precision. On the other hand, if we consider the false negative, means that when you GPT or generative AI to generate a piece of work, but you cannot tell, you still consider that it is done by human, then that is false negative, which means you can consider students use generative AI to create their homework and submit it to teacher, and the teacher consider this is done by the student. So he or she marks the assignment and give the students high marks. That is a kind of someone get a loose, and even if he or she is cheating, you don't catch that. So that is what we call recall. So consider you are the system. Which one you think is more important? Do you think false positive is more important? Means that you don't want to false accuse anyone, or you think false negative is important, which means you consider you don't want anyone to be uncaught, and if they are doing bad things, or you consider both are equally important. So that is something in this kind of research you will always see precision, recall, and also, as I said earlier, that is what we call F value. So F value, usually 1 means you consider precision and recall, they are equally important. F 0.5 means you may think the precision is more important than recall. On the other hand, F2 means you consider recall is more important than precision. Once again, precision means that you emphasize to not falsely accuse someone. On the other hand, recall means you consider to not let anyone doing bad things to be uncaught. So they are both important, but which one is more important to you? So when we have an old saying, actually we have an old saying says, whoever hung the bell on the tiger's neck must untie it. So you all know that the most famous generative AI or large language model right now we know is so-called GPT 3.5, GPT-4, that is ChatGPT. And who created them? Actually, it's OpenAI, right? So OpenAI is who hung the bell on tiger's neck. So can it untie it? So actually, they do have a blog saying that a new AI classifier for indicating AI written tasks they have done. So they announced and launched this classifier to train to distinguish between AI written and human written tasks. So in this case, they say that unfortunately, our classifier is not fully reliable. Why? Because they say we can correctly identify 26% AI written test, which is true positive. You still remember as AI written. So only 26% AI written test will be considered as AI written. On the other hand, we incorrectly labeling human written test AI written for 9%, which is false positive. So in that case, they don't give you other major like a false negative or a true negative. So you cannot really calculate the whole accuracy, or we call something like F1 or F2 or recall rate. However, we can still consider that we can calculate the precision here. But before I show you the precision rate here, they announced this on January 31st, 2023. Unfortunately, they also announced as of July 20, 2023, the AI classifier is no longer available due to its low rate of accuracy. So what is low rate means? The low rate means if we consider, because we only have true positive and false positive, so we can try to calculate something. So in that case, the precision rate is about 74%. So actually 74%, we may not really consider they are quite reliable. So that is why OpenAI actually at the end dismissed this AI classifier. We also have other researchers, they are keeping doing this. Remember, large language model is not a new thing. You know ChatGPT, you know GPT, you know generative AI due to the successful announcement and the promotion of ChatGPT or GPT 3.5 or GPT-3. But actually, before that, we already have something like a GPT-2, GPT-1, and we also have other large language model, but they are not really caught any attention to general public. So you can see that since 2019, actually, people, they are already doing, using different way to do the test detection research. So for example, the logistic regression, which is using statistical methodology, they can try to get a 93% accuracy rate for 40 words test. On the other hand, another kind of classifier, which is based on BERT, which is a Roberta classifier, they actually can close to 95% for the GPT-2 XL large language model. And other researchers, they can also reach, for example, like 87% for the precision and recall, the equally important result at the sentence level. On the other hand, for the raw test, that is 81% accuracy rate. On the other hand, for the Robota model, they can reach to 98.78% at the sentence level, but for the raw information, I mean, for the whole information, actually only 88%. That this is very common to be seen. You probably will consider, if I have 98% accuracy, or you say F1 value at the sentence level, I should be able to identify the raw test better, right? But actually, most of the research will show you that this kind of situation, which is higher at the sentence level, but lower in the whole test. So that is something when we're doing this kind of research, you may see these kind of things happen. So there is one very, very important and quite amazing research in this area, which is done by another group of researchers. They use a data set which include 64 articles published in Science. And then they generate another 128 examples by using ChatGPT 3.5 and 4. So basically, when they are generating, they are not generating the whole article. So they are using the article abstract. This is one more thing I would like to remind you. Most of the research in this kind of test detection research field, they are using abstract, which is like 100 words, 40 words, 100 words, 150 words, and so on, for doing this kind of research. They are not really doing the test detection for like an 8,000 words article or something like that. Why not? I probably will consider one thing is about the time. The other one is the other thing is you just saw that most of the research at the sentence level, they will have a higher accuracy rate than the paragraph or the whole text level. So if in that case, if you have a larger piece of work, then maybe the result will be not so good. So right now, most of the research in this area, they are using abstract from 40 words to 150 words or 200 words, something like that. So what do? They have a list of 128 example and 64 article abstract. They provide the list to a human, and the human will read those articles coming from real human being or from GPT. And then the human expert will try to find the features. So the humans features can have 20 or 40 or 30 depending on them, but at the end they find 20 features which they consider very important when you identify whether or not this piece of work is done by human or done by GPT. Okay, so when they have these 20 features, they're trying to train a model with these 20 features, so the model can identify the articles written by GPT or human better. So when they are doing the test, they use 30 chosen article and 60 ChatGPT written example to do the test. And what did they get? 99% accuracy. So that is something you can see this from newspaper. So news reporter and newspapers, they say, wow, yes, we can now identify what is done by human, what is done by generative AI or large language model. Very good, 99%. Actually, I need to tell you, the accuracy rate in this paper is not 99%. In this paper, actually, the accuracy rate is 100%. But even in this paper, the abstract, the authors write still say higher than 99%. So they are not saying 100%, but actually in the data you see in the paper, that is 99%. Sorry, 100%. Okay, so this is 100%. Do you still need to do any research? Actually, you do. Actually, when you see this research, you need to consider one very important thing or two. The first one is the 20 feature is done by human. So how much time the human expert needed to spend to identify these 20 features from 100 or 200 article abstract written by human and generative AI or large language model? 1 hour, 2 hour, 3 hour? You think that you can consider if you are the human expert, I provide you 100 or 200 articles abstract and ask you to identify the 20 features that you may see from different authors. How much time you may need to spend? The second thing I want to ask you is, so I give you 20 abstracts published in Science. Can it be also used in another area, let's say healthcare, or chemistry, or computing, education? So these 20 features, can these 20 features be expanded and used in other area or even for other articles published in Science? So there are two questions you can see from this introduction. And actually the same group of authors, they also noticed that. So later they have another paper. You can see this is from 2023. So they also published another paper about 2 months or 3 months later. They use 100 chosen paper from 10 chemical journal. So earlier they do the 64 articles abstract from Science journal, and the chemical can be considered a kind of science, right? So this time they use 100 chosen papers abstract from the chemical journals, and then they use the same 20 feature without human read them again. And what is the result? You can see. Actually, the result become
Is it my device, Islam?
okay, I'm coming back. Let me see if I
Okay.
can Resharing.
Oh, yeah.
Okay, so just like as I say, really 20 minutes. So that is another, that is also kind of a real situation for iPhone to be the personal hotspot. But anyway, so I just wanted to let you know from this this kind of a situation, you can see that this is why we need to do research on this part, because you cannot afford to have a human being to keep reading everything and summarize the new features and then train the model based on that features and do 100 or higher than 99% detection, right? So in that case, this is we are jumping in. We say, can we have a better way to train the computer to differentiate AI written text? Counter generative AI technology, authorship forensic. So we are considered to use statistical natural language processing plus CNN, convolutional neural networks. Many of you may be expert in machine learning, so you probably will say, what? We are doing natural language processing, generative AI, but now you use CNN. CNN usually is used in image recognition. But we are doing test, written test, how they are connected to each other. Yes, that is what we are considered. So when we are doing this research, we don't consider the content you are writing. We are thinking, how about your style? Many people, they do have their writing style. So in that case, perhaps we can use so-called part of speech tag to do the things. So in order to making sure everyone is on the same page, you just want you to know that n-gram could be 1 gram, 2 gram, 3 gram, or you can call unigram, bigram, trigram, and quadrigram. And usually 1 gram is a word. So for example, learning outcome, that will be a bigram, that is 2 gram. And the computers in education, that will be trigram, which is 3 gram. So when we have these words, usually you know we have so-called verb, noun, adjective, and so on. So actually, no, depending on a word's location and the context, it can have a different part of speech tag. And also when you consider at 1 gram, unigram level, we have 36 part of speech tag. So usually we only know verb, noun, adjective, and so on, right? But actually they have 36 different part of speech tag for even unigram. So in that case, when we have 4 gram, that will become millions of part of speech tag combination. So our first stage is trying to consider, because people, when they are talking, actually some people, they will have a favorite words and they will use those favorite words much often than others. So in that case, could we also consider when people, they are writing, they may also have their preferred phrase or wording or sentence they will always try to use. So that is something we consider. If you are trying to always using similar way to write, for example, some people, they like to use a lot of noun composition. So noun and noun and noun and noun. And some people, they may like to use adjective noun, and so on. So in that case, if we trying to find your learning style based on the part of speech tag, then we don't need to know what you are really talking in your writing. We don't need to care about the content or context that what you write for. We only need to see what kind of part of speech tag you are using. So in that case, take a look at the list. You can see left-hand side and the right-hand side, actually, they are belonging to two documents written by different authors. And you can see actually document 0 using a lot of determiner singular noun. And then second, it's using a lot of plural noun. And then third, it's using a lot of singular noun plus a kind of conjunction. On the other hand, document 28 actually using a lot of plural noun, different from the document 0 authors. And then the second and the third, actually, he or she likes to use a lot of adjective. So see, if we know this, can we try to find your fingerprint? But due to we need to find the fingerprint, we need to making sure everyone's fingerprint is sorted based on the same order of part of speech tag distribution. So that is why we try to learn from 22,000 long abstract from DVPedia, which is a kind of database of Wikipedia. And then we can try to identify top 15, top 50, or even top 100 part of speech tag combination. If we do so, we can put the combination as the x-axis. So everyone's x-axis is the same. However, you can see document 0 and the document 28, you can see they have a different fingerprint. That is what we say. How about let's use CNN, convolutional neural networks, to recognize your fingerprint. So we use convolutional neural networks trying to identify your fingerprint because it has already been proved very good in terms of image recognition. So what are the performance of our trained model? So we trying to do these two things. We train the models with 2 class, 3 class. So 2 class means our model can identify human and ChatGPT writer's test. And the 3 class model means we can identify human, ChatGPT 3.5, ChatGPT false writing test. And how much time we need to train the model? 56 seconds. So only 52.82 we can train a 2 class model. And even within 1 minute, we can actually achieve the precision rate 96.82%. On the other hand, for the 3 class, we needed to train 7 minutes and 26.076 seconds. And we can get the precision rate 98%. So you need to think of that. We don't need a human being to help us to identify features because we use your written part of speech tag as your feature. And the second, we only require the 56 seconds or 7 minutes to train a model. By the way, this training, they are using CPU. They are not using a GPU because I'm not a favor GPU favor person because I don't want to pay. So I consider to have our research always to be efficient and with the general CPU. So these results are done in a laptop without using GPU. Of course, due to this result is done on the laptop, which means when you put this in virtual machine, like the cloud, Google Cloud, Oracle Cloud, or Microsoft Azure, or AWS, actually you will spend longer time because virtual machine's CPU actually is not so good like your laptop. So the time will be increasing for sure. On the other hand, we also trying to analyze the size difference. So with the same data size, we use 80-20% ratio, or 70-30% ratio, or 60 or 40% ratio. Actually, we found that we only need to use 60 and 40% ratio. So which means we have 636 data, and using 60% as training, that is 381. Among these 381, we actually also divide another 38 for validation to decide whether or not our training should stop. So you can consider that the neural networks, they will read and see 343 tasks and use them to train the model. Every time when they train the model for certain apple, it will use the 38 tasks to do the validation to decide whether or not we still need to train another 10 apple or something like that. And the other 240 tests, computer never seen before. So that is the other 240 data actually will be used for the testing. So computer never seen those data before. So you can see that this is our performance. So I try to list everyone's performance, but as you know that some research, they will not provide you every data. So as long as they provided their F1 value or other things, we were trying to compare with them. So you can see that from the precision point of view, we consider precision point of view due to we don't want to force accuse anyone. So basically, when people, they are being identified saying that your work is done by GPT or generative AI, that is done by generative AI. So only 2% or only 3% of people, they may be wrongly identified to use generative AI. So we don't care. We consider that skipping or allow people to skip or not caught by our system is okay, because we don't want to we just don't want to see people they are using but try to cheating, but they are identified, so we can say, okay, these 98 people, they are really cheating. On the other hand, if we consider both of recall and the precision, but we consider precision value is more important, that is 96 and 95. And if we consider recall rate is more important, then this is from both. If we consider balance, F1 value will be 94 and 93 compared to others, their report. So of course we cannot beat 99%. But I still wanted to let you know that the 99% require human as per intervention, and those 20 features actually may not be able to be applied to other tasks or other area. In our case, we don't require human intervention, and you just need to prepare a file that's a contain the test and also label, upload, and the train will be done after half of hours. So this is what you can go. If you go to ngrandpos.vipresearch.ca, you can see this authorship forensic portal. Right now, the screenshot show you the earlier version. So right now, the new version will be even more friendly. So you can see you can enter your data set name by any name, and you can consider to train a model like 3 class, 2 class, or all, and so on. You can also setting any kind of setting configuration or number by you. So in that case, once you upload the file, you will see that your uploaded data set is being processed or pending or parsing and so on. So although the training time is about 1 minute or 7 minutes or 10 minutes, we require time to parsing the document and convert the document into a fingerprint and then train. So you will see that the document is parsing and so on. So that will take some time. That is why I ask you guys to come back like a half hours later, so you can making sure that you can see there will be a delete button, view button, and a predict button. And you can also register a free account with real email or fake email. So in that case, you can hide. You can choose to hide your data set, or you can choose to open your data set to allow people they can also use for prediction. So when you click on the view, then you can see this is the data set you provide. You provide a TXT file, and then we created the model for you because you choose to create the model 3-class model, 2-class model, and with, for example, 99.5% validation accuracy rate for stopping the training. You use 80% and 20% ratio to divide the content. So you can click any model, and then you can see all the data. All the data, they are clear to you and transparent to you. So you can always double check. For example, you can check how much time you spent. You can check what is the result, or you can even check which is incorrect prediction based on different feature. Usually, more feature will be more accurate. Less feature will be less accurate. But right now we only provide you top 50. But you know that behind the scene, actually, we can easily to change to top 100 or top 150 and so on. But we didn't do that. Right now, top 50 can give you 98%. That's I think it should be good enough. So you can click anything. For example, if you click time step spent, then you can see the time spent. So for example, here you can see that the training model top 50 requires 787 seconds. As I mentioned to you earlier, the 7 minutes is done at a laptop. So when we do these things in the virtual machines CPU, actually we spend like 11 minutes. So that is something you need to realize that the virtual machines CPU, they are not so powerful like your laptop. So you can also see that the results. So for example, you can choose a result, and then you can see that, for example, the recall rate, successful rate, and so on. Everything is right here. By the way, so consider that training a model is training a child. So if you prepare 10 books and present to 10 children, do you believe all the 10 children will learn the same thing? Probably not, right? Because everyone will read and digest different kind of information. So in that case, we are considered to do several things. So we consider to maybe train a lot of model, like 10 models, and then trying to see whether or not they are consistent, or in average, what will be their precision rate, recall rate, and so on. On the other hand, consider if you have 10 models, each of them, they will provide you their feedback saying, this piece of work is done by human. No. This one is done by GPT 3.5. Oh, no. This one is done by GPT 3.4. And in that case, can you form a judge panel? So maybe you can say majority decision will be considered the correct one. Will that make things even better? Because every model is a human, you can consider a virtual human being. They have their own judgment. And do you believe majority, like 80 or 70% of what they say will be the case, whether or not this piece of work is done by human or done by computer? So you can consider that. Also, we are trying right now. We are trying to do is we have at least 636 arbitrary data set. So we also want to test this 636 arbitrary to the existing online AI content detector and see how effective or whether or not our approach is better than any of them or all of them. Also, we want to use the train model to test the existing data set. For example, as you still remember the earlier group of authors, of researchers, they trying to have 64 articles and 128 examples from GPT, and also 50 abstracts from 5 journals and 50 ChatGPT generated abstracts, and so on. Can we use our train model to correctly predict the loss outside of our scope? Because you know this is coming from science. This is coming from the high impact of journal. So, and this one actually is from Q&A. Could we try to test them and see how adaptive our approach and the train model can survive with other data set? Right now, we are also doing the new data set. So we do have a kind of survey link, which if you want to join, the first 50% will get 20 or 25 Canadian dollars Amazon gift card, which you can use anywhere. So in any case, if you are interested to help us to create a very simple data set, we will ask you 7 questions. And for each question, we will say, please write down 150 words. For example, do you have any complaint want to give to the city government or something like that? So in that case, we can see how about the content from general public in the common domain, not a science or chemical or any academic domain, where this kind of content can still be identified easily. So that is what we want to do. And right now you can see we're trying to train the model with ChatGPT generated content. But how about Gemini? How about other other generative AI tools generated content? Can we also do the same? Or can we train the model for them? So that is our next step. So in any way, I hope this counter-generative AI things is useful for everyone, and our research is always my research is always open access, so you can always try to use them without paying anything. And even when they are required registration, you only need to use a real or fake email address to register, and then you can use. The only negative things to use fake email address is when you forget your password, you may need to create another account with another fake email address. But if that is okay for you, then that is totally fine. So no worry about that. And we don't record anything. So basically, that is what our research is done. And if in any case, if you are interested, please trying to get on our authorship forensic research. And thank you so much. And I'm taking question if there is any. I know it is very late.
Thank you so much for the great presentation and very interesting topic. So I may just ask if there is any question.
If you have any question, you can always write me an email. That is also fine. And in any case, if you want to try this portal, then I put the link in the chat, so you can go to that portal and click on authorship forensics, and then you can try by yourself. Of course, the data you need to prepare as a test file, which is a TTL format. So you can just put in the bracket for the author, bracket for the content. That is everything you need to do.
Thank you so much. But I just have one quick question. What about doing the same research for different maybe scopes or different topics? So do you think that we can?
Yeah. Right now in our authorship forensic, the 636 abstract, different from others, we actually have the abstract content from different domain, including healthcare, computers in education, mobile computing, and so on. So basically, when we train the model, actually they are already interdisciplinary things. But one thing, actually, you need to know that our authorship forensic research, the goal actually is not to identify whether or not the assignment is written by student. Actually, our goal is, can we in the future, when you receive a threat, life threat notes, and then police officer can put that notes, the content, to find the fingerprint of the writer, and maybe, because on the Facebook, social media, Twitters, people they post. So if we use those small words like 200 words or 100 words, we can also find their fingerprint. So maybe police officer, they can say, oh, actually your life-threatening notes you receive actually is written by Micah, because the fingerprint is matching Micah on the Facebook. So you can see 2-class model, 3-class model. How about all model? So our goal is all model, which means we can identify individual of the author. But in this research, we didn't do that due to a very simple reason. We are using academic paper abstract. And most of academic paper, they are written in group. So which means the writing, although they are coming from human, they are coming from different human. So that will become a kind of a mixing fingerprints, but they are still human beings fingerprint, so we can still identify them, but we cannot identify a specific author. But how about maybe Facebook? Facebook could. Everyone post by themselves. So if we use Facebook's posting or Twitter's posting, then perhaps we can try to identify individual Twitter poster based on their fingerprint.
Yes, that's very interesting topic.
Yeah.
So thank you so much for sharing your thoughts and the great presentation.
Thank you so much for having me.
Participation.
Yeah, thanks.
So
thanks
now,
a lot.
I know this our last session. If you like to join us, George, for closing this event and this long day. For the time being, we have very long day. It's almost 24 hours now. We started it's 3 a.m. here in Cairo, Egypt, and I don't know what time is it, but I can just maybe close with some of our videos from the opening session and from other things. So thank you for your support. Thank you for being here, and look forward to seeing you next year, maybe in the hyper 24-hour event. Thank you so much for participation.
Congratulations to have this event successfully done. I choose this, I pick up this last session. So.
Thank you.
Good morning, good afternoon, good evening, and good night. A greeting adapted from the movie The Truman Show, starring Jim Carrey. And it works here since to each of you there is some relevance in that greeting. And hello, Kuala Lumpur, Sapporo, San Francisco, Wilkes-Barre, Thule, Dublin, Bruges, Cairo, and Mumbai. I'm George Proler, Chair of the Computer Society Distinguished Visitor Program, and it is my honor and privilege to welcome you to this, our second annual IEEE CS EXA DVP event, or as we call it, the 24-hour event. Second annual has a nice sound to it. At the beginning of last year, hosting such an event was just a thought. To extend an earlier project to cover an entire day, 24 hours of presentations, reaching and including our diverse membership. And quite frankly, we weren't sure if we could put it together. But Professor Hassam Fahmy, my predecessor, and Professor Islam Halim, chair of the Awareness and Customer Advocacy Committee, and his team rose to the challenge. And we did it. And it was successful. The first annual. And now, well, Professor Islam and his team have outdone themselves. Look at the agenda for the next 24 hours. Artificial intelligence, AI security and privacy, and research ethics in the area of AI. Quantum computing and the quantum world, smart and high-performance computing, and the list goes on. And we are already working on the planning for the third annual event for next year, taking another step and upping the challenge for Professor Islam and his team, as we are looking to make this a hybrid event with on-ground activities concurrent and shared with the online participants and attendees. This event spans each of IEEE's 10 regions and the world's time zones, hence my adapted greeting, since each of you and the DVs, the presenters, the moderators, you all hail from different and diverse regions. And for some of you, it's 10 a.m., 2 p.m., 8 p.m., and 2 a.m., and all the hours in between. So it is morning, afternoon, evening, and night. Truly an effort of inclusion of our diverse membership base. Today is International Volunteers Day, which is fitting, since it has taken, and before this day is through, it will take the efforts of more than 50 Computer Society volunteers coming together from the Geographic Activities Committee, Students and Young Professional Activities Committee, and the Distinguished Visitor Program to bring this event to you. Over the next 24 hours, you will have the opportunity to attend more than 20 technical presentations on topics I've already mentioned, along with informational talks about the Computer Society and its regions, activities, and programs. Each presentation will be introduced by an event moderator who are members of various student chapters, and through participation in this event are gaining experience and opportunity. And then there is the audience. That's you. Many of you are members and affiliates of the Computer Society, who volunteer your efforts to make local programs a reality. And all are here allowing us to bring this event to you. So thank you for your time. And now, before I wear out my welcome, I'd like to pass the baton to Professor Ironori Washizaki, the President-elect of the Computer Society. Thank you.
The IEEE Computer Society's Distinguished Visitors Program delivers tools for individuals at all stages of their professional careers through visits to chapters, offering opportunities for individual interaction, and to the membership through webinars by respected professionals. We have distinguished visitors who cover machine learning, cybersecurity, robotics, big data, cloud computing, blockchain, and cryptography, among others. Chapters can request a distinguished visitor on computer.org/distinguished-visitors. The Computer Society pays intercity travel, while chapters are responsible for all costs with regard to the hosting of the distinguished visitor, such as lodging, transportation, and food and incidentals in the city of the presentation. The Distinguished Visitors Program is able to pay up to $1,000 for a visit to a chapter, but by working with other nearby chapters to develop a tour, that amount can be increased. So when your chapter is planning its next event, think of the Distinguished Visitors Program.
Hi, I'm David Allen Greer, the IEEE Computer Society President for 2013. And I'm here to talk about the community of professionals that you join when you become part of the IEEE Computer Society. Usually when we talk about the benefits of joining the society, we talk about those things that you see flashing over my shoulder right now. We talk about the digital library. We talk about standards, periodicals, continuing education materials. Those are all benefits, to be sure, very real benefits. But people will say, I get the digital library at work, so I don't need to be a member. Or I get periodicals in other ways, so I don't need to be a member. I have exactly one standard I ever use. I already own it, so I don't need to be a member. Those arguments have some truth in them, but they miss out the point that you are investing in your professional career by being a member of the Computer Society. You're joining a community of people who, for over 60 years, have worked to advance this wonderful technology that has quite literally changed the world. And when you join them, all you do is need to make one connection a year, and that will be an investment in your career, in how to be a professional, how to see where the community is going, what are the new trends, how you should behave yourself, how you should think as a professional computer scientist, computer engineer, software engineer, or other information professional. These are the benefits. These are the real benefits. You're investing in yourself when you join, because it's through these connections that you really learn to be a professional. Information, you can get that on the internet. Professionalism, you get that from the IEEE Computer Society. We have a web page below that you can click on to renew your membership. Thanks for listening. Take care.
Hello everyone, I'm Shema, an ambitious computer science engineering student and a proud member of IEEE Computer Society. I think that the journey with IEEE Computer Society has grown me in many benefits, countless benefits, personally and professionally. This is why I believe that it is important to speak with others so they too can experience the same. So let's explore how it has really as newcomers to computer science and engineering. When I was a first year engineering student, I felt completely overwhelmed and I didn't know where to begin. There were countless tutorials on YouTube and the volume of information left me confused. I didn't know which courses or fields to focus on. I realized when I discovered the IEEE Computer Society, everything has changed. Now, I'd like to offer a brief glimpse in the IEEE Computer Society chapter rules, focusing on the key elements that have influenced my journey. Really, I think it is the privilege that my journey as student has been treated by the IEEE Computer Society. It has opened doors to opportunities that most times happen in life, but also fueled my personal journey. I can't overstate this transformative experience has been. I strongly encourage all of you to seize the amazing opportunities that this community offers. So, don't miss out.
Well, thank you so much for all of you. Thank you, George. Thank you for all our participants, speakers, volunteers today. And this is our last word. Thank you.